All right. Hello, everyone, and welcome to my stream today. Oh, wait. Sorry, running a bit late. It's funny, I was planning to do some stuff this morning, and instead, I ended up responding to a post on X. Pretty typical of me. But you know how it is. Why don't you guys all come and say hi in the chat? We get this thing started today. All right, here we go. All right. Sorry, I'm still just like organizing windows and stuff because I was like literally just rushing to get stuff set up. I actually have a new. You remember last couple streams I was complaining about like how the sorry about that, lost the mic. I was complaining about how let me see here. Yeah, I was complaining about basically how my screen kept on flickering. Well, I got a new setup, so I had to set that up also before I got started today. Yeah. All right. I think we're doing a little bit better here. Sorry for the thing. I've been kind of scatterbrained. You know that meme with the guy with the papers on the walls and the like conspiracy theory. I felt a bit like that this week as I've been working through stuff. It's been a very different time for me. I've been using AI tools for the first time ever, like a lot, and I'm going to talk about that a bit today, um, because it's a very interesting experience. And as I said, I should have probably been more prepared, but you know, we're here now, so that's how things are. Okay, let me get stuff in a reasonable place here. Okay, so then we go here. Yeah. Hello, everyone. Yeah. No, I guess everyone's had a chance. I'm gonna pull up Twitch here too for a sec because make sure I don't miss anything on there as well. Good, 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 good. I have not given this async talk a thought since the last time I popped into your stream talking about this. I think it was when you first started talking about it. How's it progressing? Well, it's interesting, and I think I found the right way to frame it. I posted some examples this week, which are a lot of the same examples, but I thought what would be fun, and one of the ways we could start it, and I'm hoping to get some participation here from chat today, is what if we start with something? I know I've said this before, but I want to do it today. What if we started with something synchronous, like an example that's synchronous, and then we're like, okay, let's make this async, and actually kind of like work through what that process actually looks through, because that's been like my primary design vision here. I know that's not how things usually start. You usually actually start with like knowing like, hey, this is coming from a database or whatever. But there's a certain place you reach when you take a design ethos of like basically like I don't want my code to change if I go from synchronous to asynchronous. Whether that's the right one, but there's something really nice about that from the perspective of reactivity in UI, because the whole benefit of having a declarative system is generally that you can just look at it and understand what the behavior should be. Like you go, okay, I'm seeing this relationship in front of me. It doesn't really matter how it gets there in theory. I mean, in practice, we know because of performance and stuff, it does matter. But like in theory, you should just be able to be like, these things are related. When this updates, this updates. And the way we do this is through synchronous guarantees, essentially in UI frameworks, so things don't tear, don't happen unpredictably. Most solutions don't account for async, and that's a hole. It's one that most framework authors are very aware of at this point. And I think that's why coming at this perspective of like, I don't want the code to change is actually useful, which is hilarious on a complete other tangent when, you know, I keep on seeing these like Theo take, you know, like because the AI stuff, I started watching a lot of his videos again, and that whole like React the last framework thing came up yet again, and talking about like how the React compiler was a way for code not to change. And it's funny that like there are certain things that are lending to us trying to reduce code changing, but I think it's for completely different reasons, and we have to be careful not to correlate this too much. I mean, don't get me wrong. Quite often with trends in technology, it's because similar benefiting things happen at the same time, even if they're unrelated. And then that creates a movement, like, single page apps coming out at the same time as microservices. Like there is a coordination aspect of it, but it isn't always causal. Like it's not always that one causes the other. Anyway, just a thought. Maybe we'll get into that in a bit. But here's the bass guitar. Yeah, I took it down off the wall and replaced it with my Music Man, the little silver. That one's like the pop punk guitar, I'd call it. I actually swapped out the pickup, which I feel kind of dumb now because Music Man have these active pickups that are actually kind of nice, but I ended up swapping it out for like basically the Tom DeLonge pickup at some point. I don't know why. It was like after my main pop punk phase. I was already in kind of like a hardcore band at that point, but like we decided to just make that like the Blink 182 guitar, even though technically Tom doesn't play like a Music Man. They have an interesting sound. They're kind of tighter. They're almost like a Telecaster, even though they look like a Strat. Anyways, aside. Yeah, I mean, it's not about better. It's about, yeah. I think this is the whole thing. I have to be able to show it for people to really appreciate it, and that's why talking about it isn't enough. That's why I wanted to do the stream today, right? There's a couple really big realizations I came to while I was working on this. Some about on the nature of like optimistic data and optimistic UI and like where that fits, and the other thing is just sync versus async. So yeah, we probably should get into this here. Yeah. Not real exactly. They're not necessarily like, you can see how they're complementary and you can see how the timing worked out really well, but it's not like one caused the other. Yeah, sorry. Let me see here. I'm just trying to get myself oriented. I'm not bad. You're just I mean, I think I'm gonna push this out later, or we'll talk about later. But yeah, Ben Davis, some of you know, Theo's content manager, also does content himself. Big Svelte fan. Made some comments suggesting that maybe reactivity, signals-based reactivity didn't scale as well as React did. And I had to respond. I really didn't have a choice, unfortunately, which meant I didn't get to do what I wanted to do the last hour before my stream. And instead I was responding to him. I have this kind of compulsive nature when it comes to things that don't fit within my worldview. Which is a funny other thing, because I'm starting, is it weird to think of AI models as a certain personality type? This is just completely a crazy aside. It's just when I work with tools, when I work with things and people, I need to figure out a way to model or categorize them. That's just how I function. If people have any doubts anymore and familiar with Myers-Briggs, I'm an INTJ. Like essentially, yeah, sorry, that's a whole other tangent. Maybe we'll get to that. Okay, yeah, let's talk about my general positioning. Yeah, let me eat Scaladraw here for a second, and then we can get into it. Because when I say async, you're like, well, I have async in my framework. Well, I've been doing this for a while, right? Like, this is not new, right? Yes and no. So, and I think this is important to frame at least as we get started here. So let me see if I can share my screen. Actually, I have to share my screen first. It's been so long, I wonder if it's going to make me like go through the whole song and dance again. We want to share this one. Thank God it doesn't. Okay, cool. So let me kind of basically rough it out. For me, I don't know why they call it Gen 0, 1, 2, 0, 1.5.1, but there's basically been three sort of buckets of how async has happened. And don't get me wrong, there's a lot of gray area in between, right? So like, let's just like draw them out here. Bucket 1 or 0, no async consideration. And then what do we have? Wait, 100%. This is too big. We should make this a medium. Yeah, there we go. No async consideration. And I'm mostly talking about data fetching. I know thing. So it's data fetching patterns we're going to focus on mostly. There's other async, but I'm going to say that like async primitive. So yeah, do this like this. I'm going to call it gen 0, no async, large is where I want to be, large, and then gen 2, async first. And as always, this is an oversimplification. People are going to complain that I'm like not 100% accurate or whatever, but this is like my how I'm looking at things right now and how I bucket things as of today. It could change. And generally speaking, we have these 3 boxes. This is visible for everyone, hopefully. Let's do that. Let's make this one a little thicker too. Okay, cool. So what do I mean by each of these? Well, let's now switch to medium. Use effect. Okay. What's another example? Fetch in event handler. I have to include the remix stuff, you know, right? Okay, which is fine. I mean, I'm not saying it's when I say no async, it's not necessarily no async. I mean async awareness by the JS framework, because I am sort of sticking RxJS in this category. RxJS is async and it handles async. It's just it's in the event. It's like it's outside of our purview. I'm not saying I'm saying like you can put RxJS into Angular or any framework and have it like handle the async for you. But from the framework's perspective, the framework is not considering async in that point. It's just getting a sequence of synchronous updates from the outside. So I say fetch an event, but async events. Okay. Then what's generation 1 primitive? Let me see. Create resource, like Solid's create resource, or Angular's creates resource. React query, like handstack query, you know, like that. Like, now don't get me wrong, some are better. Angular's resource query has improved significantly on like Solid's resource query. We had some problems with it in terms of propagation, the graph thing. Like we don't handle it exactly as ideal as we want to, but categorically in terms of solution, I think this is where it is. And I feel like I was like pretty strongly on camp 1 most of the past year. So like I just want to make sure that we understand where this sits, right? And there's a lot of solutions that kind of leapfrogged over the bounds in terms of data fetching, right? Because you guys might be like, okay, well, what about like suspense with view or whatever? I would also kind of put that in this generation 1 bucket of things. It's not no async, but it's about like async primitives. It's kind of simplest. You could say React has a solution in here, but in a sense, because they didn't release the true React solution here, this is why I was talking about whether it's 0.1 to 1 or 1 to 2. They kind of just leapfrogged over this zone, right? Svelte was similar. Svelte had basically garbage async until the new async Svelte came out. Sorry, people who like the await component, like it didn't even work properly on client and server until fairly recently. So a lot of frameworks they were ahead by going this Gen 1 zone, or React Query where like the ecosystem had to fill in the gaps. So what's Gen 2 async first? There's only 2 solutions that are released today, right? React 19, I'm just going to call it the use generation. It's transition. It's what Ricky demoed on my stream. Svelte, async, and solid 2.0's async model, right? Those are the only ones that are in this bucket. So generally speaking, today, in my opinion, most code is actually sitting in Gen 0. Reactive systems like Vue, like Angular, or that are kind of like ahead of that game, right? But then there's a new trend that kind of supersedes that trend. Does that make sense to everyone? I get it. Theo, Ben, I have a piece of Theo wrong, which makes it frustrating. Yeah, to be fair, I think it's only the last React framework, one that really kind of got to me a bit more. It's funny. I was looking up int J just to like explain it to someone, right? And I was reading here, and they're like, core int J traits: strategic and analytical. They approach life as a chessboard, constantly analyzing trends and consequences to build, improve, fixes, blah blah. Independent, driven, highly self-confident, autonomous. They are determined to master subjects that matter to them. Reserved and candid, keep them to themselves. Appear arrogant or aloof due to bluntness. Future focus. They prefer to focus on future possibilities than the past. And I think this last trait is kind of a funny one, because being future focused means you often don't even focus on the present, which means that like when people worry about future technology in the context of where things are today, I have very little empathy for them. Unfortunately, it's so like I can't help it. like I get it. Like I logically reason into it, but it's like for me, it doesn't compute. Like you can only really make decisions on the future based on like you can't keep your foot in both sides. If you're looking at the future, then think about it in terms of the future. Don't like try and constrain yourself by the stuff of today. Now, don't get me wrong. People who are practical builders need that capability. Like they need to be able to bridge that gap. And in a sense, it's a matter of scale, like how far in the future you are. But it's funny. Okay. Yeah. You know what? I could. This is. You're right. I really like this distinction. I actually think you're right. I think React 19 is actually. It's like it has the right stuff. It's just React's ecosystem and where it's sitting will not let it get to where it needs to get to. So in a sense, React 19 is like sitting on this edge where technically it is async primitives. They haven't like opened the floodgates. They probably wish they could, right? They had concurrent mode and then concurrent features, not concurrent world. And it being incredibly breaking. So in a sense, React knows exactly what it needs to do, but it can't do it. Which is an interesting argument, right? Because this is like at, again, complete odds with what, people are like, it both agrees with like Theo's React's last framework statement, but also is at complete odds with it, right? Like, because it's like, things do ossify as they get popular. I mean, that's the nature of things. But change is a constant force. We can't ignore change. So, yeah. Yeah. Why do I put React Query over here? It's because React Query recognized, even though it might not effectively, like the difference with React Query is it's like it's kind of like this one, where you're like, I can't get here, but I know exactly what I need to do. React Query, see, this is why I told you that there's some subtlety here. React Query is like this thing where it's like, I know exactly what I need to do, but I'm stuck with Gen 0 tools. Like it kind of sits over here because it does have suspense support. It was one of the earliest ones because you can like turn on suspense mode and, you know, kind of get into that zone where it's like a bit more coordinating, plays along. But the problem is like the key revelation for React Query is that async is derived. You put in a source, it participates in the graph. It's not a write. It's not more state. You know, it's not like it's derived. And that's where it differs from here. This is like one of those fundamental things that I think is like completely missing on the remix model is like everyone just keeps on like getting to this zone where they're like more states that write more states when events happen. The event model, I think the event model, and which leads to more states, becomes unwieldy after a while. I mean, there's ways to make it wieldy. Use a state machine. You know, X state's a great solution, but it's like it's kind of like the RxJS arguments. Like, do you really need it, right? And I think that if you start looking at things from a dependency graph standpoint, which is what React Query does, you actually make the bridge over to where reactive systems are. You don't have to be like truly reactive or like fine-grained reactive to be to emulate the model. In the same way, like React hooks emulate the model of fine-grained reactivity without being fine-grained, right? Like, or React compiler. So, as I said, rough categorization. I hope that makes sense. I don't know. I mean, it's interesting what people are willing to learn to be able to be effective. One of the interesting things I've been working with generators like a freaking ton recently because I think like my whole inside outside of the system thinking lens that reactivity is really good for certain types of shapes of problems, but those problems that reactivity is good for, like signals are good for, are things that contain permanence of some sort. That are declarative. And it's like, how do you represent ephemeral procedural type logic in that world, right? One way is events. Another way is sequences, essentially, generators or whatever, things kind of like that effect really specializes in. So, I mean, sure, I think there's a place for it. For me, I've been able to compartmentalize those into different zones. Yeah, tech based. Yeah. Well, it's hard though because like I'm like the farthest thing from a naysayer. Like when you go in the comments, like Theo's comments have become like toxic, where people are like, "Oh, more AI shilling, blah blah blah. AI couldn't tie its own shoes, blah blah." Like like honestly, stuff like that. I'm legitimately excited about new technology, so it's good to kind of look at this. I think when looking at new technology, we have to frame it in a zone where we can't use our current completely rely on our current, we can use our current experience and biases because that influences the way we look at the technology, but we can't look at the current technical things. We have to think in a world in which the technology isn't limited, which is hard to do because like obviously technology evolves. So and it evolves differently than the way we think it will. Often we try to learn better to kind of make a mental model. So our estimates can be way off. We can think we will have flying skateboards in 2015. Which again probably was technically true. I'm sure there's a hoverboard somewhere out there, but not going down Main Street. Okay, so because of the grayness of this area, and because of where most people sit today, which is literally over here, I kind of want this exercise to kind of ignore Gen 1 in a sense, because I kind of think that we should start from something sync and then think about how we would implement it from a Gen 0 standpoint, and then compare and contrast that to what Gen 2 looks like, right? So unfortunately, I didn't prepare my demos today, so like we might have to do a little bit of legwork here. But this is where I wanted to start because I think two demos in particular of my list. I don't know if people saw it. Let me see if I can pull it up. But I posted like a bunch of demos on X. Good. People are already reading my article. It's not even an article. I don't even have time to publish. That's the problem when I get into these burst thoughts on the HackMD. Like the spelling and the grammar is just terrible. I sometimes think like Yoda, so it's like I don't even know if anyone can read them. Okay, yeah. So I made an example here, and I'll share this in chat in case people missed this. But I dropped like a whole bunch of examples here, and to be fair, I don't think everyone like gets them all or like the impact, and it's hard because when you look at a finished example, you're like, oh yeah, obviously it should work like that, right? So like, what I want to do actually is I want to take this example, for example, and I want to let's duplicate this. I want to go in and grab like one of my React boilerplates, like probably, of course I'm not signed in. I won't be signed in with GitHub either because biometrics, and then it'll probably ask me for my authenticator app or something. Okay, no, we got through cut. I know it's all necessary, but like security these days just drives me nuts. Like I can't even publish packages now without getting prompted by npm. Like I have to like log in twice because usually my terminals sign me out by that point. And then I know workflow problem. This is me, old guy, rich fist to the stars. Not that any of that would make me do like change things. Some people are like, oh, this is why build processes are bad. Those people are idiots. But I mean, okay, it's been a while. Let's see if I have some like React 19 examples I can use a baseline. React 19 Sierpinski. Let's not use that one as a baseline. React 19. Oh yeah, React to do async 17. I built this with Ricky, but let's not do to-dos yet. We'll get to to-dos in a minute. Instead, what I'm going to do is I'm going to fork this. And I could use Solid, but we're going to use React for this demo. You guys are familiar with React, right? You could help me write some React code in case I screw it up. Let's just do like React divide, right? Well, exactly, right? To actually understand the demos, you would need to actually specify the exact behavior you want. It's way easier for us to do this in the form that I tend to do right here, which is video essentially. So let me take this example, solid divide. I love the fact, on a complete aside note, that I can, most of the time, I can almost just copy and paste solid code. Like it's not obviously exactly the same, but like you guys saw this when I used to do like the HackerMD news. Like simple basic examples translate fairly easily here. Let's just drop this in. What's the export component called? Just so I know, is it just like app or something? Function to do app, but it's a default. So it's just a default export. Yeah, I just don't remember what this template is. So export default, we'll call it app. And then let's make this React. Create signal becomes use signal, or no, use state. And then we don't need a database yet. We'll add that in a minute, but let's worry about that. And then what else do we need here? I don't need use memo. Not that I need, but I'm going to use memo just because it's easier for this translation. We'll just use memo, and then use memo takes a function, so that's the same. So then we just have to remove all the functions. Remove all the functions on n here. And then we need to remove. We will just throw n in here for now. We won't worry about this. Just making this demo synchronous. We don't need. We can make this a fragment. It's kind of bad here because I'm like undoing the work, but we just go doop, 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 and you might be like, why are you putting two fixed here? What's wrong with my use memo? Oh, right, it needs a dependency array. God, I forgot about those. Beautiful. just copy this whole thing. And then I can never remember the shortcut keys to go down a line. It's fine. I'll just do it manually. All right. What's your problem? Oh, right. We're not async. We're not async. So our divide function is literally A divided by B. Let's remove the return type. Oh, okay. Did we do it? Our button is terribly styled. I didn't even realize I had much CSS in here. Well, let's add CSS in. Okay, wow. I didn't even think that I had much styling in here, but okay. I've remade it. All right. The biggest thing I don't like when you have a full sync happening, in the moment you're adding async, the single async, your entire system becomes async too. Well, yes, but there's a question is, what part of that don't you like? Is it that you dislike having to rewrite all your code, or you dislike that async is it's like the coloration problem, like once async enters the system, you're kind of like, there's not much you can do, right? Like you're kind of yeah. Oh, actually, the divide example doesn't even have a server TS. That makes our lives even easier. I said I'd bring it back, but that server TX is from our to-do example. Okay. Okay. Yeah, I think it's important to recognize there's certain things that are fundamental, like async. Just it has an effect on everything that, like, downstream, like it, or the consistency of your whole app. Like the existence of async fundamentally changes the game. We have to acknowledge that. But should it change, like, the way you look at doing everything? Okay, so sweet. Our example works. It's a counter that divides with 2 fixed 3. And why did I do 2 fixed 3 out here? Now, did we really need to memorize each of these? Probably not. Like, they all update at the same time. This isn't like a case of like one divide comes in before the other divide. There's no timing difference. You understand, like, once you actually start getting timing differences, you probably needed a separate tracking mechanism here. But this is the basic example. Rich Harris actually kind of think came up with the multiply version of this. I chose divide because I actually wanted to kind of, like, in reality, you don't always get away with the value being nullable. So that's why I chose it. So yeah, I mean, this is a pretty easy example. The code makes a lot of sense. I think I did this right. You React developers out here, you don't see any problem with this. Yeah, I mean, there's a delay here on the divide that isn't being used, but generally speaking, I calculate a value based on divide by n by 1, 2, 3, 4, 5, and then I show it suffixed so that it aligns at least a little bit better. Otherwise, you're going to have like this going up to here and all this stuff. So, you know, a little bit of a UI consideration. Our data, we want the full values. We don't want divide to necessarily round. We just want in our UI to only show 3 levels of precision because the rest are lost on us for the user. But let's say we could use it for some downstream calculation where rounding would be bad. So now that we have our baseline, I'm like tempted, like, should I like save this or like, you know, like fork it or something? This one, I don't think we need to. I think this will be illustrated enough. How do we make this async? I really want the chat to participate. I hope we have some like versatile React developers in here because I want the best ideas. And to be fair, my only constraint here, and I know this might seem unfair, but it's for the purpose of this thing, because we've already seen Ricky come on and use React 19. I don't want to use React 19 features. I don't want to use use. I don't want everything pre-React 19 I'm okay with, I think. But like I don't want this is just your typical app. I'm using React here. Pretend it's framework N. You know what I mean? Like what or framework X. We don't care. This is your just typical. I don't care about async framework. Am I going to get participation today? I wonder. I really want someone to suggest a solution there. Slap RQ in there. Okay, so I could the divide. Sorry, you're right. Let's start with actually what I want. You're right. I didn't clearly spec it out. Our problem now is we've been working on our app and it works great, and we're like, wow, look at how smooth it is. Everything calculates. I can see it great. And someone's like, you know what? We can't synchronously calculate divide anymore. We need to get it from a server. We need to calculate it and like offload it to a web worker or something. We can't do it. So yeah, actually, you guys are right. Let's start by updating our divide, right? This is now our function, and our UI breaks immediately, right? So we have our new problem. You'd probably have a state that's set when the promise is complete. Yeah. Here, the behavior you want to take the thing. Well, yeah, exactly. But what let's think about this for a moment. What is reasonable behavior? Let's try something naive. I think the first thing, I know you guys, do you want them to be coordinated? This is a great question. I think so, but we'll get there. You could use their await component, but the await, yeah, I mean, so okay. So what I'm hearing here is, I mean, the problem is there's 5 different divides, but what I'm hearing here is we should rewrite this into something that's like there's 2 different ways we can go here. I'm gonna do what I call the simple way first, right? The simple way, like naive way of doing this, is we're going to go in here and we're going to go, okay, well, instead of being derived now, because it's async can't be derived. What we're going to do is we're going to rewrite all of these and be like, okay, let's go const a set a equals use state. All right. And we can do this a number of ways. So I feel like, do you guys feel like this is the first thing you would try? I could be wrong, but my gut is this is the first thing that most developers would try. Keep this for a second. This is why I was like tempted to fork so that we didn't we could get back to the base state. I did save that base state, and then what you could do something like, what if we made it so that like use effect, and then we could be like divide, and the use effect depends on n, right? And then we could be like divide n1, then set a. That looks pretty good. What's wrong here? All right. Promise number. Why doesn't it know that n is? Should know that n is a number, right? Number. Because I was just thinking we'd just do this a few times. Set B, set C, set D, set E. I mean, we've seen a lot of this code out in production. On a side note, as a Vue developer, you use divide composable, but what would the logic be inside your use divide composable? Does Vue have an async primitive? Or do you just throw synchronously and then the suspense boundary picks it up? Well, the rendering isn't what's triggering, it's the button press that triggers it. Oh, you're saying with this solution, well, I mean, initially you need to load the data, right? Because you can't show the initial screen, right? So like if we do this now, okay. Oh yeah, it's, do you know what it is? We need to make sure that we don't return promise void as the cleanup function. Let's fix this up. We actually want these to be like this. Did I get it? There we go. Nice. Right, I need to update my numbers. 2, 3, 4, 5. Because like the funny thing is like if I didn't actually do the first trap that we'd probably all get into, because the first trap we'd all get into is we put undefined here, and then undefined is going to crash because you can't to fix it. So I'm gonna set it to 0, but 0 isn't correct, right? Like this technically works. When I press a button, they all update randomly. That was the kind of thing. So they all come back at different times. So we'll see 5, like the 5 updates right away. So like if I make this, you know, like let's add an offset plus 400 so we can like see the difference here, and I do it, you're gonna see like 2, and then if I like kick it a few times, luckily it's I like we I wonder if I click it and the randomness is like too variable, like if instead of plus 400 I was like, let's make it random times like 2000. If I double click it, I think it's possible that we'll get a wrong number when I click it, depending on the randomness timing. This looks still fine. What if I go 1, 2, 3? Did any of these run out of order? Yeah, here we go. 6 divided by 2 equals 2. 6 divided by 3 equals 2. Ugh. Something here isn't right. Yeah. No, the UI is inconsistent. Yeah, this is kind of awkward. You can briefly get this, but it's even worse than this. Like I just showed, we can also land in the wrong state, right? So like, how do we stop that? Well, one thing we can do to stop that is we can add promise cancellation. We can add like abort controllers, right? That seems reasonable. We could, or like some kind of like cache identity with a timestamp, and then use that to cancel it. And when we first load the page, we're also showing a like a bunch of zeros and stuff like this. This is kind of terrible. So maybe we need a way of okay, let's think of this. So separate effects isn't good. Maybe what we should do is like promise all. I don't know, like we can maybe write one super effect and be like, what if we like have it depend on n, and then be like, we can just take like this logic, right? We could just be like, promise dot all divided by 1 divided by 2, 3, 4, 5, right? 1, 2, 3, 4, 5. I had one too many. And then we could be like, you can call like this const. Oh, actually, no, we're not going to do async await with it, because I mean, we could wrap it in a self-invoking function, but we're just going to then it and then take the, did I do something wrong here? Oh, right, it's an array, isn't it? And then we are going to destructure our array. And to like A1, A2, B1, C1, E1, E1, and then we can call set A, A1, set B, B1, and so on. I mean, I could probably use a for loop with an index here, although the variables aren't named with an index. Then I'd have to use string manipulation. Screw this. I'm just keeping this easy for our purposes. Set E, E1. Okay, so maybe this is a bit better, and we don't need all these effects. Clean that up a little bit. What's going on? So we're 0. Oh, and then we're good. And then when I click, we see the 2 for a bit, but like this at least feels saner. And I don't think it's possible anymore. I could be wrong, but I don't think it's possible. And I mean, it did a weird glip thing. Is it possible to get the wrong? It might be still possible to get the wrong answer if we're like really, really unlucky. Like if yeah, let me do something really fast. I mean, I'd have to click it a few times, but it's possible that if the full total amount it took to load was shorter for a later one than an earlier one, then we can still see something like 5, like the 6th of like we won't have the individual lines tear, but we might see like the completely wrong answer. Like we might see the answer for 4 when we're showing 5. Yeah, it's still possible to have them all at the same time, yes. Yeah, and it's kind of wrong while it's loading too. I mean, we could do something like add like a, yeah, I mean let's, why not? Let's do that. Let's add like a loading state, right? Const loading, set loading, we can go like use state false. I don't want to think how many times these components are re-rendering. But we could do something like set loading. I mean, we could have set it as true to begin with, but I think we should do it every time. Set loading true, and then set loading false. This seems reasonable, right? And then we could do something like, if it's loading, we can do like a ternary here or something, right? It could be like loading, otherwise fragment. Loading. Oh yeah, nice. And then let's give it dot dot dots. In fact, you know what? Let's put the button in here too, because we I could go either way. We don't necessarily need the button ins, but let me actually let's make this a P just so that it's its own line or something. P block scope it. Yeah, I think so. Loading. Yeah, okay. Passable. Okay. Better, right? Wait, what? Oh, this is a great experience. Oh. What? The loading goes away sometimes. It's sometimes updates after the like the two problems. First of all, I find it very jarring that the loading it just keeps on like unearthing my UI. But secondly, sometimes the loading goes away, and then and you see an old value, and then the updates come in. So it's like not completely even protecting us. Yeah, I mean, we could add auto cancellation on the set state, but we also have to manage the loading state. I mean, I don't think this, I'm using React because it's, you guys should all be familiar with React. This is not a React problem. This is like an almost everyone problem. Like some had slightly, like use Svelte 3. It's going to look like this. Like this is not, don't mistake me for this as an attack against React. This is just, and React has better tools today. I'm yeah. Oh yeah. We should make loading a counter. That's a good idea. Yeah, let's do it. So now loading is a counter, and then we can like do like a Boolean check. So we can make it a 0, and then set loading equals L plus 1. That loading, yeah. This is a great technique. I've definitely used this one before. L minus 1. Yeah. No. Now, if everything goes good, it should only ever show and not flat flicker anymore. All right. Success, sort of. I mean, it's. I mean, it's not bad. I mean, it doesn't quite feel like my old synchronous app, you know, where I could just click the button and the numbers updated. It's kind of jarring. You know, every time I do something, I get a loading spinner jumping back at me, but not bad. Handles initial load. I don't mind this initially when you're like telling me like when the page loads, I'm like, okay, this stuff hasn't come in, but it's really disruptive when I'm clicking my button and it's like, okay, yeah, so it's that, and then I do, oh, what? What if there is something below here just like jumping on the layout? I mean, we can be smart with our CSS and not do that, but it's like a little bit disruptive. Yeah, you know, exactly. React has known this has been a problem for like a decade. That's why they started working on this stuff. I mean, to be fair, with this setup, I don't think we get the 11 divided by 1 is 10 problem anymore. Like, I think we have produced a synchronous UI, and we did it basically through the loading counting. Another option, is it possible? It is possible for this system to still screw up though. If I mean, I'm not probably going to be able to pull this off, but if I click a certain random number of times, it is possible that we'll see like the 4 divided by 1 and see the answers for 3. I don't know if I'll be able to pull this off. I got it. There we go. 9 divided by 1 is 8. 9 divided by 2 is 4. 9 divided by 3 is 2. So we still need promise cancellation in this model. Right? Like we still need to know that like for this particular operation that, oh, and there's an easy way for us to do this actually. I mean, I don't know where to store it here because the components rerun. Like in like Solid or Vue or somewhere where you have a setup function, even so you could just like set something outside, like be like, this is a variable it stays. I mean, I can make a ref. I mean, I hate making a ref. Should I make a ref? I mean, this is more picking at React, but I could be like promise ref equals use ref. Is that right? Use ref. No, don't get me wrong. This could just be like some React developer could be like, this is just, why are you doing this? This is just dumb. I'm just trying to, what does use ref get? Does it get an initial value, undefined? Okay, beautiful. And then I could be like, promise ref dot current equals this, right? Is that right? Promise any or undefined. I'm not worrying about like a abort signal. I could wire a freaking abort signal up, but there's no actual fetch in here, so I'd have to do all the stuff myself. Maybe that's a nicer thing, but honestly, from our perspective, or UI perspective, we don't care about abort signals. We just need to like know to cancel. So we can go. So it's actually kind of simple. We can go like, we got a promise ref, and then when this comes back in, what we need to do is something along the lines of like, we always need to decrement the loading because we need to make sure that it doesn't stay counted. But before we set A through D, we could do something like if promise ref dot current equals promise, or doesn't equal promise, we're going to return. And you might be like, what's promise? Well, that was my bad. We need to create a locally scoped variable. So what this does is, this is the simplest way to do cancellation, essentially, I think. All you do is you basically, in the scope of this function, create a reference to the promise you're doing, and then have a outside scope here, actually keep track of the reference. And then when it finishes, if you aren't the last promise that ran, we're going to just ignore your results. Right? So there we go. So now in theory, I mean, it was hard to do already. So confirming that this doesn't happen anymore is going to be hard, but I shouldn't be able to do what I just did where it breaks. We actually cancel we cancel setting the downstream stuff. Because I mean, don't get me wrong, abort controller is technically probably better, but most of the time it's too late. Things already gone to the server, like you're getting it, like maybe you can stop it from processing the return JSON or something, but effectively it doesn't make any difference compared to just not setting the signals or the state. So, okay. I think we have a consistent model now. I'm not super content with the DX though. I mean, we could wrap this behavior in a primitive, right? And in a sense, you're kind of getting to where like tan stack minus the caching ability. Well, but in React, you kind of need caching anyway. So like this is kind of a cache. If you look at this, like how far do we go from keeping this promise to caching it so that like the next time the same value for n comes, we can use the same promise. Like we're already well on our way there. Yeah. That's kind of what I'm doing. The problem is Boolean isn't enough. You need to actually have a reference. This looks like Remix 3. Yes, kind of intentionally so. Maybe, I don't know. Yeah, I mean, you're right. We can simplify this a bit because you're right. We don't need separate state. We because originally we were treating this as separate state, but because it only ever gets all set at the same time, now we don't need separate state. But we do need the separate loading indicator because we have to handle multiple in flight, and we do need the cancellation. Do it inside the use effect, and you don't need the prompts. I'm not sure that's true. You need some. You need the problem is this. The inside the use effect is this, like where you're like, okay, I have the reference. So because like if I set this to true, and then I need something to check it against that exists outside of it, because every promise is going to think it's the chosen one. You need a sequence ID, a promise reference. You need something, right? Because otherwise, like true. Like when it finishes, it can clean itself out, but it's not about when it's okay. So we're suggesting, yeah, I think you need something internal to identify itself, and you need something external that keeps track of what the current is. If it's a single response, there's no need for cancellation because you can no longer come in and out of order. Okay, so you're saying like batch it on the exit side. I mean, all of this stuff has nothing to do with React or UI framework though, right? Like, well, everything I'm describing here is us trying to patch the fact that this is the only tool we have at our disposal. Yeah, I mean, you could also like create a buffer, right? Like a sequence, keep more stuff in memory. There's a trade-off to that, but yeah. But the buffer isn't guaranteed to be in order, actually, because our responses are coming back randomly. So we need, I mean, unless you allocate a space first. Again, this is, there's a systematic thing there where a buffer works fine if you go, at the beginning, you go, this is your index. So when it comes in, it goes, I'm loading index 3 and I'm going to write to index 3. And then 4 comes in and goes, I'm going to write to index 4. And then the UI goes, okay, on completion, I'm only going to show index 4 or the latest index. It's all the same mechanism. We're just describing slightly different variations on basically doing the same sort of thing. I think the only reason I lean towards promise ref is because it's very close to how you would do it in an actual caching solution. You'd use a key, which is kind of like the slotted index you're talking about, but like categorically same sort of solution. Are we writing React code? Did we give up on solid V2? Yes, that's exactly. We were talking about how much we love using async in systems that don't consider async. Now, don't get me wrong. Modern React does consider async. I just want to kind of clarify because this, I think, is passable or some variation of this. I'm getting a lot of suggestions from chat, but I haven't heard anything. The closest thing that I've seen that's been suggested that's kind of actually fundamentally different is actually storing the promise inside the use state and then having the event write the new promise to the use state. The only challenge with that is you still need something to decode the promise back, right? Which is like what use does in React 19. Without use, I think you're going to still end up using something like use effect or like kind of like make one of your memos unpure or something. Like you're going to use some, which is fine. Like these mechanisms are fine. That's basically how you make React query or like a primitive when you don't have use or you don't have modern stuff. But like these are all the same sort of types of solutions. the more we do all these bugs, the worse our code looked. Yeah, and I mean, this was a simple situation here. As I said, we're lucky that we started with 0 because we knew we were going to hide. Like if there was a scenario where something downstream actually depended other than UI and you couldn't start at 0, you actually had to say this was undefined for some reason, then like this gets even more fun because then like, I mean, let's do it because this is lying in a way that I'm uncomfortable with. So we want to actually, let's make this a little bit better. Right? I mean, I guess most people, you guys don't use undefined, right? You guys use null. Null's a cooler thing. Null. Okay, let's do null. So let's do it's number or null. Oh, so I'm like, why did that not work? Let's do number or null. 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 And luckily for this example, we don't have to like, then we can do something like a, we can just do something like, because now it's a UI concern, which is kind of like where it belongs. Do something like this. We can update our A, if there's, no, so it's the other way around. It should be actually A and like this, yeah. B and then just hope that A, B, and C are never 0. I mean, we can, that's a whole other bug that we could add. Better. And yeah, I mean, let's say not equals null, just in case these ever were 0. I think this is a better approach. We could also hoist this out, perhaps. We could, yeah, I mean, we can make it the same object, put the whole thing in the ternary, like loading in not or null, or like, there's a few options here, but I think I'm okay with this, recognizing those shortcomings. Yeah, how to do pending states is unknown at the moment. Sure, let's pull this out. Use effect, fetching data with effects. Use effect, fetching data with effects. Oh, actually, this is coming from Twitch. That's beautiful. I can actually copy the exact link. Thank you. YouTube, I can't, so let's do this. Oh, yeah. This is like the on cleanup pattern. Yeah. Yes. Okay. Yeah, actually, and this is the pattern I use in Solid all the time. Yeah, that's a little cleaner than the ref. The ref is closer to how you'd actually do it if you're implementing a cache system. I've been doing that so long, but you're right. Yes. This is I do this. I used to do this all the time when I was writing like solid code like 7-8 years ago, like before like 2017, 2018 style, like solid code. Yeah. So what they're saying is instead of doing a promise ref, you can handle cancellation by you can kind of do something like this, and then when it reruns, you can get away with like you'd be like done equals true, and then if done, return essentially. And now you know that like when when the subsequent ones happen, they're gonna call done true on the specific previous ones, which just cancels them out. And then yeah, this is a little bit cleaner. As I said, the other approach is closer to how you'd actually do cache management, but yeah. So sorry, it took me. I wasn't thinking about the cleanup function, and literally this is probably the most common way to do this. Definitely. Thank you. Yeah. They don't want you to do this either. This is just like fundamentally like I did this pattern a ton, and like in Solid, I just be like on cleanup, promise that, like, and then just do this done check. The internals of most async primitives work a bit like this when you actually make one. Like, if I showed you Solid Signals 2.0 async handling, it's basically this, more or less. It's not anymore actually, because I do defer disposal to manage transitions without forking, but like conceptually this is an okay place to be. Okay, so this is pretty good. The only problem with this is that the UI unloads on us while we're waiting. It would be nice if it didn't. I wonder if we can make it not unload, like where we can do something where it's like we have some kind of state. I mean, it doesn't even need to be that reactive the way like it's never going to trigger. It's kind of like, how would we do this? The component reruns again. I mean, I don't like making this state. It could be a ref, but I get it doesn't matter. Const loaded set loaded. This is going to be my easiest way to do it. You guys probably will have a better way of doing it. It's possible that we should get rid of loading, but for now, what I'm going to do is just say, oh, right, it's actually trickier than this because it's here. Actually, is it even here? Yeah, it is here the first time. That loaded through, I think. No, and then I just don't want to get rid of loading yet until I know that I've done what I need to. Oh wait, that didn't work. Did I loaded was false. And then when it finishes, I set loaded to true. So shouldn't it be? Oh right, it's the opposite logic. It's not loaded. It's like this. That's 5 updates too soon though. Like we're getting better, right? This is starting to be a little bit better, but the 5 updates too soon. Yeah, I mean, I can remove loading now probably. I didn't want to get ahead of myself. Oh, okay. But we now need a way of making fix not update too soon. So I mean, okay, let's get rid of loading. We don't really need loading anymore. We want the cancellation, but we're let's get rid of loading. I mean, I have an idea. You guys have better ideas, but we can make like const visible n equals like maybe something like, oh no, maybe we want loading. See, I'm too much of like a reactivity person, right? Because the way I would do this is I would keep loading, and then what I would do is something like const visible n is use memo. Like I make it a calculation that depends on n and loading, and then do something like probably something like use the previous value. So like loading previous value, otherwise n, or something like that. Does that make sense? And then like everywhere except for the button, I wouldn't mind the button updating, but everywhere else here, like I would just like replace this with like, sorry, I have to replace this whole thing apparently. I mean, I might be a little bit off base here. Maybe visible n. Does that work? No. Not quite. Yeah. I mean, we have to keep track of all stale values separately. That's the key part here. Why is this not working? Let's just think through this a bit. If we're loading, then we return previous. And then when we're done, loading goes to false, we return n, which should be good. And then we go to loading again. Previous should be the previous n. So what am I doing? It's not working. Why does it go to undefined? Oh, right. React doesn't freaking do this. I forgot they don't have self-reducing memos. That's a solid only thing. That's why this doesn't work. I'm like dumb. I'm like so used to using solid. We actually should we keep a reference? I mean, maybe this is just easier to handle a state. You know, I don't want to think about how I derive this. That would have worked in solid, but for React, I'm going to just do something like this, and then maybe like get rid of the whole loading thing. We don't need to derive it from loading. This, we can just do something like when we're down here, we can go like set visible n to n. Set visible n to n. And then we initialize the state with n. And then, yeah, this is probably the easiest way to do it. And then I click on it, it updates, it shows. Oh, actually, I want to add loading back for one more thing, because like I don't hate this, but I don't want to get rid of loading indicators completely. Sorry, so what I want to do is I'm going to keep this, and then I'm going to go back until I have loading there. And then I'm going to change this to this. And instead of loading, I'm going to rename this in a second, but let's call this set visible n to n. And then we want to, let's, instead of loading, because like we already have loaded, let's change this to some other name like pending and set pending. Which is funny because it's still a, and then, yeah, sorry. It's a counter, but it will serve our purposes, and then we can do something like pending show maybe like a dot dot dot. Otherwise, we just won't do anything special here. And then yeah, I like that. And then the only thing is it shows initially when it's first loading, which is weird. Like I don't really care when it's pending. So um maybe it's like if it's pending and loaded, then we do it. Yeah, I think I like that. So loading. Oh wait. Yeah, there we go. Yeah, that looks right. So it's loading to the button. Oh no, wait. Why is this still getting out? That's weird. Isn't that weird? It should start initially as false and true, right? Is it because of zero? Is this because of zero? No, zero will be fine here. Right. I mean, I don't really care. I just figured that there's probably some kind like this, like we just need to know that, like, give a better affordance. Like obviously n updating right away tells us that something's changing, but I'd rather like a better affordance here, like some affordance. I'm just using dot dot dot, but this tells us that the stuff is updating while we wait for it. And I'm gonna to make this feel, I'm gonna bring this back down to like a more reasonable place where it feels like a little bit better. So we can go like this. Click it. There's still a loading issue though. I mean, that looks bad, not bad. Maybe when I speed up, we won't notice it. If you guys can see it, that's fine. Otherwise, I'm not going to stress on it. But yeah, we load, we see the loading. See, it flickers. There's like a midstream between it sitting set loaded to. It's just weird. I don't know, whatever. After the fact, it works pretty nicely. We get our instant thing. So we have our pending indicator. We see that our work is being done. Stuff doesn't tear. It's self-canceling. It's not bad, right? Do you guys agree that this is like, I mean, this is why I wanted to keep the original. Let's see if I can, I'm pretty sure I didn't save. So if we go back here, we can look at our sync example again. Yeah. I mean, this catches the spirit of the sync example. Stuff updates, it's consistent. Um, uh, yeah, I'm gonna fork this one so we don't override by accident. We're gonna call it async. All right. I'm sorry if this took a while, but I think we're in a good place, right? We started with something that like seemed pretty reasonable, kind of looked like this, where we did some division, we showed it in the UI, did that, and then we got to a place where now we're handling key things like the initial load in. It's a weird flicker. I don't know what the bug is, but whatever. And then we can click through and we have no race conditions, stuff updates, we know it's updating. Like we could do great things out instead of the dot dot dot, but you get the concept. We have all the pieces we need to have a fairly responsive UI. It's not jerky like before where the loading was like pulling us out of the app and and whatnot. This is kind of where you probably want to be. The only thing again is our example started as 41 lines of code essentially, like we had a divide function. I mean, ignore the divide function. So it's like 40 some odd lines of code. We had some calculations and we showed them in the UI. It's fairly straightforward. And then to get here, we added some what do we add? We added the pending indicator. We added the loaded indicator. We added the shadow stale value, and then we managed to coordinate our promises to make sure that we set the right states, did cleanup cancellation, introduced our, changed our derived stuff to states, updated the UI to use the correct variables, and then manage null checks, and kind of arrived in an okay place. Chat's really quiet right now. It's been like 5 minutes. Did I lose you guys? Is this kind of just obvious? Am I building this up too much? I just want to make sure that we're in like a good place. Maybe I did really lose chat. The only reason that I'm emphasizing so much on this right here is because multitasking here. Okay, yeah. The only reason that I'm emphasizing on this so much is that because look how many new state. I mean, this is not something most people count, but look at how many new points of state that we introduced in our app. We introduced 1, 2, 3, 4, 5, 6, 7, 8. Now you could argue that the memos are already state, but for me, the thing is, every time you introduce state, you also introduce the setter, which means you introduce the possibility of someone writing to it in some random place that you didn't expect, right? The whole reason React has unidirectional flow is largely a control mechanism, right? You want to make sure that like things propagate in an expected natural way, and it's also like a secretly read-write segregation tool. Like by not putting it on the same variable, like obviously this is just a number, so how can you put a write on it? But like without a compiler or something. But effectively, what this does is it means that if you're passing down to components, you have to pass the setter down. You have to pass a handler down that calls a setter. There's no way that simply passing a down or n down or whatever is going to result in those things being changed. You're basically creating an immutable interface for control manners. So every time you introduce more state, it's just something that you have to be aware of. This is a simple example. It's all one component. The state doesn't leave the component. Who cares? Sure. But just look at, for me, when I look at this stuff, I look at all these points of like potential complexity that invoke from like the result of the model. Okay, so you said React and I checked out. People shouldn't be so harsh on React. The frameworks you guys are using are probably not much better. They are better at all. I know, maybe that sounds like a harsh dish. It's just, and this isn't even React today. This is framework X. This is pretty much like 80% of, like, if I'm not talking about like actual frameworks, but framework code out in the ecosystem, this is probably like a substantially large portion of it, right? This like Gen Z or Gen Zero kind of look at things. Okay, right? But it's important to do these exercises because like this is what I think about when I like look at Remix 3 reveal or whatever. Like you kind of work through this problem. Okay, so what else could we approach this a different way? Now, I've got the solid 2.0 divide example in front of us, and if you look at it, you're going to notice a few things. First of all, I could have started this one from the baseline the same way I started the React one from the baseline, because like we can look at the baseline and we can kind of copy it back. We can go, okay, so we have a divide function, we have increment state, use memo, and then we have some stuff with toFixed, right? So I bring that across to solid, and we have increment, use memo, divide, toFixed. That this stuff is all identical. The biggest difference here is this loading thing, which is kind of like suspense. We recognize here, like, okay, when we load, we should have some kind of loading mechanism. The button could be outside like it was in the other example. It doesn't really matter, but we probably need a way from the UI standpoint, just looking at this fundamentally, even if we start with the same example, we're going to need some way to say, hey, I don't have the data yet, right? Because we can't do, like, as much as we have this cool pending state stuff, here where we're showing this, we can't show something we don't have. We can't get 0.33 when we don't have 0.33, right? There's no, like, you can keep showing 0.33 while you're calculating for the next couple numbers, but you can't manifest. So I think as a stable rule, we do need some kind of loading indicator. In our example, the way we did this was by creating a loaded state, and then by wrapping in like a ternary. Honestly, this is probably the simplest part of this whole example in terms of adding loading indicators. Like this one was just like one state that started as false, and then set the first time, because equality check is not going to keep setting it. Hopefully, it's just gonna, it's just, it's essentially like the easiest piece. So from a UI standpoint, when you go to async, you definitely need a way of showing some kind of placeholder when the data isn't there. I think this is a fundamental piece. So we do need to add that. Now, the rest of this is more interesting, right? So I'm actually going to back off here because I want to get us as close to like the baseline example. Okay, so this is the baseline example. Okay, so with the absence of adding this loading indicator, this is the baseline example, right? And actually, let's go back to the baseline example and actually copy their divide function. Divide function. Okay, so now we are here. So we're back to baseline. Okay, so it loads immediately. You don't even see the loading, and then you click and it updates. And this is the baseline solid example, right? You have an n, you increment it, you create a memo. I like this doesn't need to be a memo. Just like in React, it didn't need to be a memo. We could have just done this, perhaps. Whatever. My point is, we're doing some kind of calculation. Maybe it's worth caching. It's in a memo. Whatever. Now, what do we do to go async from here? As I said, there's two things. We first acknowledge this loading state. To be fair, you know what? Screw this. It takes me so little effort to reset the demo. I'm going to get rid of loading too. Okay. Here we are. Presto. Blank state, sync state in solid. Okay. 2.0. So what's the first step? The first step, we go, okay, now we're in the like same place. We're like, okay, we know that we have a primitive, we know that we have a divide function that calculates, right? We're at square one again with solid. And we're like, we need this divide function to be async. So what are we gonna do? We are gonna update our divide function to be async. Now, in an Async-First model, it should be able to handle that. So when we load, there's some ugly tearing, but when we click our button, we aren't seeing tearing. We're like, this doesn't update, including this, until the value's there. If I click it like 10 times, or 4 times, or how many times, whatever, you're gonna see that it just jumps once. We don't have that weird use effect problem, right? We just, stuff is already consistent by its very nature. And the truth of the matter is, switching this to return a promise versus a value didn't require any code change in our application. This is the baseline. We had our sync model. We changed it to going, okay, instead of dividing being synchronous, now it's async. And our code still works. We did not change any JSX. We did not change any code in our component. It's literally identical. Right? So, but we have some problems. This is not perfect. It's not just like, okay, sync to async, it's done. There are things that we have to consider. Right? So the first thing we have to consider is is that when it loads, it shows it doesn't have all the data. So how do we manage that? Well, the way we manage that is, sorry, I should have started the demo this way, is we add a loading barrier. And a loading boundary, is kind of like Suspense in React, if you've seen it before. With one key difference is it only runs initially. So it loads, sweet. but now when we click it, it doesn't trigger again, right? So it's kind of like when we went from loading to loaded. This loading barrier is basically like it's like suspense is like the loading, whereas this is like the loaded in our previous example. So now it never goes back to suspense. It just it just keeps on updating. But yeah, this is not ideal because you can't really see that something is updating here. You're like, what, did the UI freeze? Like if I make this timer bigger, like sure, we're not getting any tearing, we're not getting any weird things like updating out of sync and partials, everything's like working nice, but it's kind of awkward here, right? Like I click a button, oh, is the UI broken? This is not a great base place to see. Like we're used to seeing tearing to at least know that stuff's updating, and in this system there's no tearing, so we're kind of in a weird place. So far we haven't really had to change the code other than having loading somewhere. That loading could have been in the component, the loading could have been around the app. Like as long as you like somewhere say, hey, when the stuff's not ready, show loading, you're kind of fine here. That's what's beautiful about things like Suspense or these loading boundaries, is it doesn't really matter where the async is, as long as you're reading the values somewhere below it, then great. Like we'll show a placeholder because we can't render it. That's basically what it's saying. Like without it, it kind of rendered garbage, but with it, you're like, okay, look, we can't render this. We're not complete. So we need a way of knowing that. So the first thing we can do is we can go, well, let's ask n if it's pending, right? Or sorry, actually no, let's actually ask n for the pending value. And this is, you know how in this React divide async example, we had like a separate visible n that we had to keep in sync? This is kind of like the reverse. Picture that n, it's more like the other way around, where this is like n becomes future n or pending n, pending n, and this just becomes n, right? Because what you're saying is like, as far as the user's concerned, that's the n that they see. So I know I'm doing everything backwards here, but what if we make this n and make this pending n, like the n that hasn't committed? Now we do this, and then this one comes from pending n, and then when we increment, we set pending n. This kind of aligns a bit more with what I'm talking about. Oh, what did I lose? The indicator isn't showing anymore. I must have missed one of the wiring. Oh, right. These rely on pending n, not on n. Something else must not be relying on the right thing. Because this is updating properly and the pending states are showing properly, but the UI is not. Okay, whatever. I don't care enough about the React refactor here to actually get this working like that. I just wanted to conceptualize it. Okay. So if we ask about pending n, we can see the number sooner than the updates come in. C4, see. So this is the in-flight value of n rather than the one that's currently visible. And then similarly, if we wanted to show some kind of pending indicator, we can go like, is n pending? And then kick it as many times as we want, and then it only goes away when it's done. So I mean, I can't really make the exercise much longer than that. This is essentially the difference with an async first model, right? You sacrifice the fact that the affordances might not be obvious at first because, well, it works async first. You have to actually opt into showing the tearing. But on the positive, the only code you needed to change between the sync and the async is the code where basically you diverged from what the sync stuff did. The sync stuff was always working a certain way. Now the async stuff goes like, look, I need a loading state. I didn't need that before. I need a way of showing that I'm pending. I didn't need that before. So the code remains basically untouched here. And the only difference we had to do by making this into a promise was saying, hey, this is loading, and show me kind of some in-flight stuff so that I have affordances. You see, React Forget doesn't. Do you know what React Forget would do in this example? It's basically completely tertiary. React Forget actually doesn't help us at all. It removes this. Yeah, that's what React Forget does for us. It might make it more performant by like memoizing some of these value calls, but from your code perspective, you just get to remove writing this or the React compiler. I don't think there's any point trying it. It literally doesn't help us here at all. So we are waiting for everything to complete before we update everything at once, and you can escape with pending at the end boundaries. Yeah, exactly. Yeah. I mentioned previously, Svelte is a very, very similar model with the new async model. The biggest difference with Svelte is it's kind of compiler based, but as I said, I'm talking generically. This isn't just pro. So I think this is the right direction. The difference with Svelte is that they don't batch multiple clicks together. Like they don't transactionally handle it. They just kind of like you'll get like a bit of a shuffle. If you click the thing like 5 times, you'll get like 5 results regardless of like, and so I think you actually handle cancellation yourself. You still have to handle cancellation in this Svelte model, whereas in the future React model, which I'm not showing here, which requires a few more wrappers, and the Solid 2.0 model, the cancellation is kind of implicit just from the shape of the design. Yeah, the React use stuff does, because you can get the exact same experience. You just have to write the code a little bit differently with React 19. Like there's this example isn't like this one would actually fairly easy to write. What you do is you wrap the set n in a start transition call, and then it's actually it's complicated enough that this is why I'm staying away from this, because memos don't necessarily preserve like between renders. Like they're like caches, but they're best guess caches. Like they don't actually like, it's possible like when under suspense conditions that you actually blow away the memo cache. So you actually have to keep a separate cache for your requests, like these divide requests outside of the app to actually handle it properly. Sometimes you can like do tricks like store it in the callback of a use state call or something if it's above the suspense boundary, but if it's below or like it doesn't work like that. So like I feel like if I tried to make the React 19 example, I could come up with a really nice clean example, but I would have to like think very carefully about the best way to streamline it, and I don't think that's worth the time. We did this exercise with Ricky on the stream. What's cool about this approach is like literally, and you can see with some of the other demos, it just doesn't matter. Like those kind of considerations are not what you're thinking about here. You're not thinking about where to place your suspense boundaries beyond saying, hey, I need a loading indicator here. Like that like it's not like the same sort of like if you made a reusable component or something, you could like just put those pending calls deep in them. Like you never need to worry about nesting suspense from a composability standpoint, only from like a layout UI standpoint, so to speak, because we've kind of decoupled them to be single purpose. Yeah, it's very similar to use transition, except you didn't have to do anything. It's literally like the behavior. I'm describing use transition, except where's the use transition call, right? We're, I mean, there are cases where you need optimistic state, but yes, use transition will give you is pending. And then if you want the pending value, you can create optimistic or use optimistic. And then when you do the write to the set n, you also write to the optimistic state. As I said, I know people are really interested in the future React solution, which as I said is way nicer, way nicer than this. I was just really trying to illustrate why people are looking at different solutions. And then you're going to be very hard pressed to find like this is completely doable with React if you add like 20% more code. It's perfectly fine. It's just like, and when I say code, I don't mean typing individual letters. I mean conceptual points in which you need to add more primitives and more set calls and more like start transition wrappers and stuff like structural, not structural, but like and use calls and potentially suspense in some cases. Like it's kind of structural is the best way to put it, instead of like, it's not like just like character typing. I think those kind of meaning, like if someone says your primitive is called computed and yours is $C, those kind of wins are meaningless. Like clap, 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 clap. Like I think that like the structural thing, like whether you have to call start transition or not, that is a more interesting question, right? But yes, definitely similar. I'm not, as I said at the beginning of this, when I put it out here, I consider the new React stuff like basically in this zone, even if they require extra APIs to get there, just simply because they can't break everyone's code. It's the place. Could you replace the loading boundary with show as pending? I'm guessing the difference is that loading will show only the first time. Yes, and the other difference, and it's kind of subtle, is show is going to remove those nodes. They can like stay live off screen to a certain degree in some cases, and like or the on screen ones stay live while the new features showing. But the loading boundary specifically is designed to parallelize that flow so that like if it like loading boundary doesn't matter because you never go back to it, but like say like an error boundary, we actually keep the nodes alive. You know what? I have another demo for this. We're done with this demo. Let's just continue on here. Okay. I'm hoping this demo made sense. I wanted to spend a lot of time on this first one because I think it's the most essential ones. The other ones are going to go faster here, right? Like let's move on. I think these will go a lot faster. This one I don't even really, we've already seen this one on previous streams, so I don't really want to get into it very much. But the difference between sync and async is literally, I mean, you can just see where the points are. If this didn't have a loading boundary, but this one is like when you choose a state, it has to load the cities for it. So when you flip it, you know, there's this. All we did to indicate that was put an is pending on the disabled on the select. And what's beautiful about this is if this was brought into its own component, like extracted out, you could see a component authoring this way. They're going because cities is the options option. So this would be like my select. You could just make a rule that was like I want my select to be disabled if my options are pending. It's that simple because the graph just queries it, right? It's like if your options are pending, then we probably shouldn't be selecting from them. That's basically the logic here. It's very, very composable. It doesn't require too much specific thinking. But yeah, I mean, this example is fun because again, I don't have to go over this one. If you watch the remix unveil where they showed like, oh, we just set the loading and then we do the cancellation with the abort controller. And then because of the way that it works and promise cancellation rejection, we automatically don't have to worry about it. It will only ever get to the setting loading false if it actually succeeds. So like, you know, we have this kind of thing. And then I looked at the problem and I was like, if I was going to write this without async, I would just be like, here are my states. And then I'd be like, my selected state, starts as the first state in the list. And then my city is going to be based on the selected state. So I'd show this, it would be like an array of cities, and the index would be the selected state or key. And then I'd be like, okay, well, and then whenever my cities would start as being the first city in the list, but afterwards, so I could just set them. And like, I was like, not thinking about async, I would just do it this way, right? Instead of having a bunch of states write to each other in events, I would just write this rule. And then when I changed it, state changes, then I select the first city. This one changes, doesn't matter. And initially when I load it, California is the first in the list. So it's the one that loads, everything just is perfect. The fact that I added async to this matters nothing. And as you can imagine, changing this from an array to a function that gets the states actually did not change any of my logic code, did not change any of the way that I drew my UI, did not change this. The only thing I was like, okay, well, maybe we should show some kind of loading indicator when my options aren't loaded. And, somewhere, I don't want like a bunch of loading spinners on my page. I'll just like wrap the whole thing in a loading. Like that's the level of thinking that goes into this. You're not worrying about province cancellation. You're not worried about like coordinating like the different async stuff. It's just like, I have state, I have UI. So, okay, this one's an easy example. Let's continue on to the next example. I don't think I did anything of note in this one. Okay, this one's fun because people misunderstand this example all the time. And I actually really like this example in the current form. I'm going to do one little modification before we go, which is I'm going to remove something here. What I want is seconds, yeah. So instead of returning this whole blob, I'm going to return seconds. This is a little bit verbose, but I want you to do it. I really want people to understand what this demo is showing. This is another good one that's fun to make with use effect. Oh, so the question, sorry. So you're invalidating the selected city. That's cool. How do you know what to invalidate? I'm not sure I quite understand the question there, because like basically when you set a new value on the signal, it tells anything that depends on it that, hey, my values change, and then it recalculates. So by wiring up the graph the way I did, where it's like signal depending on memo, depending on fetching, it automatically, like if you set the state, the selected state, then I mean, let me quickly pull this one up again one more time. But when you select the selected state, it goes, oh, the cities depend on the selected state, so I need to recalculate the cities, which in this case does an async fetch, but otherwise could just pull the cities from a list. Yeah, so create memo is derived, and create signal can also be derived in Solid 2.0, which is what I'm showing here. So there's writable derived values and derived values. So like the whole logic of the app is right here. It's not a bunch of like effects. That's what I was talking about. When if you do your stuff like really event driven, which is good for certain shapes of problems, you have to reconcile with the fact that you're going to probably introduce more state into your underlying framework. And then because the framework's job is to synchronize state, which is fine, but like there's a trade-off here. People go, oh, why are you putting all this stuff in React? You should just handle most of it outside and then just tell React to re-render essentially when you do the load. A lot of people use stuff for state where it should be refs or shouldn't even belong in it, which is a lot easier to do when your component runs once. You saw that when we were doing the React example. We're like, where do we store this, right? But there's like a double-edged knife to that whole situation, because you're kind of like, okay, let's move stuff to the events. But then it's like, what if I have multiple events that touch this on the same state? What if I have to add another drop down to this list? I did that test myself. I'm like, what if I add country in front? And the result was like basically just adding 2 more of these. And at that point, I'd actually moved the select into like a generic component that handled this as pending. Because if you look at these selects are identical. It's like select. I mean, this one doesn't have the disabled option, but it'd be disabled options on change, just set the thing, and then iterate over options. Like these are very generic. So I was able to just go like, okay, put this in a select component, and then basically go like, add 2 lines here, add another select component. Everything works. But you have to consider like now there's cascading loading. There's this loading this that loads this. Like this model doesn't have to worry about that. It just resolves itself out. Whereas like in other ones, you'd be like, well, how do you handle this loading state? Does each like, because here's the real gotcha on this. It's changing this select list that triggers the loading on this select list. So this is what makes this example so beautiful. It's that you want to make something composable, something that you can just like generically use, you know, in component libraries or whatever. But the staleness doesn't derive from your same component. It's not like, hey, I'm stale. It's like I'm stale because of my inputs, because my options list is out of date because of the work someone else does. Once you start trying to build out that in a generic way, you start going, okay, well, should the logic you put in this change handler for each event starts becoming very specific. You're like, okay, well, the first select triggers these loading states. The second select triggers these loading states. You know, and you're almost back in this place where we're, you know, keeping a counter, right? Like just from a fundamentals level. So, okay, let's go back to Sierpinski. Sorry, it's good that we stop on these points. I think this is the part that kind of gets lost when people look at these demos. So Sierpinski is actually not a hard demo to draw. This is synchronous. It's literally triangle and triangle and triangle. And there's one silly driver from the top, which is like how many seconds have elapsed basically from the whole thing starting. And we're using, and then what, yeah, so what are seconds? We have 2. We have the seconds that we're showing, which is this, and then there's elapsed, which is used to calculate the scaling factor. But what's cool about this demo, and the reason React created this demo, is the scaling factor is handled through an animation. It doesn't actually cause any component re-renders. This whole like the triangle moving, it has nothing to do with the children components. It's literally just a CSS transform on the actual outside, which is the way you should do this. You're using animations. You shouldn't necessarily drive all the stuff through state. It's kind of expensive. Like sure, Signals can handle it, you know, but like why, right? So it's smart. But so the only thing, if you look at this first component, all the stuff is static. Doesn't change. X is 0, X 0, X is 1,000. The only thing that changes is this number that gets sent through, the seconds that get set up on an interval. And the idea here is that you've got a whole bunch of components. And the important part is when you go through the triangle, what you'll see is, this is why I can even do like early returns here, even though Solid usually doesn't do early returns, because you know that these props are never, ever, ever, ever going to change. Now, I don't take that bet when I'm building generic components, but when I'm building a demo that I know that all the props are always static, you'll see they're still always static. The only thing that actually changes is the children, right? See, this I made this note here. It just let me copy the React example verbatim, even if it's like not very solidy. You know, we should use a show component or something. But my point is, the only thing that travels through this whole grid is the seconds. But what the idea is, where is the triangle itself? Yeah, the seconds end up just, I call this slow. I made a calculation here because that's the point of this app. But the seconds get passed to their as children, props children, and then they get passed to their children, that gets passed to their children, that pass children, pass their children. And the whole point of this demo is that what if every single child in this tree that spans out has to do its own calculation, like expensive calculation in here. Like, so each number, so we start at the top here of the triangle, and every single node has to push its calculation all the way through. Now, if we had a really poor system that was like polling based or something, it's possible that you might actually see numbers start updating at the top before they got to the bottom, like, but almost every system now is synchronous. We will only flush everything all together, which means that if there is a legitimate slowdown added, and just a second, I want to see what the slowdown is. E-performance. Yeah, I'm going to do two things. I'm going to just open some kind of note thing somewhere where I can just dump this code, and then I'm going to go back. Okay, cool, let's do this. So if we add a slowdown here, I'm gonna make it small at first, where like we're just pretending that it takes something stupid like 200 milliseconds to calculate every single one of these nodes. Our UI is gonna start not looking as smooth, especially when we start like interacting with it and stuff. We're like, this is still working, but you can see the problem. There's like 1,000 circles here, and they all depend on the calculations of their parents, and they have to show themselves synchronously. Like they have to stay consistent. That's the rules of AI, right? Or sort of UI. So what are we going to do? And what if it gets worse? What if like we're taking almost a second and this thing updates every second? Like it's going to start, we might like lose our cursor somewhere. Like if I move the mouse fast enough, you're going to see it's going to stay highlighted on a different item because it can't even get to rendering it. We're just like chugging the whole system out, right? And this is not great, right? This, as I said, I don't know how much this happens in real apps, but you can kind of see that like this is already kind of a hint. Like at the point you kind of go, okay, you know what? I recognize that this is a slow calculation. The first step, you might memorize it to make sure it doesn't happen again. But this case, we can't save any of the calculations unless we created some external memoization system, that like remembered the numbers from above. Like I could see you creating maybe like a cache where you're like I've already done this calculation in this node, so I don't have to do it. But the assumption here, even though this is literally just returning the same thing, like is like, what if it was seconds plus one or something like that it actually fanned out? Maybe that'd be a better example. Is that you don't get to keep these calculations, right? Like they kind of cascade down through the whole tree, but we have to show something consistent. Now, again, we could go here and use effect, right? And maybe make it async, right? This was kind of like your only option in the past, but that would cause this weird fan out where like the first ones would kind of finish and then the other ones would finish and then another request would come in and then it would do it. Your UI would just look like a Christmas tree, like, light bright, like put it on rotating color mode. You wouldn't get any kind of consistency. You still get interrupted probably. I mean, it might be smoother, but like it'd be like whack-a-mole. You'd be like, okay, that's a 1, that's a 2, that's a 3, you kind of get the picture. So how do we offload work in a consistent way? Well, if it's derived, if the async is derived, which I was showing in the last example, then you don't have this problem because you can both offload the stuff. And again, it's just returning a promise here. I took the original example, which is just memo, do some calculation. And I just was like, okay, I'm going to return a promise that set the timer. It could be set timeout for all I care. I do my expensive calculation in here. And then I just register an on cleanup function in my memo. It's funny because effects people are used to doing cleanup in because like it's impacting something in the outside world. If you view async as derived, it's actually important to also be able to do kind of internal cleanups. The difference is people aren't listening to things you're doing in here. People are only listening to here. So this is safe because it's encapsulated, right? So what happens when we do this? Well, it's consistent, it's smooth, and it works. So why do I show this demo? Because change this from sync to async, because I noted that there's a performance issue, was just a matter of just figuring out a strategy for deferring the specific work. I don't lose any consistency in my graph. and now the performance is great. It actually scales great. Like I can do something stupid here, and like, what if taking almost a second is or whatever is actually, you know, too good for it? What if the person's on mobile somewhere really slow? Okay, we're still smooth. We're going that. When we interact with it, we start getting a little bit tensed up. Oh, we're still doing okay here, though. Not bad. It's not slow enough. Let's do 6 times slower. Okay, let's go. Okay, still smooth. Oh, the numbers stopped updating, but the animation stays smooth. When I stopped moving my mouse, okay, the numbers kept on going. So we did take a hit a little bit because something has to starve when you like artificial slowdowning, CPU times 6. We're saying that, like, look, this part of the graph couldn't propagate. The animation continues because it's completely isolated, right? But this part of the graph was not able to calculate it fast enough to actually show it within that window. So it did starve in this case, but it's just a temporary state. It's just like, that's if you spike it. I don't know how often you're going to be running with, like if you have an app that is super slow, calculations, and running on a super slow device, and the person's interacting it like crazy, I've like, someone's made a miscalculation. You know, like, if it's the different thing is if you're like using an app and then like you have a temporary spike and you're like, oh, I missed a number, you know, and you're like, okay, that's acceptable, you know. But it's a completely different consideration when, like, you expect to live with it. Nothing that we see here is desirable. This is just showing that if you identify something is slow and you want to offload it to a web worker, to the server, to wherever, some other channel, a timeout that's not part of the render cycle, you know, this is a reasonable approach. Like, obviously, there's still limits. I'm going to get to 20x here, which is just insane. And now the numbers just don't update even when it's animating. And the animation is stopped being smooth. You know, we're seeing, it looks now like my original demo a little bit. But at this point, this is taking longer, like several times, almost 20 times longer than the allocated time. It updates every second, and we're like, it takes 20 seconds to calculate. You know what I mean? Like, yeah, I mean, oh, our CPU slowdown stopped. Okay, we're back on. See, like, no, we didn't actually corrupt anything. You know, I'm hoping you guys can see that the numbers are updating again, but. So something like this, use request or use, I don't know. It's up to you. Not my problem. Like, you see, I kind of like this aspect of this. I mean, you're right. There might be a future where people want to create smarter primitives that handle specific scheduling behavior. The key part here is that the scheduling behavior is independent of the mechanism. So, like, I wrote my synchronous code. I updated the one place that was slow. I did not need to change any of my other code, and I'm already better for it. Okay, so sync to async. You guys are following the pattern here. The pattern is, I did not need to, basically, other than like where the async case differs from the sync case, like now I need to worry about loading. I don't need to change any of my code to add asynchronicity to the system. Okay. We were not going to save that one. Okay, let's continue. Nested fetching. I don't even know if this one is important. I mean, it kind of is. But this one's a silly example. I mean, I've shown this one for ages. The idea behind this one is, you have a component tree, right? And it has some data in it. So you have some data that you calculate and you show in your component, but you also show children, right? Right? And that children also has some data that it works with, and it shows its children and so on. And then the third one has no children, so it just shows this thing. But what this demo, if this was synchronous, this would just be some kind of calculation you needed to do. Like, you're like, based on some props or something, when you start up, you're like, oh, I needed to read something, you know, I need to just like set something up, like capitalize a name or whatever example it is. And then something happens. We realize that we can't calculate that on the client anymore, and we actually have to calculate it on the server. We actually store it in a database or something, or maybe it's in local storage or some kind of place where it's like not available to us immediately. That's what this example shows. It shows that when I change this create memo from being a value to being like, oh, now I want to just fetch something in here. Yes, that fetch takes time, but intrinsically, because the data dependencies, like if you look at it, you can see it, like we're not passing any arguments on it in through here. B here does not depend on A, and C does not depend on B. It doesn't matter the rendering hierarchy. These will fetch in parallel. They're all 3 seconds. So how long should this take? 9 seconds? Because A renders B renders C? No, it should take 3 seconds. Yes, but it's also like it's caring that B data doesn't depend on it. Like if I went like A for some reason and passed A in here, right, and then I don't know, decided to add a props A here, that's not going to change it either, right? It's still going to take 3 seconds. It's not going to take 9 seconds. You know, there it is. I snuck it in there. Like, it's the data dependency, not the UI dependency, right? Right? And the reason this is a powerful as a sync to async example is because you start with something where everything's synchronous, and then you realize that, oh, I need to fetch something in the middle of the tree. Well, guess what? That doesn't necessarily mean your app will waterfall, because the UI and the data are separate concerns. This is a good thing and a bad thing. When we get to Ben Davis's comment, when we get to This Week in JavaScript, or maybe I'll get to it sooner than that, we can make a determination. But like it essentially, it's because the component isn't the read. It's not like I want to use B in my component, so use B. The read is inside the specific binding. And the thing is, if you have like a granular rendering system, calling use B here or here, like one of the coolest things about use in React is that like literally you can put it almost anywhere. But the difference between calling use B here and use B here isn't that different in React, because I mean there's some exceptions if you wrap it in a component and when the component runs or whatever, but like, and like maybe pass the function. I've seen some really cool hacks people done around React, but generally it doesn't make a difference, where here this makes all the difference. The same trade-off that people are like, oh, why do I have to wrap stuff in functions when I access it? Why can't I just like use values and stuff? And is the same reason that components don't matter in this kind of fine-grained async system. So that's what this one shows, because it shows that even if we start with a simple hierarchy of components, props pass through, whatever, like all these components actually only render once. See the 1x? They actually render, this is what the stupid counter is doing. It's checking how many of the component bodies, even though this is async, even though it's loading, it's because the difference between suspense, or loading here, or suspense mechanism, it preemptively runs the branch, the success branch, and detects the async, but it doesn't throw it away. It doesn't go, okay, hit async, throw error, throw it away, run the component again, now we're good. It still only runs the components once. So you keep that stability stable thing that, you know, we like here. Like the component, even though there's like this async, it's just like, okay, I can't show this on the screen, so I'm going to hold this over here while it's working. When it completes, it doesn't re-render everything again. It literally goes, oh, okay, well, I couldn't render this one thing here. I couldn't render this one thing here, maybe that props thing. And it just goes right fine-grained and goes, okay, I'll update that place in the DOM, that place in the DOM, that place in the DOM. And then it's like, oh, I'm done. I'll just swap it in. So because of this mechanism that basically, as I said, turns the children to siblings, flattens the whole hierarchy, it means that your fetching is kind of automatically hoisted. Like, unless you create a strict data dependency, like if this, right? Suspense doesn't do that. But like if you put a show component saying like only show this if B is there, then yeah, you've done that. So this is why we had to make stuff non-nullable, you know, which we showed in that first example. I didn't really highlight it in here, but if you look at this, what's the type of A? Access or number, right? Even though this returns a promise, we get a promise of number, we get accessor number. When this was not a promise, when this was just divided as a function, it was still accessor number, right? It didn't care whether this was a promise or not to make this accessor number. And which is why we can call to fixed on it without a null check. And the same thing kind of carries on down here, because if you have nullable async, people will put guards on it, which will ruin this parallelism. We had to make it non-nullable so that we could basically flatten the graph. There's no point to go show if is pending or show if not null or whatever in this model, which means that effectively we solved client-side waterfalls. Yeah, it actually throws into playing in the graph, which I'll show on the next example. But I've shown this example before, so that the people in the chat are probably like, oh yeah, this is old news. But think of this from a sync to async perspective. This is huge. You have a tree, you realize some parts of the tree separate, like modular, need async. It's not shared somewhere else. You can just you're way more likely to be safe to put it inline. The only thing that gets you in client-side apps is lazy loading of code. Usually that will defer stuff till the chunk is loaded. Lazy loading is the main reason why we have file system routers today. It's because essentially, like in the client, you're not going to load all the code up front. That will cause a waterfall. If you have data fetching under lazy loaded boundary, that will cause a waterfall. So that's why people hoist stuff into loaders and that. But generically, the rendering is not the reason. It's purely because of lazy loading that we can't just fetch in our components, right? And obviously stuff like server components can solve that in a different way, because like server components can be like, oh, well, you don't have to even send the code to the client. So from that perspective, we do all that fetching in a single pass on the server, and then the client doesn't waterfall. So yeah, that solves it too. But the challenge is, if you don't solve the structural problem I'm talking about here, the server is still going to waterfall. Like if you do something stupid like await promise, like async components, guess what? You're blocking. Now, on the server, there's not parallelism of like reactivity or interaction, so that's probably fine in most cases. But it's something to consider with, because you are 100% blocking things you didn't. You could have gone on and rendered B, but now you're like, no, I can't render B because I happen to wait. Async components are nice DX, but they just don't fit. They're probably like I can almost say like the wrong way always, like from a design perspective. Yeah, I mean, you could argue like like it just doesn't act. Why would you block? Anyway, chat's like, yeah, Ryan, just keep on your soapbox. Okay, but yeah, I already showed that actually. I just like I actually removed the suspense boundary. I mean, you're not gonna like what you see when I remove the suspense boundary, because the stuff's missing. See, I showed the UI, but it's like in how many seconds? Oh, 3 seconds. But so I suggest, but what I'm saying is you're not going to be beholden to it. Like the way you could view it is at a very base level, you can put a loading boundary around your whole app and be like, I don't really care at all. I don't need granular loading. I don't need some stuff loading before other stuff. And you can just be like, call it a and be like, look, I know when the UI shows up, it's going to be good. The reason you use loading boundaries is so that you can go, okay, I'm okay with this section outside loading before this section. So you can kind of like divide up your app in logical realms. But this is sort of independent of affordances that you use to show that things are in flight or pending or that you're doing work. This is just like placeholders. This is just like, this is the decision the designer makes. Where your suspense components go, the designer makes that decision. The developer just goes, okay, you want one there? Okay, I'll put one there. I'll put one there. And the designer can conceptualize it, because the designer can go like, okay, I don't have this value, so I need to show a placeholder. Like, so like this has nothing to do mechanically beyond the designer's preference. Whereas you as a developer are going to be more like, okay, when things update, yeah, I care if this is pending so that I can show some kind of pending indicator. The designer's still going to be involved in this process, don't get me wrong. I'm just pointing out that like, see, I actually should reset this back to the baseline. It's just that like these affordances, even the pending is not like a technical challenge that you're going to solve by going through and adding a bunch of state variables. It's like where I'm, it's a UI question. Yeah, this is the mentality I had to like push when looking at this, right? Like this is about architectural design constraints, and I think sometimes isolating them is key. I think React has done an amazing job here because like even the introduction of suspense, it's suddenly like this is what people who don't like were like, I don't need suspense. Like what made suspense so powerful was that this inversion of control that was basically like we don't care about the technical stuff. It's a UI component. The challenge is sometimes with React, that co-location becomes too strict. It becomes like too rigid for you to be able to like maintain. But it's I love it when they do it because that simplification lets their minds go down that path way more rapidly than other people because they're just like, okay, well, it's already components, so it's like they can just like go down these paths in ways like I wouldn't be here talking about this if it wasn't for the work React did. Same for Svelte. It's funny how they influence my thinking, right? Because like Svelte has a compiler and everyone's like, oh, that's a super compiler. I actually consider the compiler almost like a limiting factor. Compiler is like an acknowledgement that your code's not good enough. Like, I mean, there's performance optimizations, definitely, but it's kind of like a lot of times compiler is trying to like extend something that just isn't possible, but it lets you open up to dream, right? So when Svelte does something, sometimes with the compiler, it's not an optimization. There's a second category they do, which is kind of like, what if? They use compiler as a hack, essentially. So like Svelte 3 is basically, what if we didn't need a VDOM? That's the hack. They're like, we could just define our state and then we could just like do something smart and kind of like figure out like, something fairly reasonable where state updates does roughly the right work in the DOM and we don't need a virtual DOM to do it, which has benefits of, keeping our runtime smaller and like, but it was an approximation. Anyone who's used Svelte 3 knows that like there's like weird edge cases and timing and like consistency, and you're like, oh, what happens when this thing happens? And then they switched to ruins in Svelte 5, which is the actual model. Like it uses the compiler enhancement definitely, but that's mostly, not completely, but largely syntactual. They actually moved from a compiler-based approximation in Svelte 3 and 4 to the actual runtime in Svelte 5. And I feel like the work that I've been doing with Solid 2.0 in a second is taking their approximation in async and making it into an actual runtime, like making it into an actual thing. So I think this is like the thing that Svelte challenges me to dream, right? Which is amazing. And then like React, on the other hand, React knows the problem to solve. They even know the solution. They're just like, in my opinion, and they obviously disagree with this, and I'm they're free to, is that their hands are tied by the fundamental design of their system. So like, it's a great place for me to be sitting because I can see the dream, and I can see like how it should behave and what it should do, and I just put it together, right? That's what engineers do. It's funny, some of my work's researching, but it's like essentially I feel like there's a certain practicality of taking like a dream in terms of like what the user experience is versus like very solid, rigorous work the React's doing like from almost like an academic standpoint, and then finding a way to meet that in the middle. We have to find an opportunity to decouple. Yes, Ryan Florence. as much as like I love Ryan Florence because he doesn't accept BS. Like if he sees crap, he calls it as he sees it, and that can offend some people. But you know, I, my my dedication to the truth, maybe overly so, makes me respect that incredibly. Um, right? Like, so what would happen create async? There is no more create async. That's been the whole point about this. Every create memo is a create async. This is kind of an, I don't know if you guys have noticed in this example. Yeah, I haven't, in any example, there's no create async. I'm literally just going, oh, I took a create memo, I took a signal, and I just decided to derive it from a promise, you know, like what's this return? Fetch and second. Promise of string gives me accessor of string. You know? No. All the work, all the frameworks are great. You have to understand, you popped on my stream. I am what you consider like subject matter expert on JavaScript frameworks. That's my thing. I am a JavaScript framework author, so I'm obviously biased, but my position, my content is all about very deep JavaScript framework design pieces. So when I critical of something as Svelte or React or whatever, it comes from a place of like being very, very deep into it. It's not because I don't think they're good choices to be used. I'm talking about architectures that are not here today, might not be here for 2 years, 3 years, or whatnot. So it's no hit on what they're doing. Yeah, that's basically the underlying mechanism, but the impact of that is huge, as you'll see as we continue through these demos. But the important part about this demo is it was synchronous. I decided that I couldn't calculate this on the client's, 3 components down in the tree. No problem. Okay, move on. Okay, what's our next example? I like keeping the divide example up because it's actually like pretty cool. Okay. Error counter. Okay. This one doesn't really have a synchronous version, so maybe there's no point skipping over it. Other than like this one, yeah, this one doesn't fit here. The only thing is this one still shows how much easier it is with a model where you can derive async up here and worry about whether it's loaded down here. That's the main thing that it shows, because this model, this shows error boundaries too. This one, like, what's cool about this one is that if I have an error that I realize down here somewhere because I fetch some data and it doesn't work, and my data fetching is up here, or it's like in some store globally or something, or some kind of weird other place, the error boundary only cares if it can't render. So when I trigger the error here, come on. Either when I click onto the next value, which, re-triggers our async work here and re-renders what needs to re-render, or I click retry, which looks at the error and then retries, like if the error gets thrown down, like you get the error, you throw it, we can trace through the nodes of the reactive graph to know where the error is coming from. And he just goes, okay, well, the source of that error is actually this memo. I can just retry it, and it retries it. We get basically data fetching retries for free. So like this will try and get 70 and oh, it got it that time. And it was funny. Ryan Florence actually had a post the other day where he's like, did error boundaries ever actually work? Like, how does anyone like refresh them or restate them? Because the problem with the error boundary conceptually is when you try and click retry on it, the error is still there. You have to both fix the error and then tell the boundary to refresh. And does poor old me down here know what the error is? They could take a stab at it and be like, okay, maybe it's coming from my props here, so like maybe my component should have like a retry fetch thing that I pass through so that when I error, it doesn't make it very easy to use or be composable, where this is just kind of like, look, we might not be able to reset it. Like maybe you'll have to go do something, but generally if the error is something that we propagate through the reactive graph, it's something that we can solve. Yes. I mean, it's a subtle difference, and I talked about this a bit earlier when I was talking about like how many state points is. I'm all about control, maybe a bit too much of a control freak. Creating a primitive that's like, look, this cannot be written to is valuable in its own right. You're right. A memo and a signal can be basically the same thing, but the fact that it's writable versus not is worth enough semantically to be a different thing. It's like let versus const or whatever. Like I use const, so when possible, use create memo. You know, create memo is const, create signal is let. Yeah, that's an interesting thing. And the answer is yes, which means that it's probably going to error again. But you're right, it is a purity versus impure thing, but the mechanisms are general, just like refresh, right? I'm still thinking about this a little bit because you're right, it's purity versus pure. You don't want to discourage impurity, but we're trying to create a system where we don't view async as impure, even though it is sort of, but like we're trying to keep that at the edges outside of our knowledge within the actual like UI framework itself, like not within the framework but within the interface that you interface the framework. Like when you're in your components using signals, using GSX, you're not thinking about purity, hopefully. Yeah, the error bounds have mostly been unrecoverable. Yeah, so I mean, this is a small detail. This one doesn't really translate to my sync versus async thing other than this small point. This component here, our poor little message, has no clue that our app has changed. It doesn't know. It doesn't even have the ability to show a loading state. It's just a dumb component that says the message is this. Okay? But just because it's down here, see this console log? See this console log, phrase counter. This is important. Let me see if I can open this up here and show what I'm talking about. Where's the console? Or actually, can I just switch to console? Yeah, it's better. What I wanted to show here is when I load the page, we're going to see rendering phrase counter, fetching phrase, and then writing message. When I click 1, 2, oh, there's an error that time, retry, the thing you're not going to see is rendering message again. And that's because, partially it's because this just updates, but the key part here is we didn't need to pass like a promise through. This message component got to retain being completely oblivious about async, even though this is actually the thing that is throwing. So from a sync to async thing, what this is actually showing is that the inclusion of async doesn't require a tree-based API change. Like one of the biggest challenges with something, with a lot of systems is you end up, you have to fetch high and you want to read low. If you don't throw down here and you throw up here, well, you can't do that here. That's above the loading boundary. So then what, do I have to put the loading boundary above the whole component? Do I like pull my component out and then like this one's not bad because you could put use inside here, I suppose, but then this has to become a promise. If we're reading inside here, now this is a promise. So now like everything between where we really want to read it and where it's fetched, we have to pass promises through. So then we start getting APIs that are like, text is a string or a promise of a string, which it might not be that bad because it can like help you see the async as it propagates through your graph, but it means like huge amounts of refactor when you're like wanting to add async, right? So like it's kind of awkward. Like either you end up reading way too high and causing like things to unmount unnecessarily, or especially if you don't have like single load suspense or whatever kind of mechanisms, or forcing wrappers higher, like you have to like build it up, or you're going to find yourself passing promises through several, prop drilling promises and partial promises. So you start getting these like interesting cases where you're like, if it's a promise, render this. If this is a promise, render that. Like I've seen some examples couple of examples React where like you, depending on if it's a promise or not, you render it something in suspense versus not in suspense, so that you can like handle the use like in a more co-located way that's composable. The extent of this system is like if you want to be aware of pending state or like stale state, you just like, you don't put a suspense inside this message component. That's like, again, that's like a UI decision, right? It's not composable. Like suspense doesn't belong in reusable components. Suspense belongs in your application code, right? Like unless like the reusable component is complex enough that like it warrants having its own suspense and it has enough behaviors. But a simple message button, whatever, probably doesn't have suspense in it. It might have like an is pending. It might be like, okay, well, you know, let's ask if is pending my props.text, then I should maybe you know, me and my ... right? See, I added the ... on the end here. You know, that 4 dots. See, pending, I added 4 dots on the end. Like the extent at which you ask it, but this doesn't require, like, now don't get me wrong, there's no indicator here whether this could or wouldn't be pending, but the decision is affordance based, not based on, you know what I mean? It's like if your component would want the ability to show loading, then it would know it wants the ability to show loading, so then it would do it. If your component is oblivious of pending state and has no logical place to show it, then yeah, it probably happens somewhere else. But that doesn't mean like you don't need the use down here and to like pass in a promise now and have it be still the source of async in a way that is the most efficient, which is pushing the reads all the way down to the leaves. Like, yeah, I don't know if I can explain this stuff well enough. I was hoping showing it would make sense, but yeah. That's the power from a sync to async standpoint. This component, unless it goes, okay, it's my natural responsibility to show some kind of stale state, does not need to change. Adding async to the system does not cause this crazy coloration where you have to go update all your components to accept promises. Okay. Cool. So I'm hoping each example brings itself some sort of value for people. I think we're done with this one. Oh yeah, sorry. The last one had some sync. This one has 0 sync to async value. So I probably can skip it. This one is the one that I just include to show, like, this is the test. If you think your system has properly behaved, or if you think your system belongs in Gen 2, essentially, like, or like borderline, arguably like React 9, this is your test. Can you make this example? This is the most thing. Because the key to this example is, a lot of people, I did this in early solid, like 2019 suspense and stuff. If I can't click on the next tab over here and have this counter still go while I'm waiting for the next page to load, I have failed. This is the test, right? There's also a case where I show like a nested loading boundary, which is cool. But the basic test here is this counter has to stay live while I'm running the next page. This is the fundamental thing. And this is not a sync to async thing, so we could probably skip it. But the idea here is each page has its own counter on it, but the counter is being driven from some like higher up state. And you're like, well, that's easy. It's not a question of whether you lose the count that updates, because the count stays there with the app. It's not getting like lost when you switch between pages. It's whether the current page is still live while you're rendering the other page. That's the test. You don't want, like, there's tons of systems, or it's not that very hard if you make it yourself, that when you go to the next page, that you just kind of like stop updating what's here but still show it. Like maybe you cache the DOM nodes. Like Solid, you know, these are actual real DOM nodes, so you can just go like variable equals my UX, and then when they switch, you can just be like, oh, I'm actually going to hold on to these. You know, like you can, there's ways you can just like keep the DOM nodes there. But in Solid, our reactivity is such that when something disposes, like in a condition, like in a switch match or a show, we dispose of the children and this reactivity dies, right? when this tab switches to this tab, then this count, like anything created underneath in this tab. So let's go to child one. You'll see child one here, the memo here, create delay that fetches the data. But the time that gets passed through, where's the counter? Why am I not seeing the counter? Yeah, props count. This count, this memo effect, whatever that's rendering this one thing, would naturally get released because you've switched away from the parent. It's not getting released here. So yeah, this is I just included this because if you haven't accomplished this, then we're not having the same conversation. Right? Like this is the, now obviously you've seen this with React. It's really easy to do with React as well. All you got to do is when you go to the new tab, where is it? Set tab. When I click on it, where do I click on it? Yeah, set tab. Just wrap this sucker in a start transition. There you go. The only difference with our models here, and that's why I say React gets it right, is that you don't have to call start transition here. But I'm not stressing on this. This is the advert? I guess so. I mean, I think all of this is actually good. This is not the sync to async thing, but this is just showing that, like, this was the probably trickiest part to actually figure out, right? Because I didn't want to fork for performance reasons. So because if everything's a transition, it'd be really slow that like every click forks the reactive graph. That's freaking crazy. So I need to come up with a non-forking transitional model. So that's the technical part that's like quite impressive with this, but like from a UX standpoint, you don't have to worry, or DX standpoint, you don't have to worry about it. Like set a tab, switch it, stuff keeps on moving. See, because this has nothing to do. The key realization, if you guys are out there trying to figure out how this works, is when we lock stuff up for transitions, reactive dependencies matter, ownership dependencies don't. So this, even though it is owned, like the effect that's running or whatever, calculation running, memo computed, whatever the hell you want to call it, is running, is under the scope of, whatever thing that's doing the switch. It doesn't depend on it. So it can run independently. It does not get locked up by the transition, right? And to be fair, React is no different here. It doesn't use the reactive graph to make that determination, but it's a similar thing. With React, what they do is they go render the whole other page and then this page is still live, so it keeps it updating. So they just like create a forked reality. Originally, I was creating a forked reactivity graph, like kind of like more Git style, where you can merge like nodes to nodes. But then I came up with a new system that I've talked about on my previous streams. We're not going to get into, but essentially, this example is just here for people to vet like that they actually, because I saw a bunch of people going like copying my other demos and with different frameworks, or like with their like home, like with their own framework. I have a lot of those people in the Discord, very helpful. But then this is the demo that they were missing. This is actually like the first demo. Like this is, if you're like, I want to be async first, make this demo first. This is the fundamental piece. I didn't think Svelte actually passed this test originally, which is why I disregarded Svelte 5's async for like several months. And I think early days they didn't. But if you check Svelte 5, they passed this. So Svelte 5 is definitely, like, this is the criteria. This is the door of entry. Okay. Cool, let's continue. Okay. These last two are kind of fun. I'm excited for these ones. I need to drink some water. I hope you guys are excited as I am. Because this is where the whole picture comes together. And it hasn't gotten any, and this is because, I was working, remember we had Ricky on from React core team, and we were working through like how to do stuff with React, and I had my version, he had his version, and like I set up the question kind of unfairly to be towards my version of it, and he reverted it all around to go to his version, and then I'm like, both of these are valid. And then I was like, huh. That's very interesting, right? Like they're both valid approaches. And I was like, can we thread the needle? Can we accomplish both approaches in a way that doesn't feel awkward from a sync to async perspective, but like it's completely consistent? So like basically like do both, but better than both of what I previously thought and what he previously thought. And the answer to that is obviously yes, we figured it out. So that's why I'm excited about this, because this is when like I'm hoping the light bulbs come, if they haven't already, where you're just like, oh, okay. So let's go back. Let's go back to my dashboard. Let's leave this. Nothing in here is worth saving. Okay. So I made an example here that I've used a few times here. It's not full to do. I call it solid to do simple. Okay. And I've used this in a recent conference talk. All this is it's the to-do MVC example. Oh, I haven't even, did I update? I didn't even update the, oh no, I did update this one. Okay. Yeah. And it's, the key thing is there's only 3 actions in this. There's add to do, remove to do, toggle to do. We don't have edit to do. We don't have like select all behavior. There's like 8 or so different operations in to do MVC, and they're all important. But this is, I want to simplify it down to a demo that I could actually, like, if I want to real time code it, I could do it, right? And the way I set this up is pretty simple. You have your typical to-do app, and then there's a loop that renders each to-do, and we pass in toggle to-do and remove to-do. This is very common. You might be like, why don't you handle this locally in the to-do? Well, if you think about it, you're managing a list. So list lives out here. What I love about the 2MVC example is it's the same example essentially that React used when they introduced their compiler. Everybody, like, this is just like one of the most like first examples to show when you're talking about data hoisting, right, as a mechanism, and then how like memoization impacts that, right? So I've used this in Solid a lot to show fine-grained updates, right? It's in our tutorial, essentially. And because the key part about a to-do app is that you have the to-dos like up here somewhere, and then you do have operations that matter on a per row level, like if you want to toggle them on and off or remove them. But essentially, there's a class that we apply that shows them crossed out. This is fairly simple synchronous API. I have a couple event handlers that just wrap. You might be like, why didn't you just inline them? Well, it's because the inline event has some details on it. So it's easier so the person can consume it to have a simple ID like remove ID or toggle ID and whether it's completed or not, you know, like information like on the event so they can propagate it back up. So like we obscure the actual like DOM event here so that the consumer can just basically do operations directly on it. Now, I purposely set this up in a way that there's a to-do component, there's the main component with a list, and then the events handlers are, as I said, they're just wrappers that are nicer for API. The on-input event handler is actually a little bit, as I said, it obscures the DOM stuff, but it has a lot more logic because you have to like trim the input to make sure you can even submit it. Have to, like in this case, we're actually doing like a key, we're checking for keys. It's funny, to do MVC does this, like it's not like an on change event. Like they want it, the whole thing with to MVC is, yeah, like they don't use a blur. They actually literally use an enter key. I just copied this thing. There's some logic about like clearing the input, and then ultimately we create our to-do and we add our to-do to our list. But essentially, the DOM stuff's out here, and then what this let me do is create like a little to-do store. Now, I could put 4 to-do apps on the page and each have their own store. So this is not necessarily global. That's why I did it this way. You're actually creating an instance of state in your component. It's just organized as like a store. You can put in context, you can do whatever you want. This is a pattern I use. I don't know other people use this pattern very much. I love this pattern though, where the first value is the readable value, and then the second value is the writable value. You're like, oh yeah, of course, like use state or set signal that. But what I actually do this for stores as well. A lot of people like this co-location thing. I do not. I put my named actions on an object that I can destructure, because it's not reactive. These are the action side. So I can just like list them up. What can my store do? I can add a to-do, remove a to-do, toggle to-do. And then the store itself, which is actually a solid store, it's an array, a read-only array of to-do here, is just the data that we use. Like this could be an accessor if it was like a different thing, but I use this if we're using signals. But our to-dos implementation here is very much a store that's an array, and then add to-do is pushing to that array. This is the new produce style API default that we have in Solid 2.0. Set is filter, and then toggle is finding the one at the specific index and then switching the one thing. Why do we not just like do map filter through this whole thing? It's because this is granular. I want it so that when we add our items and we toggle them here, we don't rerun the whole list. It's just the completed on the one row that updates. So this is super fine grained. Like obviously filtering keeps references so that the list still has to, when you do a filter operation, the list has to diff. When you do, because it needs to know like which ones have moved, changed. When you do an add operation, you know, you basically have to trigger the diff. But when you toggle a to-do, there's no reason to run the for loop. Like there's no reason to rerun the loop. It doesn't change anything in the loop. It only changes this one place. So this is why you use stores, to be super granular. Nothing gets updated that doesn't get updated, like doesn't need to get updated. This does not cause any components to re-render, does not cause the list to diff or anything. It literally just does the one update. We've demoed this a million times for Solid Basics. But the important part here is this is very clean. You create your store, you don't give people the store setter, you give them very specific actions. And by just using internal primitives, we don't need, like this is Zustand, you know, like this is why you don't see state libraries in Solid very often, because you can create your own conventions, ways you want it. And it's very reusable, very powerful. And like, you know, you're off to the races. You didn't need anything else. You know, you keep your code organized, and there you go. We have our to-do store, our UI logic. We're happy. Okay. Everyone's still with me. Sorry, chat. Whenever you guys get quiet for like 7 minutes plus, I get worried. Part of it is I'm probably going too slow, but that's kind of like my threshold. Okay. So who cares? This is your to-do MVC. What are the to-dos, you ask? Well, let's look at our implementation here. To-dos, we have an array. It's just an array in memory. So when I refresh this page, sadly, all our to-dos are gone. Right? So now we're like, crap, we need the persistent, right? And you use Xstate store with Solid instead. I mean, again, you can. The only challenge with stuff like Xstate, I mean, I love Xstate because you need something to coordinate all the state management. It makes a ton of sense. The challenge, of course, is that a lot of times the stuff's immutable. I've been doing a lot of work in 2.0 to improve the efficiency of immutable diffing so that we can actually do immutable diffing under the hood, which I'm very excited about, because we actually don't mutate the references under stores anymore, which means that when you do immutable diffing, we can just swap references. And this means that like, it can be super efficient because we literally do, if no one's, it's like a tree falls in the woods thing. Like if no one is listening to a specific reactive path, we don't need the diff. We can just swap the references. We basically can walk down the traversal, which is a real thing when you look at how for things to react, you have to keep the reactive path intact, which means it's a safe heuristic here. So we can literally go like, which properties in the stores have signals, because we create them lazily, and then be like, we can diff along those signal paths instead of the whole thing. So you can have a huge store of data and then diff the whole thing, like replace it with something fresh in the server. But if you only listen down one specific path, like user one, blah, 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 we literally don't have to do any work. We don't have to diff. We just like, we just go, okay, diff down this. Does this user change this one, this? The whole rest of the array, the whole rest of the whole thing, just, you know, like other data not related, we just shortcut. So this is a new thing in 2.0 that I'm excited about, because it kind of marries the benefit of React, which is diff in the UI, but does it at a data diffing level, because basically we know what gets used. Anyways. Okay, so now we need local storage. So what I did was I created an API for this. And it's approximating delay so you guys can see it. But the idea is get to-dos is calling, it's delay get to-dos, but the actual get to-dos, there's only two actual real APIs. There's get to-dos and save to-dos, which basically just parse stuff and store in local storage. And then there's a delay timer, which just wraps a promise, right? So essentially, I just created an API from this that like you could pretend it's like JSON API or something or whatever. It doesn't really matter what it is, but it's like get to-dos, which gets the to-dos, add to-do, which then adds it to the database, so to speak, like creates the structure and then it saves it and then returns the last item in the list, remove the same thing. This is literally just like a fake API server database setup. So even though there's only like 2 operations to save, we essentially expose our get and plus our 3 operations to save it. Now, as you can imagine, there's a couple ways we can take this, and that's really what this shows. The optimistic UI is the way that Ricky approached it, and optimistic data was the way that I approached it. And we've seen these examples before. In fact, optimistic UI is what Remix first showed off when they first showed the optimistic updates. Remix was way ahead of its time in terms of showing the whole idea of ephemeral optimistic updates of state. Genius work. I know I say it every time, but honestly. But he actually provided me with basically both demos, even though he didn't use to-dos. The optimistic data is what the Trello demo that he did, or Trellix or whatever that he did for Remix, was that. And there's a subtle difference between the approaches, but I've now been able to kind of categorize them into 2 categories, because I always kind of lean towards optimistic data, but the React APIs kind of lean towards optimistic UI. Now, don't get me wrong, you can do both, I think, with both if you're smart enough, because yes, we know you can do that, because if the Trellix demo was possible in Remix, then conceptually you could do the same thing. It was React, so you can do the same thing using React APIs, albeit less efficiently, but definitely still doable. So I this is kind of what I want to talk about. So let's start with talking about optimistic to-dos. And I want to start with the to-dos this time, because I'm going to start with the to-dos this time. What did I do for create optimistic to-dos? Well, what I did was I took our store, and instead of starting from just the array, I actually fetch the data from the API to get to-dos. Which is kind of like, okay, why does this work? Well, it's because, again, promise a to-do array becomes store of to-do array, right? This is the same async stuff. When I added it, I didn't just add it to signals and memos. I added it to stores and projections as well. So we have that same async system through our deep nested granular stuff as well. So this could have been a store. Someone's like, in the same way that you don't need create memo if you have create signal, we could have kept this as a store, but I chose to make this a projection because we don't need to write to it. Right now, our database is our source of truth. So what do we do? Now, this is a new API. You guys might hate generators. I don't know. This is a fundamental problem that's very hard. Even though I could get rid of the start transition wrapper, I can't. There's no way to connect what happens beforehand, like this, to what happens afterwards with async JavaScript. You cannot resume the context. There's no async context, no async local storage. We still need the ability to connect them together. Now, if you remember the React approach, they would call like start transition, and then they'd call start transition again, right? Since Solid can do parallel transitions, we actually had to have the action helper pass the second start transition, the resume transition through it. It was terrible. So instead, I looked at MobX, and in MobX they have something called flow, and it's very powerful, right? You can just yield promises, you can create sequences, and what's beautiful with this is, the context is refreshed automatically. I don't have to ever remember to call start transition again. I just have to remember that, instead of awaiting an API, awaiting a promise, I need to yield it. That's the biggest difference here. I know people are not huge fans of generators, but out of a bunch of terrible options, this one was the best. Now, some people have issues with TypeScript. there's solutions for this that I'm actually kind of excited about, but a bit beyond the scope of this. First of all, this also supports async generators. So technically speaking, you can still wait in here to get your values out, and those will be properly typed and then yield. It's a little weird to yield like await then yield. So I don't end up doing it very often. So you know, I get it. A lot of time with actions, we don't actually care about the results. If they error, then they throw and we handle it, you know, or like they like the other thing that I'm looking at is I haven't shipped with this, but it's in the tests, is that we could also make a helper that's like res error and just be like yield star attempt API dot add to do. And in this situation, we would be able to get proper type information and through this and like remove the try catch blocks. I think this is super ergonomic. The only reason I'm like hesitant to add this to solid core is because like, what if you want to make attempt with retry? I think there's a whole world of generator based helpers, you know, kind of like RxJS, the whole world of operating just helpers or whatever that could exist out in like primitives land that I don't need to worry about from a core perspective. And to be fair, a lot of you will never use the generator API because let's say you're using solid router and you're using the automatic invalidation. You won't need the generator. You just pass in your server function and set your keys. And this mechanism will be hidden from you. Under the hood, I'll be using the generator, but you as a developer will just be like, pass me server function, say what keys get invalidated, done. Like that's the thing. This is a low level primitive, but it's still high enough level that I can make convincing demos out of it very easily. Yes, resume was that bad. It was, I can't stress over it. It's so bad that even though React's like kind of living with it right now, I do you know how bad it is? I'm not gonna, I don't want to hate, like make Ricky feel bad about this. I watched Ricky demo this feature, framework author, you know, like guy in the know, like myself. And I know because I had this on myself. But you practice your talks ahead of time. You're ready. You go. I saw him demo it on my stream. I saw him demo it at ReactConf. I saw him demo it on Learn JSON. And every single time he forgot to do it. Every single time. And it wasn't like, oh yeah, I forgot to do it. It was like sitting there for a couple minutes going, okay, what's wrong with this example? How do I do this? Oh, what did I miss? Do this. And don't get me wrong. When you're on the spot like that, you do like that and you don't see the obvious. It always happens. It happens on stream. I'm like sitting here and I'm like, what happens? So, but it wasn't like the, oh yeah, obvious. It was like the, okay, what did I miss kind of like level every time. Now that could just be like unlucky, but that sort of thing is partially why I think async React hasn't like quite clicked with people yet. I know it's a stupid little API decision, but I think like the having the call to second start transition, even though it aligns more with the future and it plays in context, is the biggest. The funniest thing is it's not a huge foot gun because people won't notice and they won't quite get the right behavior, but it'll kind of work and they'll probably push through it. But it is like the difference is Ricky knows exactly like what he's expecting out of the demo. So when he sees it not do that, he knows that he's like, there's something wrong. But the fact that it's not immediately realizable is super detrimental to the point that I don't think that API from my perspective is shippable. Like it is, and it's even worse as it's kind of worse being in the signature with solid. It's like awkward, it's bulky, it's like it's just like it is terrible. I've never been a fan of generators. I think it's too hard for people. Like people see generators and like, oh, I don't understand generators. I don't know them. I don't want to work with them. You know, and like that puts like a shelf on things, and you're like, oh man, this sucks. People are gonna be like, what? I didn't know you could put a star after a function call and like what yield? What? That is how bad having to call start transition a second time is from my perspective. Like it is every complaint that people have ever had about React, like forgetting dependency arrays and like it is because I had this happen to myself even so many times. like I get stuck. I get stuck for a while. I'd be like sitting there working demo, and I'm like, what the hell? It's because in the case, it's because I converted from a generator to an async function. Just kind of because I was cleaning up. I'm like, I was trying to make it like a demo, for a talk or something. And I was like, oh, I shouldn't use a generator. I should just use an async function. It took me like 10 minutes to figure out what it like. It is terrible, absolutely terrible. Asking what it is if this was and this is a React Start transition API. If this was an async function like this, conceptually, and like, so we have an async function, and then we like awaited here. For this to work properly, you have to actually call action again like this, because you have to be able to associate it back into the transition. React calls it thing, but you have to remember that after you do await, you have to wrap anything else that you want associated with another call like this. This is if this wasn't a generator. I mean, linters could catch it, I guess. It's just like this isn't even this is just there's nothing good about this. You don't get composability. There's just nothing redeemable about this API. It is one of the worst APIs I've ever seen. Anyway, yeah. So they're like, yeah, actually, what's even the linter rule? If someone calls any function after an await inside a transition, well, the funniest thing is you don't even know, because if you look, I can pull up Ricky's demo. You start making convention, like one of the differences that Ricky did was he put the transition inside the components, right? So then you'd be inside a transition scope or an action scope or whatever without seeing the action call. So like you would basically just get the async function, and you would then have to know that you need to call action again after the await. Because like you might know, because like your component calls it like click action instead of on click. So then you're like, okay, this is an action. I have to make sure that I call this action again. But like, yeah, I think this is worse than use effect. Like, this is one of the worst. Like, I couldn't. It's funny. I'm usually not so heated about this kind of stuff. I could never ship this API. It's so bad. I'm willing to like, yeah. Anyway, sorry. I'm willing to look at generators, which I honestly not a big fan of. Now, if we had async context, maybe this all goes away. So there is that. But no, Svelte's solution is more similar to Solid Router's solution. Like their optimistic solution is not a generic solution that's in the base of Svelte. It's like something I think built on top of data fetching and SvelteKit. Like it might be more outside of SvelteKit. I'm not 100% sure, but they're not creating a generic optimistic mechanism. They're creating an action that has a very specific semantics. So like I didn't have to worry about generators when I was building like Solid Router. Yeah, like yeah, exactly. It's more like what we do in the router. This is low level API. You'd build APIs like Svelte's API on top of this, and people will, because they don't like generators. Solid Start probably won't expect people to use this kind of actions, but I can build every one of these demos without JSX, with just the signals library. There's nothing intrinsically like this is just pure reactivity we're talking about. Okay. So now that we're past generators, the refresh is something that comes from the API that takes either an accessor or a refreshable store. So this is not too hard to picture what it does. Projections, when you return a value rather than mutate, do a reconcile under the hood. So what we're basically getting here is every time that we refresh the to-dos, we get a fresh batch from the server. It does a data level diff on what's currently being subscribed to, and then updates just the places in the API that differ from where it is. That's the gist of it. So we can perform an action, do a refresh in the background, and get fine-grained updates. Super simple. People probably love this pattern, right? So nothing to worry about or think about here. Okay. Now we should talk about our app. Now, there's one thing that's very interestingly different here between what I did and what Ricky did in his demos. Even though this is what I call the React kind of style, I put the action in with the data. It's in this thing, because this, if you look, this hasn't changed. Create to-dos has the same interface. I didn't put the action down in to-do component or, you know, or like, and I didn't make custom input that's like has exports an action thing. The source of the action is in the data, not in the UI. And this is a key distinction, but it helps us bridge the gap. Yeah, I imagine so. I think you guys were asking me earlier about effect. I think this is where effect comes in. I think you have the reactivity to show the graph. And if you have like, if you basically most events that do complicated sequences of stuff, that's where like effect comes in. I haven't looked at effect closely enough, but like I think this is the bridge point. There's kind of two different sides of the coin. Anyway, so now just to kind of demo very simply, I'm going to comment a couple things out because they'll make it easier here. My code here, if I didn't need to do anything else, would just add a loading around it. And you can see here, when we load, there's a loading thing here, right? That hopefully should go away. What did I break? Did I break something? Demo has been working the whole time. What did I break? Oh, that was weird. Wasn't that weird? Oh, it's because, you know what? No, I know why. I commented this out. Sorry. What am I doing? I commented this out, but didn't comment out where added is used. I like what sorry. Okay. Now it should work. Yeah, okay. So what I wanted to show here is if with the change we made to the data, technically speaking, this is the exact same function that we were using to add a to-do before. And then the UI, I have not actually changed a single thing in here or here. This is some optimistic thing that I added. To-dos also don't need to be any different, okay? So if in a world like that, the problem is when I add async and I go, hello, there's a delay. Like the input disappears, but there's this like time period where there's a delay. Now I have some other optimistic updates here, so you're not going to see it properly, but I go, so if I go, and if I add a bunch fast, you know, you don't really get to see this. So yes, we successfully added async, but we have no indicator that async is happening. So we need UI for that, essentially. Now, the easiest way to do that, which kind of almost the way Remix introduced it, is that we add optimistic state here, right? So this is where I add create optimistic, so I just undo what I did previously. And what optimistic here is an array, and when I save the to-do, I also add it to an array of that started as empty. I just add it to the array. So this is our action, add to do, but then we have an optimistic update that we do here. And then down here, I make another for loop where instead of going over our to-dos, I iterate over the added items. And what this does is when I go A, B, C, D, we see them all come in as they do. And then when it resolves sometime in the future, assuming it matches, then nothing will update anymore. Because essentially, I mean, the UI will update. There's a difference. Items move from this list to this list, technically speaking, but you should probably see the same thing, right? That's kind of the gist of the optimistic thing. And we don't have any additional affordances in this example. We could, like originally when I made this, I actually didn't use a to-do. I actually used like I copied the code from the to-do and then like showed it like grayed out with an opacity. So you couldn't do any like operations on it. So like you could see the difference when I was loading in. But if you have no reason to do that, then there's like no reason to do it. Do you know what I mean? Like if you don't need an affordance, like what I'm getting at is if I add a to do and I click checked on it or remove it while the stuff's still on flight, I didn't remove the check one, I moved the one above. It's still gonna work. It's gonna actually save, it's gonna send off those requests. I can interact with an optimistic piece of UI because it has the ID, it has like in this case, I have everything I need to. So when I call toggle to do on this, the created to do already has an ID, so it can save that while it's still in flight. So like we can get ahead of the optimism and layer on as many layers as we want, right? Like this is quite a powerful mechanism, right? Like so the reason you don't see any affordance for optimism in this example is because we're pretending like it's sync. It just like I can do any operation as I want to. And as I said, I got this from Remix. This is the first example where they mapped over the to-dos and then they mapped over the adding to-dos. I just think we've obviously it's a little bit more ergonomic now where we can just say, give me some optimistic state. Like it's not tied to specific like form action or whatever, like kind of piece. Like you just go, give me some optimistic state and then do that. And the key here is like, I pass my actions here also down through to do like I was doing previously. I didn't have to change that wiring. And then down here for is removing, set removing, I create some more optimistic state. I'm like, if I'm removing, it's a Boolean. And my optimistic completed, well, it's derived because optimistic, it's like create signal. It can be derived or a value. It's derived from props to do being completed. So the way optimistic state works is while the async is in flight, it will use your override instead of using like the actual like value. So like when you set removing to true, it's gonna, when you read is removing, it's gonna be true. When the async ends, it's gonna set it back to the reset value. So it's gonna set it back to false. But in the case of like when it's derived, when the async ends, it's gonna set it back to whatever it's currently derived from. So if you click a completed, which sets it to true optimistically, and then the server comes back and the async ends, well, hopefully the server also updated and sees true, and then they'll see true, I don't have to do any more work. But essentially, even if it started as false, it won't reset to false, it'll reset to true because that's the current value from the server when the async resolves. And then the stuff itself for the optimistic, I just put set completed, checked, and then I call the prop handler, set remove true, checked, like I said. And this mechanism automatically handles the reversion. So this is what made that ephemeral state so powerful, is because you ever use GraphQL for optimistic stuff, like where you like pagination, where you're like you're managing the cache yourself. The reason the Remix model is so powerful is because you're not managing the cache. You're kind of keeping it separate. You have like your truth layer coming from the server, and then you have this like sort of optimistic layer that's transient that sits on top and then removes itself. That's essentially it. And as I said, in React, they were putting the start transitions down here. The difference with this model is because transitions are implicit, they're already there. By default, everything in the same tick is going to be part of the same transition, right? So like when you handle an event, the optimistic state, the action, all that gets tied up in the same transition. So you don't have to, the wrappers can exist with the data instead of with inside the components. So the component, again, this is kind of like the is pending parallel I was talking before. The component can decide, hey, look, this is a little less detached perhaps because the component has to be somewhat aware, but it can decide, hey, I have optimistic behavior. It doesn't really know what the action is here. In this case, like if you think about it, like I was having a hard time when I was struggling through this example because I'm like the checked is pretty easy. You as a component can know, like if I have a function to be checked, and that could cause something async, then potentially I want to be able to show some optimistic state to show that my checks succeeded. But like, who removes themselves? That like it's a weird thought. But again, it was easy. If I show myself if I'm not removing, if I'm removing, I just remove myself, right? And again, I can. What's cool about this is I was able to replace references to props to do dot completed with is completed, and I just know that when I'm under async or not under async, it's just going to give me the right value regardless. So this is the key improvement over the the aspects that I found challenging with the Remix API and that I got from basic core React is I started writing these tons of combinatorics around like, if this is pending and this is pending, then show this and like to do math. I guess I still would need to do this if I created multiple optimist states, but I can kind of choose the granularity in which I merge it in with. It's not necessarily tied to a specific action. It's tied to the state has a definition rather than the actions each saying like, hey, I'm pending, and then you have to do the combinatorics. The combinatorics exist in the state, and it's the responsibility of the actions to be the ones, or the events to be the ones to decide how they participate in it. This sort of like semi-decoupling makes the logic a little bit less error prone. But what's cool is the action itself is just another participant in it. You don't need to we don't have the this is still on toggle. It's not on toggle action because effectively everything's under a transition. So there's no need to differentiate that on toggle's an action or not, because it's all a transition. Yeah, wrappers exist in the data instead of the component. Is that right? Yeah. So yeah, this is super powerful because it's basically the same demo I made with Ricky, and then I just overlaid some optimistic updates in it, right? But this wasn't good enough for me, right? I'm like, okay, so this checks off this box, but if oh, hey Theo, how's it going? I will talk about async or sort of AI a little bit today, probably, but I am not quite there yet. I'm on my last async to sync example right now, which is kind of cool. It's a to-do app. Which is not very cool, but the power of it is really cool. Okay, so what if we took a different approach? And that different approach is this last example. What if I told you that we could have async and literally not change a single piece of code in our example? So remember, look here, in our UI part of the example. So let's go back here. I'm in my app. I have my to-do app where I create my to-do stores, on input, trim, add to-do, go through for each to-do, remove, toggle this. You remember this code from a bit earlier. Now, look at my optimistic UI example. I updated the stuff to use some async, which is still pretty easy to do. But then in here, I had to add the optimistic state. I added the extra setters. I added the second for loop. I did a few more optimistic overrides. Kind of call them the toggle and stuff. I mean, don't get me wrong. This is sometimes you need this because when the affordances diverge from the future, it's important to have this mechanism. This is super powerful, super clean. This is already much cleaner than you've probably ever seen with React. But we can do better. So what I did with this example is look at it. This is our exact example. Again, to-dos, on input, add, our code. Okay, I added a loading boundary. Sorry guys, there's one loading boundary because I mean, it's not even necessary as we know, but I added it. And then in here, we just call props on toggle. So yeah, I did not change any of our UI code. It's the same UI code that we had when we were synchronous. So what did I change? Well, instead of doing optimistic overrides granularly in those places in the UI, what if instead of changing our store to an async projection, I make an optimistic store? So now our data is optimistic. It's not just like normal async data that propagates through and then we add optimistic API. We're now saying that our whole data store is this piece of optimism. And again, Same kind of thing. We don't care. What's this? Promise of to-do array? Well, that gives us a to-do array, right? Yeah, it does. Because we can pass promises, we can pass generators, we can just absorb any async source and just get out a signal essentially on the other side, or a store, right? So that part's the same. The actions look almost the same, except what did I do? This is the fun part. If you look at the simple to-dos, and you look at what my actions are here, essentially. When I add a to-do, I call set to-do. When I call remove to-do, I call this on the store, and these are all just basic store operations, right? When we did optimistic UI, what did our actions look like? Well, we yielded our add to-do, remove to-do, and then we called refresh on them. When we look at our optimistic store example, we just do both. Our optimistic update is our original synchronous store update. Then we do our action and we refresh. All we did was just add the optimism in the form of the original updates. So if I was going from sync to async, all I would do is wrap my function in a wrapper, keep my synchronous code, and then add my async code to it. And what's really cool about this is, as you know, optimistic auto reverts. If the server doesn't agree with the client, it fixes itself, right? Using that fine-grained data diffing we talked about already. So the end result is it's just the same thing again. We literally kind of combined the more complicated optimistic UI approach of that. Well, I mean, it's just we took async, we took sync, jammed them together, and then our app does not need to change any code. And as you guys know, this will just work perfectly, optimistically, while our async is happening. Like, we don't care how long that to-dos takes. Like, because we're living in this async world, I can go in here and go into our API, and I can go, let's do something dumb. Let's make getting the to-dos take like 2 seconds, something like stupidly long. So yeah, it's going to load for a while here because I did that. But now we're doing this, we're checking this. I swear to you, these are no way they could possibly save in the time that 2 seconds, but we're good because we're basically working on that optimistic UI before it even comes back from the server, which you can do without optimistic data. But the key part here is we didn't need to change any of our synchronous code. Even in the actions, we can keep our previous synchronous code as our optimistic update. The only thing we had to do is be like, okay, let's save it. No, yeah, I didn't think anyone would get it. This is like groundbreaking. Yeah, that's what the goal is. Because when you go in here, all you cared about was the simple stuff. You're like, look, I have a to-do, I want to add it, remove it. The wiring here shouldn't change because async happened. So I was able to abstract the asynchronicity, the optimism. Do you know what this is like? It's like a sync engine, right? Except it's not a sync engine. I just gave you a sync engine without you having a sync engine. Like you're not worried about async. Stuff just happening, works perfectly, purely optimistic. You're writing synchronous code. And guess what? It's because we decoupled it. We don't see sync engines work because they give you incremental updates. This is not incremental. This is terrible. I'm refreshing the whole to-do list every single time I'm doing it. But you can't tell. It doesn't matter. You can swap out the protocol behind the scenes. We've made a consistent reality. What is the difference between create store and create optimistic store? Create optimistic store reverts. If the reality doesn't match, you're right. To sense, a store could like when the data come in diff, but the problem is, okay, let me explain. This is a harder question to answer slightly, but if I just left this as a store, then like all the race condition stuff that we were dealing with earlier, we're using the actions here to actually ensure consistency. So we don't want like optimistic stuff to remove too early. when you click it 3 times. You don't like if you go delete, 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 and things come in at different orders. You don't want like things to kind of jumble around where like something deletes and then comes back again. You know, like because you optimistically delete it, but then the first data come back from the server has the deletion, like has the item still in there. Like the benefit of this optimistic store is that it actually knows how to handle the reversion properly, and it's like transitionally aware of that piece in the life cycle. Don't get me wrong, people are probably going to do this, not realize, and I mean, let's do it. Let's see what happens. Like this probably will still work in this example, especially when there's no errors. Oh no, the other difference is it's not going to update the UI right away. Think about it. If it's not an optimistic store, it's not an optimistic update, so it has to wait for the transition to show anything. Sorry, that's the biggest difference. If it wasn't an optimistic store, then yeah, sorry. This is taking so long because I made it 2 seconds long. Sorry, let's just go back. Yeah, sorry, duh. If it's not optimistic, then it has to wait for the transition. You're not getting optimistic updates if it's not an optimistic store. Yeah, great. So we don't even have to worry about that. Yeah, sorry, my bad. That's like the obvious answer. You want an optimistic store because you want optimistic updates. Right? Okay, so we got some questions coming in. How does the state from the server flow back down into the to-do state value? Right here. Because we call refresh. Remember, this is part of our like smart graph thing. Refresh to-dos tells us to rerun this function, which tells us to fetch. And then create store uses reconcile under the hood, which is a fine-grained data diff, which I described a bit earlier, where it diffs along the subscribe path. So it's fairly efficient. It's basically kind of like a mini version of what React does, where React, you only diff the UI, like the parts that are used. This is a similar diff that only diffs the parts that are used and then swaps out the rest. And then the parts that use get notified if they change. That does fine-grained updates in the UI as the stuff comes back. What's beautiful though with Optimism is this, again, why the stores are awesome, is because the projected optimistic layer is stable on top of where you're at. So if you add a to-do optimistically, it creates DOM nodes, right? Those same DOM nodes are present when it tries to diff what comes back from the server later. So if nothing changed, you get to reuse the same DOM nodes. And in fact, if nothing changed, you don't have to, nothing reactive gets propagated. So we don't have to do any further updates. Like it's fine-grained. It's funny, it's not fine-grained over the network, but it's fine-grained from every point on there. So from like a developer standpoint, it's like if you ignore the network tab, it's a sync engine. That's the best way I can put it. Like that maybe people understand. It's just like the framework from data forward is so optimistic, or sorry, so optimal that like we don't do any additional extra work once we get the data. Like the network protocol doesn't really matter. I mean, I love sync engines and incremental data so that like you can not shove it all over the wire, but that doesn't prevent us from doing the best possible thing in the UI. What about reorders due to network shenanigans? Okay, yeah. So there's two things that we have working for us here. One thing that we have working for us here is that the refresh, the store itself or the async things are self-canceling. So it's only the last refresh that will get through. The second thing that we have going through for us is because the way entanglement works, and especially with optimism here, is even though, see, people complain about how React makes everything a single transition. We don't make everything a single transition, but like in cases where things are related, like we're operating on the same to-do list, they actually are the same transition. When I clicked like crazy there a moment ago with the 2-second delay, they all overlap because the overlap of the same data requirements in terms of what gets set here, in terms of what gets refreshed here, we actually are entangling them. So they're all part of the same transition, which means that we're not going to lift the transition until all of these actions are completed, which means even though we're showing stuff optimistically, the stuff coming back from the server is not going to be like, I am true until everything is processed, right? So with those two constraints in place, you essentially, like, don't get me wrong, there are still, we can talk about in a second, there's still some race conditions that can exist, but you eliminate like 99% of the race conditions, because this is why we want action. This is why we want to connect the before to the after, so that they're not treated as separate operations, because it's really important that just because we're on part A, like we're saving and we're refreshing, we don't want those to get untangled from each other. We want to make sure that if another operation comes in and they overlap in such a way, like that, this one refreshes before this one does, like, and they don't, like, they need to know that they overlap to ensure that they stay consistent. Now, to be fair, a lot of times, if you don't have optimistic state, you're not going to notice that, and it's actually perfectly fine. It's just optimistic state because the way it can like disappear on you and bounce around, it makes it very evident of when these issues happen. But on the flip side, optimistic state is informant for us because it's a part of the reactor graph. We now have a new heuristic on which to entangle on. So, like, it lets us be smart. Actually, adding optimistic state informs entanglement in a really clever way. So it's not 100%. We talked about this in a previous stream. I think we had a really hard time, like, because we went through Jose's from live views, all those complaints about like out of order timing things, and I think out of all of his examples, he had like 8 of them. There was only one that actually was still applicable, but it was like kind of like one that we were like, the only solution would be like almost no one working in the client-side app has any expectation that this case would suffice, like would be there. Like we're used to dealing with systems that only handle maybe 2 or 3 out of the edge cases, and so coming down that the baseline of just doing the normal idiomatic thing handles 7 out of the 8 edge cases is like such a drastic improvement that if you want to handle that last 1/8 of the edge cases yourself, like, go for it. Thank you. I get it. Yeah, this is the funniest thing about this. I'm like trying to explain like why it's clever on this, and then when you look at the actual code and you actually like just do the thing, you're just like it was one of the most anticlimactic moments when I finally got, like, I've been making these demos with Create Async and I've been like going through them, and I was like, okay, cool, this looks cool and people could get it. And then I removed Create Async and then I removed this and I simplified this, and then I was like, man, how am I going to demo this stuff? It just looks like you write the code and it just does what it's supposed to do. No one's going to be like, wow, Ryan, like this seems like what I want to use. They'll just be like, doesn't everything work like this? And it's like, no, not at all. Like, it's so obvious in hindsight, but it's like, yeah, it's one of those things. Okay, what else we got here? Can you add some randomized failure operations? So like, yeah. The problem is I can. The challenge here is if you add failure, your UI code needs to be able to show the failure. So if I made the affordances, I could go and add that and show it working. Right now, the easiest way that I actually show this working, although it doesn't always work with stack blitz, is I open up 2 windows and then I start typing in one window and the other, like the WebSocket example, right? Where I update in one window and then update in the other window, and then like you'll see the updates from each window show up in the reconciled results. Like I mean, I could probably do this right now. The problem is it's really weird. StackBlitz sometimes gives me different local storage. I don't know why. I almost have to like start over. But yeah, I mean, here's the thing. And this kind of relates to the Jose thing. If you're in a system that's real time where you're expecting to see updates from other clients all the time, and it needs to be consistent, like you have a WebSocket open, then you have a different sort of expectation on UI where that last case that Jose was talking about actually matters. But most people, where you're working on something and it like only updates when you perform an action or do something, and like it's not like live in the background, your expectations can only go so far in terms of like how the UI the UI works. But yes, I think the biggest takeaway for me when I started working on this example was, and it became really obvious when I was working on the optimistic UI example, when I because the more I made this like the sync example, the more that I made it just work as if it was synchronous, the less the less specific affordances I came up with. It approached this optimistic data thing where basically the UI is the same. But the thing is, async and errors are real. So the exercise of going from sync to async is mostly an exercise of showing how the success path is smooth. Even with stuff like this, you have to be aware that, hey, stuff takes time and stuff can error. And that stuff can error thing can happen before async. Most demos don't have error handling, which is why this demo does not have error handling. If we had error handling, we would already have the affordances to actually finish the demo to show what I wanted to. Now, the remix demo did have error affordances, so it is worthwhile at some point that I make a demo that shows this with the error affordances. But I think one of those kind of real things I realized is that optimistic updates always require optimistic data, but only sometimes require optimistic UI. That's the takeaway here. So like, what I mean by that is optimistic data here in the optimistic data example is actually just this create optimistic store, right? It's a self-reconciling, super smart, async safe storage, right? In the optimistic UI example, the optimistic data is these create optimistic calls that I have, in a couple places here. But in the optimistic UI example, because of the way I put the data, I was pretty much forced to make some changes to the AI, to the UI to represent it. Whereas in the other case, because it fed through the normal data channels, I did not need to make UI changes. But let's pretend that we had a requirement here where when the stuff is new, we wanted to show that it's new. So like we highlight it green while it's coming in or something. Now in the optimistic UI version, this is fairly easy to do because we just like put something on this to do in the second for loop and just go like make them green, right? Done. With the optimistic data version, we now don't have the data to necessarily to represent that, so we'd have to add it. Maybe when we add the to-do here, when we push it on, we go to-do with pending true. Now this field doesn't exist on to-do today, but it's fine to do this because optimistically you're adding the same to-do, but you're adding pending true. Now in our UI, we will be able to render something with that pending true, like show the green. But then when the server comes back and refreshes it, there will be no pending true on the server, which will remove the field, which will remove our green. So there's a lot of play and flexibility with these approaches. But the thing to keep in mind is none of this stops you from having to be aware that things take time and that you need to handle errors. What it does do, however, is simplify the wiring so that there's basically no difference between sync and async. That's the pitch. Why is this feeling so simple? Solid URI, solid things. see, one day. So data diffing only works on simple data structures like lists, maps, those are objects, and that's it. Yeah, I mean, here's the thing. Stores have this built-in diff when you return like projections, like when you return the value, but these are actually mutable. So it is completely possible to define your own diffing algorithm and stick this in here and return undefined. If you don't return anything, return void, then you can create your own diffing mechanism, because they pass the store in, like you get S in and then you mutate it. That's the actual API on here. So you can create other diffing mechanisms if you want to. It's just like the base case is fairly straightforward here. And yeah, stores themselves only really support objects, arrays, simple data structures. Yeah, but I mean, again, for the most part, this doesn't get you in trouble, because like, what are you dealing with? Most things that you're serializing are JSON or JSON-esque if you're like talking to a server. I mean, I'm sure there's extents or like there's exceptions to this where you're going to need to do smarter stuff. But yeah, like, yeah. Yeah, that's what I was talking about sync engines. The difference is this is handled, this is like just what the framework does, where TransactDB is like manages at your data level. This is like, there are similarities here. A lot of the work that I did when I was working on these features was inspired by that, and I wanted a solution that worked really well with sync engines and things like TransactDB. Like if they go through all this trouble to diff your data, do incremental updates, and push that through, sending it to React to re-render everything seems like such a waste of time. Like it's fine, React will handle it, so to speak, but it's just like you do all this work to be incremental, and then you're just like, throw it away, you know? So yeah, I want it. The thing is, and I've done this a few times, even like when we did server functions in Solid, I wanted to give the capability of more capable tools at a base level. Like server functions were so powerful because they're like, I know, like you don't need, like it's an extension. Like I understand people like, you remember that whole thing that was like, you don't need GraphQL, you have TRPC. And then like, but like, so the server function jump was more like, you don't need a dedicated solution to get TRPC essentially. You just have it, right? Like that was the server function kind of sell. So like you don't need GraphQL, you just have functions. Like you don't need an API, you just have functions. Like this is kind of the same thing. It's like people who need sync engines will use sync engines. But for everyone else, you basically get the benefits in a like a data source protocol agnostic way. Well, I mean, right now, if it fails, there's no error handling, right? So what type of failure do we want? There's two types of ways you handle failure. There's failure on fetch, which will be caught by an error boundary, but which we don't have in here. And there's failure on save, which will just not save it, which means your optimistic updates will just remove. So if we were just randomly in here failing stuff, all you would see is like those operations disappear on you randomly. So you're like adding 3 to-dos and then only 2 show up in the list. Right? If you want to, like, you have to decide the affordance to decide what we want to show, right? What's the difference between optimistic UI and data? Just where the things get merged. Essentially, with optimistic, what I was calling optimistic data, it means like the core source coming into the whole application is optimistic, with the server being the source of truth. And with optimistic data, we're doing kind of, or sorry, that's data. Sorry, with optimistic UI, we're just doing individual overlays where applicable. Both techniques can work together. Both techniques are powerful. Yes. Constant catch up with the relay team and working now like 5 years. Oh yeah, GraphQL never fell out of popularity because it wasn't the best technical solution to the problem. It's still better than we're doing here. It fell out of popularity because it was like too complicated. It was too involved. Like relay example usually comes down to like you need to do hoisting, right? Now, granular loaders that you find in SolidStart, SvelteKit, and TanStackStart are very close approximation of this, because what you can do, you can create a pattern where you have your like preload or loader function, and then what you can do is beside your components in your like tree, you can create, you want them as separate files because you don't want them to get bundled together, but you can create separate imports which describe the data loading for that specific component. And then what you do is you import the types from there into your component, and because our types are not going to get bundled together, and then you the actual data fetching piece you import back into your loader. So this way you distribute your loading through the tree, and then you use your data loader to construct a query in which you do the actual thing. There you go. The poor man's GraphQL, so to speak. Add some granular data diffing like I have here. Like you can approximate it with in a bulkier way. GraphQL is way more powerful than that. It has normalized caching. It has, it has a whole bunch of other features. It also has generally 40 to 60 kilobytes for the actual package. And all the infrastructure, the schema matching, all that, like there's so many, way more declarative, because you can, like the stitching of the queries happens from the query language itself, not from some manual wiring. Like there's a bunch of reasons to use GraphQL. But that doesn't mean GraphQL wins. Right? Which, people might say is, this is a different argument I want to make clear than saying like, something like, oh, Solid's better than React, but that doesn't mean Solid wins or something like that. I'm not suggesting that. I'm saying it's not because something's better versus not better. It's because of the complexity. Like the better isn't like a purely, isn't the only metric we're looking at here. It's like the rest of the opportunity cost on a technical stance, not just on a like, does my team know this technology stance, but like on a technical stance is actually has severe implications. People have gone to this in depth forever. I'm a huge fan of GraphQL. I was responsible for doing GraphQL integration at Bitagami, the startup that I was working on when I first created Solid, and also responsible, funnily enough, for doing the framework integration for GraphQL for Marco at eBay. So I'm, a big fan of it generally from what it's capable of, but I understand why people don't use it. Yes. Well, it's a show. I mean, what's more ways to see? Okay, I mean, sure. It's actually pretty painful to TBI to build efficient React integration. Yeah, I mean, I don't imagine the solid integration isn't very nice today either. I imagine there's a lot of things. This is what I've been thinking about though. I want these tools just to be like solid's the obvious choice. Yeah, I mean, this is why we rely on Theo for. This is the state. Relay is incredible. I've never gotten it working right. Like that's the summary. There we go. I went on for like 2.5 minutes trying to like explain it. It's like, there we go. Like I never used Relay. I used Apollo to simulate Relay. It was simpler to use, but the problem was like it was simpler for me to integrate and set up. But when we got to the push comes to shove, when we were actually making the real app and like doing like the what, I wasn't involved as much on the team anymore, and I'm not going to blame the people like who are actually doing the development work here. But I started reviewing their stuff, and I'm like, why didn't you, use this like cache update function? Why are you doing this? And just like, I was writing a bunch of buggy code that kind of worked, but then didn't work in the edge cases, and instead I just got rid of it and it just worked. You know what I mean? Like, and this is how people fell on TanStack routing. It wasn't just like the initial infrastructure too. It was like literally writing the right thing was actually that much more difficult. So yeah, I mean, it's tricky. Yep. Thanks for solid these streams. You inspired Rask UI. I'm curious what you think about. Thanks. Okay. I love to see new frameworks and new libraries come out of this work. It's very, very exciting. We got to keep things moving. So yeah. Oh, you did the relay simulation on Apollo? Yeah, yeah, yeah. I mean, because what's that term when like people are like like kind of like trying to justify or trying to like you're in denial and you kind of like go through the steps of it. like you're like, okay, I'm just not smart enough to get relay working. Okay, that's fine. Apollo basically does the same thing. And then you like go and you like wire it and you're like, okay, I think this is no, I'm not smart enough to get Apollo working that way either. And then you're just like, screw it. I mean, it's real. Okay, no, see, you did get there, yeah. So quick to build on it, yeah. I just for me, it just felt like this like deteriorating set of steps. Like, yeah, GraphQL is great. Like, people shouldn't knock GraphQL from the technical capability because honestly, nothing quite covers the same gaps like the same room. Like if you're gonna like graph it on something, but like, yeah, I mean, there's not much more to say, and there's not much more to say on these demos too. I think I think you guys get it. This was the main thing that I want to talk about. So let's move on to another topic. Let's talk about AI or talk about state of JavaScript or talk about what Ben posted. I don't know. I can close these down and leave without saving anything because I think they're in good shape. This was fun though. I really enjoyed creating the dumb async version. I'm actually super stoked that we were able to replicate the modern UI thing using just use effect. It really goes to show like it's not that even the code is, I mean the code's kind of terrible, but it's not even that. It's just like being able to like work through like the logic and the thinking for the simplest case. You know that your actual apps aren't going to be that simple. So yeah. Right. Okay. Just switching. Cursor solves reactive front line. Yes and no. Not officially, but on the other hand, they never were very public about the fact they were using Solid. I did finally get to talk to them like a year ago about, maybe a little less than a year ago, because I had no clue. So people are like, oh yeah, Cursor uses Solid. I'm like, and they're like, they've been using it for years. And I was like, well, no, news to me. I wish I knew. I mean, we have other teams in our Discord, other organizations that we help and work through stuff with. These guys never thing. And I found out, and he was like, yeah, oh, it was my college professor, big fan of Solid, and I heard about Solid, so I just like decided to build my startup on it. And I was like, that's really cool. That's a great case study. He was asking me how we could like basically 2 or 3 years later how we could improve its app, and in a call I didn't have the context to go through it. Basically the challenge they had was they had like giant stores, like the most massive stores I've ever seen, and the size of the store doesn't really matter that much because each key is a separate signals, so to speak. But they were having TypeScript problems at the time, actually, funnily enough. Because of the complicated types for our store setters, it was actually bogging down their development cycle. And it's so funny because like when I create stores, I'm like, God, the types here will be impossible. I hate TypeScript. That was like what I was saying. And then someone's like, no, I can solve it. I can solve it. And the community came together and actually solved the types or the setters here. It's like one of those things like immutable JS or one of those like things. It's really hard to get the types right for the API that we had, because it wasn't a mutable API. It was an immutable API like immutable JS, etc. Those types are functional. Immutable APIs for TypeScript are notoriously difficult to type right. Things like with partial application and like those kind of worlds. So they solved it, but the problem is like Cursor themselves was so big that the recalculation of the types was just like, it was a very complicated types. It was like dragging down the whole system. Now, I don't know if that's what the sticking point was, or some other stuff kind of changed, but it was just one of those kind of funny things because like different people in my core team had been approached to get hired. They actually, and in community, there were feelers started going out. They're like, hey, come work at Cursor. And I don't think it ever went anywhere. So like, it's one of those situations where like, I wish maybe there was like more communication, or that we could like, I feel like we could have easily solved their problems, but I mean, maybe this just gives them a good use case to demo of how they can migrate from a lesser known framework to a more popular. No, that's not really a good use case. If it was the other way around, that would actually be interesting. Yeah, who knows? Cursor vibe coded a port to React. They haven't said anything actually switching to it. Yeah, that's true. Like, we don't actually know it's successful. I've often said that going to React from Solid would be easier than vice versa because our constraints are more strict, right? So it's one of those like kind of interesting things, right? Because like JSX Lite, if you remember from the builder team, was like a kind of like generate your code in every framework. There's a reason they chose Solid as the baseline for that. I mean, they eventually what they changed it to Solid's rules with React syntax, because they fake they look for like .map functions, but basically treated them like R4s. But like essentially, yeah, it's kind of a yeah, it's interesting. I don't know. I mean, if Cursor had been like a big success case that we'd been pushing down everyone's throats and been like, yeah, and rallying around, and we communicate and talk with them and something, and then it would be a little bit different. But this was more like, I didn't even know you guys were using us, and then now maybe you're not. So I mean, what can I say? Can't help those that don't help themselves. I don't know. So, anyways, yeah, what did I want to talk about AI? It's funny because it's trickier to talk about AI because it's less structured, right? But one of maybe I'll just relay a bit about my experience I've been having, generally speaking, and because I'm probably still going to write an article about this. So sign in with GitHub, and actually I already started working on that article. AI is a game changer. Sorry, but not a ton, but DAX. I've worked alongside DAX previously, if that makes sense. So like from that perspective, like I know he knows what he's doing with Solid, and he actually had some concerns at some point. About like how we worked with sync engines and stuff. And it was good feedback, and it's largely shaping the direction of Solid 2.0. And then he took my response and he's like, yeah, this seems reasonable. And he worked forward through it. And he actually, the open code people sponsored work on Solid Start. 3 developers for like 6 months to work on the Solid Start stuff. So like, yes, very, very different. Even if I haven't like worked in their code directly, and actually open code, big news. Was it Brennolds or Brendonovic? Sorry, from Solid Community, just got hired by them. So like one of the probably our most active and knowledgeable community members in our ecosystem is now working for open code as well. So like, yeah, the completely night and day difference. All right. Okay. What's Untitled? It's like, do I open Untitled while it's on the screen? I don't even remember what this is. Okay, Untitled is literally Untitled. I can delete that. Come on. Yeah, they also built the OpenTUI on top of Solid, which is very, very cool. I love this story, just on the side, because everyone seems to think that React's the only ones that can operate outside the DOM, and like, oh, Solid is Solid is no more a compiler than React, like pre-React compiler was a compiler. Like there's this weird misconception because Svelte did such a good job of selling people on this idea of like you're a VDOM or you're a compiler. So people saw Solid and they're like, oh, it's like Svelte but less ergonomic, but like maybe more performant. And it's like, no, Solid is completely something else. In fact, Svelte is more like React than Svelte was like Solid. I mean, people don't get that, but so I mean, now that's not true. Now Svelte and basically Vue are almost identical to Solid, but like, yeah, uh, it's kind of funny the difference between the surface level perspective and whatnot. Okay. I'm just getting like Discord notifications in my background. I have no clue what it's about, but whatever. I'm gonna check that later. It just keeps on ringing in my ears. Sorry. So let's talk AI, and the reason is because you can actually see my progression through AI through my HackMD, which is kind of funny to me, because in did I ever what did I get to there? I never finished this article. Yeah, no, this article was something I wrote before I wrote the frameworks heading into. Let's signal thoughts. Yeah, okay. This is the last HackMD that I covered on the channel before I went on break. So I didn't know how to approach AI at all. You guys are gonna find a lot about how much of a like idiot or newbie or whatever I am through this. I mean, it shouldn't be surprising anyone, but like I had Anthony on my stream and he showed me a bunch of stuff that was cool and I conceptually got what it was getting at, but like I had no, I didn't understand the terminology. I got him to explain it so people could follow along, but like it didn't sit with me in the same sort of way. I use like some chat, like, you know, in Google search or something, but I didn't even ask it anything interesting. Like I basically ignored it. So the first thought I had was, is it even possible for me to tell AI what I'm doing and it understand what I'm talking about? Right? So this kind of started as like I was like I tried to explain it a bit, um, like the async system, and generate like kind of an article out of it to get people hyped about it, right? What we covered today, and that's how I started, right? Solid 1.0 are delivered one of the fastest, most precise reactive systems in JavaScript. Solid 2 takes the foundation and evolves into something more powerful, more expressive, dramatically more ergonomic without changing the API you already know. Async isn't bolted on anymore. Like it seemed to get what I was talking about. Loading boundaries replace suspense, then they never go back to fallback. First class optimistic updates, you know, whatever. Yeah, okay, I already shared this one yet. So if you guys want to see it, I'll drop this here. I mean, this is AI slop at its best, although it, actually, sorry, that's the wrong link, isn't it? Yeah, that's the wrong link. That's the edit link. Sorry, where's... What? Did I call? Yeah, sorry, that's the wrong link. Yeah, okay, sorry, here's the actual link. Doesn't matter. First class optimistic UI. Optimistic UI no longer hand roll. Create optimistic store. Derive state everywhere without effects. Signals can be derived at their base. Stores can be derived at their base. Create fetch and create sufficient derived stores. Pending optimistic builds is pending loading flags. Stores get a major upgrade. Create storage still, but it participates fully in the async model. I mean, it's not true. It's not quite the same API. Pending is pending is first class state, right? Replace manual loading signals, suspense wrappers, effector and async tracking, ad hoc state machines. More predictable scheduler, same API, radically more power, blah, blah, blah. Okay. So, I mean, so what? Right? And then I was like, okay, can I get it to, I mean, I carried on several conversations actually in Copilot. These are the only things I had that it was worth actually, I was using Copilot and I was like trying to get it to do more like smart stuff. Like I, here's another one. What did I do? Solid 2 DOM, this architecture, talk about eliminating hydration IDs. Like it seems to understand what I was talking about here. This actually it proposes a whole model of using proxy elements, like actual little JavaScript proxies over elements as a way of doing hydration without doing hydration ID matching. And so let's see elements be found in place at insert time instead of searching for them. Like crazy ideas that I hope to do with 2.0. So like I was kind of like, I was like, wow, maybe maybe this is something that I can use. But I the main thing that I wanted to work on, and you see, I just have tons of these. What's this? Yeah, like trying to explain how the system works, like all these kind of like markdown articles. Also, async example. You know, I to actually describe the system, I needed to go through so many details and examples. But what kept on happening was it kept on losing where it was. It kept on drifting. It kept on like forgetting what a firewall is, and it still to this day does in Copilot. Like I still have this one chat that I had running for like weeks because it contained all the knowledge I needed, and even though I made external documents for it to reference, so like it just I got to a point where like I could get ideas from it, sort of like bounce off ideas, and it seemed sensible, but it couldn't keep everything in its head. I actually talked about this on Twitter, right? What's this new async mental model? Is this another one? Yeah, this is probably the cleanest and crispest version of like some of these things, but most of the artifacts I was creating were basically like ways to like communicate to people what I'm working on, not ways to like actually implement it. Because whenever I got into the implementation level, it couldn't keep it, like it would just slip. It couldn't keep it in its head. So you're like, okay, we'll just produce a lot of documents. So that was like my starting point. But like, so like I go into Cursor and try and like dump this stuff in, and it failed terribly. It's the best way I could put it. But I was doing things wrong. I realize this now, but it just like this is just this was not the way to approach things. And as I said, I went on X and I mentioned this, and where is it? Yeah, I did this whole post where I'm like, my work context in your head is difficult to pick your battles in this scenario. Because honestly, I think I mentioned here at one point the AI was like trying to convince me about JavaScript semantics that like literally don't exist. Like it was like they were like, oh yeah, this ensures that this gets queued at the end of the microtask queue, and I'm like, no, there is no possible way. And they're like, yeah, yes, and I'm like, no, you are wrong, I am right. Let's proceed assuming that I am right. Like literally arguing with it on that, like because at first I tried to prove it. I was like, no, look, this example, this doesn't work, this thing, and it was just like, it was like, look, but this example does work, and it's like, no, that's because of this. And they're like it was so sure. And the problem is like when I got frustrated and did similar things on other parts, I actually pigeonholed my design where it like didn't actually work properly. And as I said, the firewall one, just to this day, if I pull up my Copilot right now and ask it what a firewall is, it will not get it right, even in that same chat that I redefined it like 15 times. But the big positive out of this, so, is that somebody I don't even know was all like, Lee Rob, hook this guy up. Like clearly he's not using good enough models, and that's what happened. Lee Rob reached out. Lee Robinson, formerly Vercel of now of Cursor, hooked me up, and suddenly I wasn't dealing with some old free models. I have all the latest models and enough credit to use them to actually test them to decide if I like this thing. So right off the bat, huge thanks to Lee and Cursor, because that was if they didn't do that, I wouldn't be doing this, talking about this stuff here. This completely changed my perspective, and it was only possible because of them. All right. And I mean, maybe this is why there's a bit of a disconnect even there when I talked to the Cursor guys before, and I was like trying to get them into our Discord and talking this, and they're like, oh, maybe you come work with us. I admit I didn't know anything about the AI, and I couldn't care less. So like, No, I didn't talk to him about using. So I mean, I don't know if it's in the same zone of what he does. Isn't he like a education? What does Lee Rob do? Teaching developers. Yeah, yeah. Like I, I, I don't know. Honestly, I feel like if they didn't care enough to really engage us in the first place, why should I care if they, you know what I mean? Like if they kind of go a different direction. I'm not here. I feel like I don't. I know this is such a presumptuous thing to say, but I don't feel the need to convince anyone on that kind of like on that aspect. It's just like it should be obvious, and if it isn't obvious to you, like that's a you issue. Um, I know that's weird, but that's also why I'm not in marketing. Um, yeah, I know. Yeah, exactly, David. I see the stuff. You almost have to read the intro to my next article to actually understand what I'm talking about here. I don't have the full article finished, but I can read the intro. I know I'm late to game, hard to teach an old dog new tricks. I'm the type of person to get dragged into the future when it comes to the tools I use every day. I don't like wasting time fiddling with stuff. When I see people share their setups or talk about their Vim shortcuts, I have trouble even focusing on them completing the sentence. When they show off that they can type 300 words per second or minute, whatever, I just think about all the time and effort it took to get there, and when development has never been about typing. A MacBook, a simple text editor, a couch have always been enough for me. Like, that is me in a nutshell. The When people talk about any of the other stuff, I I get it, improve stuff, but it's just like I'm sorry guys, I don't care. Well, don't get me wrong. I I understand that it's an important part of my job, and I understand that this is a shortcoming of mine. Do you know what I actually did? I asked AI to help me understand better, actually, like because I recognized that I was like crap. I was like I thought about my favorite communicators in the field, and I was like, can you what did they do that works really well, right? Yeah, the rest of the article is going to be great. I'm really excited to finish it. But I so and it's funny this was so beautiful to me. You guys know I like Myers Briggs. I like personality types. Like when I was thinking about AI, I sometimes treat it like a person. I'm like that helps me figure out how to best approach it. You know, like what kind of personality AI has. And you're like, well, it doesn't have a personality, but it doesn't. It has a reasoning center, right? Like it's not an INTJ like me, for example. It you know, I saw a great Theo video the other day, or yesterday actually, where he's talking about getting into design art. And the instructions were like trying to instruct it how to be random enough to appear as if it has some natural intuition. And I was thinking about that. I'm like, there are people in the world that aren't very artistic that you would have to give basically the same instructions if you were going to tell them to produce good art. So like I actually think I think you could Myers-Briggs profile uh, uh, essentially an LMM. I imagine most of them probably fit into the same archetype. The funniest thing, and what you guys are going to be maybe surprised about when I get to that is, I don't think most tool makers are also resistant to certain types of tools, and that's why they can resist to AI. My conclusions about AI are not what you guys would expect, not at all. I think, but I want to get there for a second because the communication thing I was really interesting because like my favorite speakers by far. There's others, so if you're not on this list, don't be offended. But the people that I take the most personal inspiration from in terms of that side are Dan Abramoff, Rich Harris, Evan Yu, Ryan Florence, Kent Dodds, Theo Brown, and Tanner Lindsley. Um, and like I wanted to understand what works about the way they communicate versus what not, what, doesn't work about what I do, or like see if I could kind of do it. And the AI started just like giving me my 4-quadrant graph, and I was like, man, that's so cool. Like it was actually really funny when it was just the four of us. They literally were able to give a 4-quadrant axis graph, like the kind that I love drawing, where like, but it was interesting that the note like the style impacts, right? I talk about models, semantics, inevitability, right? It's so funny. I realized a lot about myself when I was reading through this, because you get to see this on the stream. Whenever I say something, it's to me, I always talk about it like it's the obvious truth. I don't try and convince people. I'm just like, oh, I mean, how else is it going to work? I welcome anyone in the chat to show me otherwise. Like that's usually the approach, right? Whereas like, Dan, very, very different. Reasoning, nuance, introspection. Rich is a showman, he creates a narrative, right? Evan's calmness is very notable, right? Even Ryan's bluntness. Anyways, not super important. I haven't decided if I really want to share this, but it was like really interesting to kind of reflect on this. And this is a completely different use of AI. Yeah, this is funny. Rich Signals' signature move is making simplicity visceral. He doesn't argue that something is simpler. He shows it in a way that makes the audience nod along instinctively. He sells elegance, minimalism, intuitive correctness, not through proofs, but through vibes. Honestly, like this was like, where is it? I almost want to. Where's the? I want to look at the share link of this actually for a second, because the actual readable version actually, I think, does it not have the table of contents? I thought there's a table of contents. It makes it way easier. Oh yeah, here it is. But like, yeah, self risks, self style comparison. Dan narrates the process of understanding. You present the result of understanding. Evan focuses on how developers feel using a model. You focus on what the model fundamentally is. See, like these kind of thoughts. Like Dan makes people feel safe exploring complexity. You make people feel confident about that complexity has a clean underlying structure. Evan optimizes for approachability. You optimize for correctness. Rich makes people feel the simplicity. You make people understand the simplicity. Right? Brian Florence. Florence grounds ideas in production reality. You ground ideas in architectural inevitability. Kent optimizes for learning and adoption. You optimize for conceptual correctness and long-term stability. Theo shapes culture. You shape architecture. What about Tanner? Tanner builds tools that feel inevitable to use. You build models that feel inevitable to understand. AI is speaking poetry. Anyway, sorry. Not to get too far off of this, but like, there's like a lot of interesting things that I did for comparisons, that who clashes, who amplifies, who depends, just to try and figure out like what if there was other people similar to this that like could balance out, or even existing people that could work together and kind of figure out. This is a very INTJ kind of approach to things, but again, interesting use of AI. But let's move on. The cursor work actually was interesting because, I mean, let's go to the signals repo. Because I tried, and I'm still trying and failing pretty badly. A couple things, but let's look at my commit history. Yeah, I guess it starts around here. You can actually see because my commits jump way up. I started on this work in progress, refactor graph, and then set baseline for optimistic. This is like my third rewrite. I'm going to do optimistic, right? And then everything from this point on was AI driven pretty much. there's a couple things that weren't, but pretty much from this and the commits. Yeah, action test suite. Where was it? I'm trying to. These ones, yeah. So where was it? Implement community transition integration. This was kind of crazy because the difference with working with the good model was for implementing new features. Refactors I have not had much luck at, but implementing new features with a strong spec actually worked surprisingly well. As long as I didn't try and make it chew off too much, it was worth. It actually implemented create optimistic, then create optimistic store on top of it, and then is pending and pending. All the features that let me show the demos today, like the last two, the AI implemented with that, with basic instruction, and most of them, there's corrections and stuff. The one that blew my mind was create optimistic store. I literally left it for lunch and it created it, which is probably the most complicated one that I had. And it was complicated from a development standpoint because stores have a lot of touch points and they're buried, they're proxies on top of dynamically created signals, and you can layer stores on stores and like that. But the key was I just create and get it to help me create dozens and dozens of test cases. So many test cases. See, and I realized the thing was my work is very well defined. It's hard to create. It's complicated. There's so many aspects that conflict when you're like, how can you do this when you can do this? People tell you it's impossible. It's like solving a logic problem. It's like the thing where you have like 20 statements and you have to say who lives next to the guy in the yellow house. That's essentially what my work is here. And AI is really good at solving logic problems. So as long as my specification is good enough, well, the baseline that I put on was literally just showing it where to put the functions. I just like put the skeleton, like put this here, put this here, put this here. Like it was just like, I just wanted to kind of like go like, this is like to do implement. Like I just wanted to kind of like show the API so that like the test suite could at least be written using the API. That was like kind of like the thinking. And like during the conceptual planning time period, I definitely had to correct it a lot and thing. And honestly, with the latest work I've been doing, I've redone it like 3 times now. I think it finally got it this morning. I haven't been able to vet it. Because what ended up happening is I implemented all this with the AI and we got there and we posted stuff on Twitter. You guys saw one of the examples, but there's actually, I realized my model's not quite, it's too simple. There's actually another case that I didn't take into. If you trigger async on optimistic updates right now, we treat very logically, we treat it as being optimistic and we flush it right away. We're just like, look, you've opted out of the transition. Now you're in optimistic land. But I was shown some demos almost immediately after I posted it where async could also suspend in its own sub-transitional channel, which again is like very complicated to implement, but is incredibly powerful because then like it's just one less, like I could solve the problem they were solving using the existing primitives, but it wasn't intuitive. Whereas this model, everything just works. So like it was definitely the right move to go, but it means that I'm basically redoing the work from the last week again with a slightly different model. And I was trying to like refactor on top instead of build from scratch, which has been a completely different experience. But generally speaking, the work I do is hard because it's impossible to keep the full context of every possible thing that could happen in your head. But those things define a model, not like a vibe. Do you know what I mean? Like when people go in and they go, I want to create an app that does this, like that is very open to interpretation, you know, and you can add a bunch of specifications about what those things are. Yeah, you can be like, oh, you know, but when they click this button, this happens. But it's very results oriented. You're creating a model for maybe human behavior or human interaction. You're not creating a model for how the code executes. This is incredibly low level. It's like the model is like very specific to to the actual architectural interactions of the pieces, which means that if it's not well specified, if it's ambiguous, then there'll be edge cases. So the hardest part about code and code that changes is the work to write test cases and good documentation takes incredible amount of time, because you're like, why? Like, that was the cost thing. Like, I hate unit tests because they always break. Not because necessarily the code breaks, but the expectation break, or you know what I mean? And that's kind of what the AI is good at solving. I don't need the AI to figure out what to do. I already know exactly how everything should work. That's never been my problem. My problem is, well, I mean, it is a problem because at a certain point, like, you don't know completely how things should work until you try them. You have a suggestion, you have a direction. I always have a direction. That's a better way to phrase it. But I don't always have the time, like, to implement it all and rigorously test those edge cases. I rely on the community. I rely on the Discord. I rely on these streams to show people ideas so that people can poke holes in them and go, what if this? What if this? What if this? What this? Because all of that interaction helps define a better model. Because what I'm working towards isn't a product, it's an inevitable truth. So, like, from that perspective, like, my biggest bottleneck, and a lot of people in open source field working in the libraries, is actually resources, because you can't just, it's like R&D, you can't like just like throw people, you don't, if you don't have money, you can't throw people at solving the problem, you know. My AI use is not cheap. Not at all. I was like, this is very dangerous for me, because like, if I get used to this, I'd be paying too much for this, right? Like, it's crazy to have a friend, let's say, that can just start thinking through and implementing anything I think, because I've got lots of ideas. I mean, they're cheaper than getting an actual developer, but like, I still probably can't afford them. But I was surprised, and I realized that I was thinking about things wrong, because I was thinking like, oh, you know, how could AI possibly solve these very difficult, intricate, you know, patterns that are so low level and blah 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 and complicated and good thing. And it's just like, my work is actually not that ambiguous, right? There can be a flaw in the model that you can see, and that deciding that is the ambiguous part, like from like what the behavior should be. But the actual work itself is very clear cut, more clear cut than pretty much most things that I like. If you're building an application, there's way more room for interpretation. If you're building a product, there's way more room for interpretation. I mean, I'm on the $200 plan for Cursor, but I mean, it looks like I have a set number of credits there, and I'm burning through them like crazy right now. I've been using Opus 4.5, which is probably with Cursor why it's an Anthropic model. Somebody in the chat, the funny thing is I didn't spend time to test different models. I literally, somebody in Twitter was like, use Opus. And the second I used Opus and got like started going, I was like, okay, this is different. ChatGPT, or not ChatGPT, sorry, GPT 5.1. Sorry, why did I say ChatGPT? It was actually, and still to this day, feels like I can talk about something like in the abstract and it can jump there. Like those articles I was writing, I still go to GPT when I was like, my model's not working. Like, what am I thinking wrong? This is what I want to happen. And then they're like, oh no, you need this. And then I'm like, yeah, I thought about it, but I didn't think that could work. And they're like, no, if you do it like this, it can work. And I'd be like, yeah, okay, yeah, you're not like, it can't work like the way you're saying, but you've made me realize how it could work. Okay, thank you. Opus, my interaction is not like that. It's more like it's like this beautiful puzzle solver that I just have sitting there going like, okay, if this does this, this does this, this does this, this does this, then this, but oh wait about this. Okay, well, we could do this, but then no, okay. I think that I read the chat logs sometimes, because literally it sounds like me talking to myself in a monologue, and it'll sometimes go straight 10-20 minutes just contradicting yourself. So, well, we should run the tests and verify that. Yeah, test fail. Oh, right, of course, because of this. Yes, it's kind of crazy. I mean, it's funny. I wonder if I could turn off that output somehow or something. I wouldn't like, I would save money or something. But reading it completely changes my perspective on the AI because its reasoning is sound, which is it's just a very different place. My biggest problem with it usually is like I have to interrupt it all the time. I read something when it's thing, I'm like, no, you're wrong. This, and they're like, oh, like, and then they go, yeah, because of this. No, you're wrong. Like I feel like I need to cut in and interject like a ton so that it doesn't go off track quite often because it can make the wrong assumptions fairly early. Um, so sometimes with the UI, I'm like, I worry because sometimes when you stop an operation, like it loses track of like kind of what it was doing on that. Like it remembers the conversation, but it loses track of what it was doing in that particular thread that you interrupted it. So you kind of like don't want to interrupt it if it's been like kind of deep, but then you're like, God, if it keeps on going down this path, it's going to go somewhere bad and like start. Like I've had some mishaps where it's like reverted my code base and stuff when like it misinterpreted what I asked. Um, so I learned to start committing very often, which is partially why you see so many commits here. I didn't like merge it down. Whenever I get to like a certain level, and also not to lose context. Like sometimes like it'll implement something, all the tests will pass, and then I'll put it in a real app, and it like doesn't work, and then I'll be like, if I don't commit where that was, and then start debugging on that specific thing separately, it'll like get confused and sometimes like treat the whole implementation as the manifesting bug. The problem is if I go too separate, it doesn't have the context to work off of to actually fix the bug properly. Like sometimes it will get deep down the bug and it'll be like asking me how functions work that it just implemented. So yeah, I mean, that only happens usually when it gets to a point where it's like sometimes you get stuck, right? It gets to a point where it's like, oh, yeah, this didn't work, so I undid this. And you're like, no, the whole point was to do the thing, right? Like it basically undoes something that was literally like the goal, like written out in the plan. It just decides not to do it. And you're like, and they're like, oh, okay, well, would you like me to continue on the thing that I just decided to undo arbitrarily? And it's like, yeah, this is the reason we did this. It's in the plan. Follow the plan. And it's like, okay, well, so I started asking more interesting questions. Like whenever it got stuck like that, I'm like, is there something missing in the plan? Why like you can't solve this, And sometimes it'd be like, yeah, like you stated this, but it's actually this. And it's like a very subtle detail of like, oh, you status not pending versus pending notification. But, I refine the plan and then hopefully, I've actually recently with this refactor that I've had our time reran the same plan, updated each time from scratch, like 3 or 4 times to actually get. Sometimes during the process, I find other bugs in the system, and then I fix those bugs, set that as the baseline, and then try and do the plan again and see if it gets there. You might think that all of this is wasted because couldn't I just like write this myself, right? Like just roll up my sleeves and write the code. And the truth is, the most valuable thing that at the point that AI can implement it, maybe I could write it as fast. But the most valuable things that it does is force me through the process of doing the planning and creating the proper documentations and tests. The signals repo went from 200 tests to 500 tests in the last week. And most of the tests are asking on new features. I probably had tests on older features now still and kind of thing. And this makes you feel much more confident, in the behavior. I'm not 100% confident, but much more confident. So this is interesting, right? Because this is a tool that I wouldn't have expected to be particularly useful to me given the complexity. But if you can find a way to make the work piecewise enough, unlike I think a lot of software, the requirements are very the requirements are actually very straightforward. Yeah, sorry. Let me look at chat here. Dom Ganaways for the yeah. Opus 4.5 is so yesterday. Thank you. It is a real game changer for his work. Yeah, codex models are quite something. Did you try them on? I'm assume I know nothing. Are they just? Oh, you mean like the ones that have the word codex in the name? Not I had sometimes it points edge cases that it doesn't know the answer to, but most of the time I'm the one double checking. I'm like, okay, so does this make sense to you? Is there anything I'm missing? I make those kind of prompts fairly often to try and refine the plan down, and then be like, like it doesn't completely work. The current system that I'm working on right now, the one that fixed the get to the final boss level or whatever here, is the most complicated that we've come up with, right? It's the idea of having transitions with multiple bendable optimistic lanes. But yeah, I don't know. It's still struggling a bit through it, but it's crazy though, because I love what I get out of it, because I think ultimately over the course of the week, if I didn't use AI like this and I just went at this myself, it would have taken slightly longer than a week. It's not, but the act of me sitting down and writing the code myself is going to be about the same, or ish, because of the amount of corrections and like debugging and all. But the amount of time that I can stay focused like that, maybe it's age or whatever, is not as long as it used to be. I don't stay up all night and program anymore, So a lot of my work is actually mental, like strategic, like structural, like things in terms of thinking and planning, so that I can like focus in on when that work happens. And in that sense, better plans, better documentation, all like fit. Like basically the AI is letting me generate stuff of that nature at a rate that I could never accomplish just typing myself. Right? I still need to review it, obviously, but like it's like so much faster. So like it's not about how complicated or hard the problem is, as the guidance post here for handling AI. It's I actually think like the ability to how like well you can specify the solution. I mean, this is obvious, right, when you think about how it works, but like is actually the biggest thing. And we all like to think that like kind of self-important, like we do work and like great work or whatever, but um yeah, I mean, people don't pay me for my programming. And I think AI made that very clear. Ooh, 5.3 was supposed to be built to be better at handling interjections for what it's worth. Okay. I mean, yeah, because I feel like arguing with it a lot. Instead of interrupting it, stop and start fresh with additional info that ensures it doesn't make the same mistake again. Yeah, I mean, to be fair, I don't know how most people use this stuff. I'm still very conversational. I don't like, it's not like I get everything in a single prompt. I wouldn't even know how to write this stuff to the level of detail. Like I I need it. Usually the process involves me describing something in a couple of paragraphs, it regurgitating it back with its understanding of the system that it analyzed, and us going through several iterations of corrections until finally making a solid plan. And it's during that process often that I'm doing the, like, I guess it's the implementation that I end up interrupting it more on, but sometimes the planning. Codex equals GPT 5.3 codex from OpenAI. Yeah, I haven't tried that model yet. But yeah, it's interesting because I think the social aspect, like what it personally means in terms of my perspective as being a developer, is probably more interesting. But I don't know if I want to share all of that yet because, as I said, I'm writing an article about it. I think it's just important to report at this point that places that are challenging for AI are not probably what people think. Like a lot of people are like, okay, AI is great for like vibe coding prototypes that you throw away, which might be true, but I I feel like that's actually like what do you call it? Like an excuse or something. It's more like AI is really bad at that. And that's why you have to throw it away. Like it, the stuff that AI is actually good at is not the work that a lot of people are probably doing. I think it's actually uniquely good at working in the types of areas that I work in, simply because what I'm looking for out of it isn't actually that different than what it like is designed to do. I'm looking for pattern matching, reasoning, and what's the term when you like span something out, like expungation or whatever, like AI is much better at working in clean, organized, mature code bases, or probably small, very small, clean, structured kind of things. The problem is AI becomes the source of the dirtiness. Whenever I get to a point where I'm like going to merge a major feature, like I got like everything together, I spend a lot of time with it cleaning up and then talking through it. And then even when it's like, oh, I can't clean anything more, I'm like, I can clean more. So I go in and I clean up more. And then I when it comes to like the real thing, I mean, I don't. There is a side effect here, and part of it is because the increase in structure. But the signals library was 2250 lines of code, like the actual like build output, before I touched the AI, and that was missing a couple of last features. But let's assume that, with my thinking compared to like version 2 or version 1 of the rewrite, we get to about 25 or 26 right now. With the latest stuff, which I think is finally mostly working, it's at 2,900, 400 lines of code more than I really was hoping to get to. And I hit that code earlier, optimistic stores. It's not its fault. It actually solved optimistic stores properly where I wasn't. It actually added the override layer, not just to the signals, but to the actual like underlying data objects. So like the stores now have the base value that's immutable, the override, and an optimistic override. I wasn't going to implement that. I was just going to write it into the override and kind of hack it, and it kind of work. But there's bugs that come from that. So it actually solved it correctly, which added like freaking 150 more lines of code. So like, I mean, take it as you leave it. So I mean, there's a bit of that aspect, but often a lot of the size optimization stuff involves finding reasonable shortcuts you can take, and the AI doesn't take shortcuts. So it does kind of lend to bloat. Of course, when we're talking about bloat, it's hilarious because I'm like, oh, this will add 0.1 kilobytes minified gzip to your bundle. Most people would pay that. I just, I'm very aware of it. I've made apps more robust than the big company who used to work with the teams over 6%. Yeah, I mean, that's the thing. You simultaneously get the way to delegate work. Like it does feel like you're working on a team. The kind of, because I'm only using like one agent or whatever to time or whatever, it feels like time that I like created the React Native app with like one junior dev, like smart kid from college, very capable, maybe doesn't know how front end frameworks work, like doesn't know React, but that you could write it yourself, but then there's all that other work and it would take time. So you it's okay, the delegation. That's what it feels like sometimes working with AI. In certain ways, I'd be faster on my own, but on the other hand, the end product's going to end up bigger and our total bandwidth's like just slightly, like 20 or 30% extra or whatever. And so it's like something I'm on a small team. It means my responsibilities change the same way it did when I was on that team, right? When you're solo IC, it's very different than being a team lead. And I mean, I know this is kind of like projecting out, but I mean, I wouldn't be surprised if like it could scale up past that to the like closer to my actual like type of roles that I start doing later, where like being an architect, and then you're not even touching the development. I could picture that. What do architects do? They produce freaking documents. I mean, that's the specs. That's basically what I have to do. So there's a lot of similarities there. I can definitely see that if you know how to specify your work and you have the right sort of assets to drive it on, that it could do that. That being said, I do think specifically because what my work speaks in models and not in like user experiences, the ability to be able to specify is way more like I just I should, as I said, the feeling when implemented optimistic stores and I dropped it into that the optimistic data. Remember the optimistic data example with the to-dos? I already had the optimistic UI version working, but when I dropped in the optimistic data, and it didn't work right away, I had to actually get it to fix like a bug or two, but then it like went and thing, and then it just worked. I was like, how? Like, this is something that I was like struggling for like, I meant like past Christmas break, like a week or so, saying, okay, with this model, how do I make this work? And I came up with a hypothetical plan, but I didn't want to pull the trigger on it because I was like, I need to think about this more, because if I invest in this, I'm going to waste, days, probably a week of time to actually vet it. And then like, it's probably not, I have to make sure I'm right. Otherwise, like, this is a problem I have with a lot of the research I do right now, is because it's like, I don't want to afford not investing too much and not being right. I'm very conscious of the timeline on Solid 2.0. I'm very conscious on like people supporting my continued work and development at Sentry and like Netlify before them, and like I want to make sure that every time money comes in the Open Collective, and like when we were doing the work on like the island stuff, like we ultimately didn't deliver on the product that I wanted to, and we weren't in the place to. I always felt like like I know there was no way for us to get there, and we learned a lot and we got Cerebell out of it, like the investment from the Chrome team, but I felt like we didn't deliver, and so I'm very conscious of it. And AI was like, well, why don't we just try it, right? Like, it's pretty well specified behavior wise, even if you haven't figured out how the implementation works, let's just try it. And then the AI is like, okay, yeah, it wasn't that hard to implement. Sometimes it is, sometimes it is. And I looked at the code, I'm like, oh yeah, of course, right? But like, that's sort of the scenario, and why I find it, I think that it's very useful in the sort of work that I do. Exactly what I'd love to get from you. A markdown with all the best patches solitaire to make the apps use of solid. Well, yeah, that's funny, because as I said, that's exactly what I don't specify, right? But like, I mean, AI could help me generate that doc, perhaps, but like, you understand, like, that's more about like extension on user behavior versus like mechanics of what the model work. Anyways, I mean, it's why R3 took so long. Yeah, exactly, because I didn't want to just like, I there's an when the coding is what costs money, there's an opportunity cost. Like, when the actual work of doing the physical typing costs money, there's an opportunity cost in trying to invest in different types of things, right? So if you can eliminate the documentation overhead, the spec, like if you can eliminate a lot of those costs, the rate at which we can iterate and improve rates drastically. And as someone, as I said, idea person, someone like driving like that the way I do architecturally with models, how can this be anything but a game changer? I'm actually kind of worried that like the characteristics it has are dangerous actually to someone like myself. I used to have like when I was a kid, my parents said I was addicted to video games, and I've definitely have had problems of being too much in my head, and this is probably the biggest amplifier like of that kind of zoning, and like that it yeah, I mean, that's again a personal topic and probably something I'm going to write about, but it's 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 crazy. I haven't been excited about something on the technology front like this, and it's funny because I was such a late to it in years. Like, um, I get it now, which is weird. It's not what people think. I don't know why no one's been very good at communicating what it actually is, though. Maybe it's because it's different to different people, but I feel like I feel like, and even now when I'm saying it, I understand it. What I'm describing it sounds very vague. Anyway, that's probably enough on the AI topic for now. I don't know. Anyone have any specific questions? I think I pretty much covered my main perspective other than the personal impact piece and like, but yeah, I do want to clarify. Like I still feel like very much at the beginning of my journey here, and I still have more work to do. All right. Let's look at this month in JavaScript here. I think that's probably where I go left. Give me a second. I'm just going to set up some windows. Give me 2 secs. I said AI is the right acronym with the wrong definition. Well, the thing is, like, when I say about technology, the last time I felt the same way about technology was when I was a kid and was first exposed to the internet. It's that long. I'm not talking about like the same kind of shift like when you know, mobile phones or whatever, touch screens or something. This is I mean, I guess phones had an aspect of it. It's about the availability of information, but it's similar, but it's now that it's not only one direction. Okay. Let's see here. Sorry, give me a second. I just want to set up my windows properly because I think that's that one. Okay, let's do 1, 2, 3. This one will be solid. This one will be my bookmarks. I don't think I actually bookmarked very much this month. Yeah, it's funny. The only thing I ended up bookmarking was stuff related to the cursor stuff actually, I think. Anyways, let's get into this week or month in JavaScript. Let's go. It's funny, I don't even know what if I even put this banner up anymore it even matters. But let's go. I thought this was fun and interesting. jQuery reaching 20 years old. January 14th, 2006. So, yeah, I mean, obviously ground shaping technology in the web front end world, but yeah, it's funny. It's been so long since I actually used jQuery directly. I think the last time I touched jQuery was in 2009. But actually, no, that's not true. Some of the early Vitagami stuff, some of the WordPress stuff I touched in like, yeah, but maybe 2013, 14. But it's one of those things that like has a lasting impact that like can never be understated. All right. But what else did I bookmark here just before I get into other stuff? All right, this was about the cursor experimentation where they mentioned the script for moving. Yeah, sounds like cursors move to React is going roughly as expected. And I've been using remove unnecessary React to use effects. Yeah, that's interesting. The weird thing is if they were migrating from solid, you wouldn't expect them to have use effects. Right? Like if you were migrating from solid, a lot of your oh, I wonder though actually now that I think about it. If they were doing stuff like state synchronization without derived, yeah, it's interesting. I don't know. My gut would be you would have less use effects in the first place, but who knows? This could be who knows. All right. See, I don't have much of the way of bookmarks here. Unless they used it incorrectly, which is not, I mean, Yeah. The usual use effects of pet state based on a trop. Yeah, I'm always that. Yeah, I've been really trying. That I'm so crazy to me that no one just got rid of that, ages ago. I mean, I would have got rid of that in solid 5 years ago. To be fair, I identified that primitive that I wanted to like do that like back in 2022 back in like the solid work group. It's fortunately taken a very long time because 2.0 got delayed by a solid start and like working on server stuff, and now we're here. But he fetched an on mount. Oh, yeah, yeah. I mean, you, you, what is it? You can't take the React out of a developer. Oh, that's what I was saying. You can take the developer out of React, but you can't take the React out of the developer. Is that what I want to say? Yeah. Okay. I'm trying to remember the solid news. Yeah. And stack dev tools. Yeah, it's cool. Yeah. Ben's been posting some content on Solid just because of the 2E stuff he's been doing, which is awesome. See that. I miss Theo's content on Solid from back in the day. It's cool to see, and new frameworks in general. It's cool to see that kind of stuff kind of come back in. Attila's talk, yeah. I've been so heads down on the work that I have not been keeping up here. It is always cool, as I said, I like highlighting when I see libraries that work just generically in Solid. Like someone flagged me on this animation library. What is it called? Auto layout in Anime.js. Yes. So they're like, someone's like, does it work with Solid? Apparently, yes. So like, that's awesome, But yeah, TanStack dev tools also work with Solid and Spas. You can see the common thread here. Okay, let's talk about let's talk a little bit about the JS survey right now. It seems like the best thing because I actually don't have that much content. I mean, we could talk about the Astro-Cloudflare thing, which apparently I didn't bookmark, but I don't know if I have much to say other than just like, that's awesome that Astro gets to continue on, and do its thing. And Cloudflare's, there's a lot of benefit from both sides, I think, from that kind of move. It gives Cloudflare like a way of pointing at like a very generic, usable, we are the web kind of meta framework. And it, I said this on stream before, and I don't like, no offense to Fred and them all, but like I had no clue what they were selling. Like I love Astro, I love the framework. I have no clue what the Astro company did. So I mean, this seems like a good resolution for everyone, right? Astro needs people who actually understand DX. Yeah. No, exactly. Or sorry, Cloudflare. Yeah, not Astro-Cloudflare. Yeah, exactly. I mean, I think this is kind of the thing. There's the DX team, like Igor and all of them, who've been working on like improving like the dashboard and all that. But yeah, I think there's a certain disconnect when you're like like a lot of the hosting providers like Netlify and like Vercel are kind of like hosting providers. That's what they do. Cloudflare is not like, they do hosting, but Cloudflare is a network provider. It's like almost like they're working at a different level, but that extra level of abstraction or like separation from the stuff means that they probably classically to date, except for like a few key individuals or teams in the groups, have generally been a little bit more disconnected from the general goings on of like the web front end. Right? We had Igor on talking about his micro front end solution. Like his team definitely tuned in, but like Cloudflare in general, I don't know how much influence they have on the whole thing. I mean, I've always found Dane great, but like I don't know how much like there's a lot of technical initiatives going on Cloudflare that exist outside of like our typical web framework stuff, where I feel like Vercel and Netlify, because they're not like as wide, are a little bit more focused in those areas. I think like legitimately, I remember having a conversation with some guys there. They're confused. They're like, why aren't more people using durable objects? And it's like, I get it. What they do is incredible, but like, how do people use them? Do you know what I mean? Like there's this gap. They're like, oh, we have this article. I'm like, look at how people are actually developing. Like there was a gap. Like this. Cloudflare had the capability of doing streaming from the edge before like literally everyone else. Like I jumped on them as soon as I could. Like I was like it's the technology is there. It's just yeah, you know, distribution as a service. Yeah. So yeah, I mean, it makes a lot of sense. I know obviously I love the guys over at Cloudflare as well. They've always been big, you know, like at least the people there that I know that were being big for the open web and all that. So it's like, yeah, I mean, oh yeah. You guys know me. My birthday is coming up very, very soon. A bunch of our birthdays are coming up. Oh crap. Yeah. God, today, Feb 6th, it's is it Rich Harris's birthday? Um, yeah. You be surprised how many people in our community have birthdays in this week. I think it's Rich Harris's birthday today. Um, anyway, yeah. Yeah, I wanted to talk about. Sorry, got sidetracked. I wanted to talk about. Yeah, I talked about this. Yeah. Is there anything more here that I want to talk about the AI topic first? I think I've watched more Lee Rob videos in the past few hours than the whole time he worked at Purcell. I've been an AI skeptic. I'm giving Cursor a real shot. Yeah. It's funny though because he has a bunch of introductory videos that I literally just like tried to understand because I watched some of Theo's stuff and I'm like I don't know what the hell he's talking about. So I went over and watched Lee's stuff to get like context of like what the actual terms were and like how to use stuff. And then I went back and watched a bunch of Theo's videos. That was my process. But the funny thing is after that happened, I started seeing Lee everywhere. Every time like I get a YouTube ad now, like 50% chance that it's going to be like Lee talking about something Cursor. Like they're paying like their promotion or whatever that they pay into the ads on YouTube are definitely working. So yeah, it was just funny. Like over like 24 hours, it's just like Lee everywhere. Rich was in Paul Rockets doing awesome stuff there. Yeah. All my references are from mid-January to mid-February. Yeah. Aquarius apparently is supposed to lend to a certain type of unique or unconventional thinkers. So anyway, yeah, no, I've been very happy being able to have this kind of ramp up thanks to Lee and Cursor. So yeah, I think that's it on the AI side. Yeah, we talked about the examples. I'm going to talk about Ben's thing in a minute. Yeah, let's go with Save.js. I actually haven't reviewed it that closely. I saw the front end framework. I don't care about the other sections too much, but oh, I didn't even see this thing. Solid may this is funny, library be used by 10% of respondents, but the fact that it's had the highest satisfaction for 5 years running should be enough to make us pay attention to what it's doing. What's more, Solid Creator Ryan has been a large responsible for operating concepts such as signals and one of the best to explain the intricacies of other front frameworks too. Well, that's nice. I didn't even notice this clip when I opened up the page. I'm like, show me the charts. Um, yeah, I mean, to be fair, we're 9%, we're 10%. I was really excited to be 10%. I'm not gonna lie. Do you know why? 10% is when you get to go on like the S tier chart. But do you know what happened? We're not on the chart. We're not on the chart for some reason. And I'm guessing it's a rounding error. I think we show 10%, but it's probably like 9.9, and we didn't end up on the chart. I mean, we're 89% this year, so we would have been A tier. Last year we were 90, it would have been an S tier, so it would have been nice, but I kind of wanted to be on the chart. Yeah, off by one error, yeah. Like they even said in the description it was the 10%, and then they're like, the rank charts libraries based on the retention ratio. Percentage users use library most. Note that libraries used by less than 10% of survey response are not included. It's wanted to be on the chart. Okay. I'm gonna come back to this graph after we look at the other stuff here. Let's start with front end frameworks. Yeah, usage, no surprise. The funny thing I'm finding about usage is this isn't actual usage, just this amount of respondents. These numbers are just kind of stabilized. Like I guess React went down last year for some reason, but like these numbers are not growing. It's like 80% of developers who surveyed used React in 2019, 85 now in 2025. But like, let's pick one. Angular 56, 48. So there's a slight drop over like 7-year period, and they had some lows and highs. So last year would have been 50. It's still like if you look at back here, things were like rising. Like only 50% of responses in 2016 used React. What were they using? I don't know. 10% using Vue. By 2019, it was 46%. Nobody else has that kind of curve. You know what I mean? It's like a spiral graph that starts out with some point out here. Do you know what I mean? Like Preact was 12% back in, like they had a little rise from 7 to 12, but they've been 12, I guess they're 15, they're up slightly this year. But like these are almost all flat lines. Svelte had a good growth curve, but even the last 3 years, 25, 26, 27, right? Solid 2%, 6 to 8, 9, 10. Same as Svelte, 8, 9, 10. Preact we already looked at. Lit 7, 9, 10. Alpine 7, 8, 9. Like no one's moving on the usage chart. Just kind of throwing out there. Awareness. This one always surprises me. I mean, I get it. Solid and HTMX are about the same amount of awareness with Preact slightly about. Svelte has somehow got like they jumped ahead of us on, or like Preact and everyone on awareness. Somehow more people know about Svelte, especially compared to usage or whatever. Like compared to all the other frameworks that are like kind of in this lower usage tier, the awareness difference is actually significant, which makes me wonder if like awareness was higher on some of these solutions, would their usage go up? I don't know. It's just yeah, flatline on awareness as well. No one, like what I'm getting at is no one's really gaining ground out of pollsters. Interest, this one's always tricky. Interest goes down over time slightly, right? Mostly flat. Who is that? There's someone else who's pretty quick. Oh, that's a pretty sharp interest drop off. I was gonna say like there's this where it's like a couple percentage down. Like if you look at React, it's like 57, 40, 42, 40, 34, 27. I mean, React's definitely plummeting on interest. It's not flatline. You think there'd be like I was expecting more like Angular, right? Angular, people are interested in it, then they like lost interest, and then you kind of flatline at a certain threshold, right? React hasn't hit the bottom yet. I mean, I bet you 27 is the bottom. I bet next year there'll be like 28 or something, but like, interest, keep in mind, is people who don't use the framework that want to use the framework. Like it's positive sentiment about people who've heard about it but haven't used it. But yeah, generally these are all downwards trends. No one's peaking high though, right? Svelte has kept consistently the thing that most people want to know about or are interested in who haven't used it. And I think this is probably the biggest driver of why out of anyone they're actually seeing usage. But I mean, again, this doesn't necessarily translate on Solid side because we've been second in basically in interest this whole time. It's only slightly less, and that hasn't translated. So yeah, I don't know. I don't know if there's much to get from these graphs on this side. Satisfaction, typical smaller frameworks, switch the rank thing. This is the graph that we use. Again, this is the one where we were the most high satisfaction framework 5 years in a row. React's, but again, Svelte second most. So I mean, like these are percentage difference. People generally happy using either. Quick one. So HTMX. Guess people realized Vue. I called this in my article a while ago that like I was the 2024 year article. I was like, my feeling is that Vue sentiment has increased, just because they keep on delivering. Angular is another one that I expect like that. Yeah, no, that's Preact. Where's Angular? Oh, never mind. People in this poll don't like Angular. I was expecting more of a bounce back. There was a bounce back here, like signals and whatnot, but I expected Angular to have like, I think the sentiment in Angular has gone up considerably, but Preact coming back is interesting. I think this is largely because, again, it mirrors React's satisfaction kind of dropping. The thing is, this is by rank. Let's remove rank. I want to go back to value. Yeah, React satisfaction dropping is very minimal. But Preact, I don't think they made any drastic change. This is the funniest thing about this. I don't think they made any drastic changes to how they work. They didn't like fix an issue or do a new release. I think it's simply the fact that what you're seeing is people who were like, Preact isn't worth it, versus React, to people going, Preact is worth it. I think that's what the shift is, because I don't think it's like from them going, oh, we've made our DX way but nicer. It's just like more people finding the opportunity, like, so that they're just like happier, like their expectations are more aligned. The biggest thing with satisfaction is about aligning expectations. Yeah, I mean, you're right. This could be Preact signals. Yeah. Yeah, I mean, Preact signals came out in 2022, 23. Yeah. I mean, it could be downstream of that. That's fair. I always underestimate the impact of signals there because you guys know what I think about that. But yeah, maybe Alpine. People still use this thing. React, Quick. Such a shame. Lit, yeah. Angular, Stent. Stencil still being on the list here is using its own thing. Appreciation. Ooh. Gap between interest and positive sentiment, and satisfaction. Okay, so this is an interesting one. I've never really looked at this one. This is one that I thought like Vue would be better. But look at this. React actually is highly appreciated. So is Alpine, and so is Preact. Interesting. What does this mean? Okay, so if I'm understanding, this is the difference between people who have used it satisfied and people positive things. So you actually want a lower score here, which is funny because this means like what this is saying is like this is saying how much people who like use it I'm trying to think of how that actually this is a very interesting kind of thing because it's I think it's suggesting that more people are satisfied with it compared to the people like the hype around it or lack thereof. So I think people lower on this chart, like this is like almost like this is like the things that score highest on this chart have less hype, and the thing that's are lower on this chart have more hype. It's like hype versus appreciation, like how much people actually like it for what it is versus people who are hyping it. That's the best way I think I could think of this. Low hype and high satisfaction scores. Yeah. Exactly. Yeah, exactly. So in a sense, Svelte is very like from this. There's a lot more hype contributing to its positivity, even though Svelte has like the highest satisfaction or second highest satisfaction, but proportionally, yeah, that's interesting. HTMX, like, yeah. Oh, this is interesting. This is, even though this is like this kind of almost looking at this chart in inverse almost gives you an idea of where the current things are in the hype cycle. It's funny that Angular was actually down here. This is like almost on the opposite end. I doubt Angular was actually that hyped. It was just like so bad that it, in a certain way, that it ended up over here. Stencil, yeah. It's like overrated. Yeah, it's almost like an overrated thing, but like lower here is overrated versus underrated. So like Preact is the most underrated solution. So is Alpine, and then React. See, it almost makes sense. Then Vue is pretty much in the middle, where you know it's you get is what you get. Solids in the middle. Then we start getting to like HTMX, Stencil. I lost Quick somewhere in here too. Quick, yeah. Anyways, I don't know. Positivity. Another one that tends to go down in time. Stencil. Quick needs a release. HTMX. Solid went down a bit, then came back up. Vue. Yeah, maybe this is the one I'm looking at. Vue and Angular are kind of, we're defying the odds. They're kind of going against the trend. Everyone else is going down, Vue and Angular. Svelte's kind of stable, but Vue and Angular have both kind of, yeah, that's interesting. I don't know if I'm going to find as much. Astro joins for Cloudflare. I'm not sure if I'm going to find as much as interesting here. We all know that Next.js just dominates everyone else on usage, but interesting. It's not. It's much lower now in interest. Svelkit, Astro and Svelkit are strong here. Solid start in what's that one? Dino or kind of like mid. Satisfaction. Astro, Svelkit makes sense. Solid start. I'll take it. I'm glad that people who use it are satisfied. I know this isn't as strong of an entry as Solid itself, but I hope to change that in the future. Yeah, I don't know how to read appreciation. Positivity. Yeah. Yeah, this one's a little less interesting. Yeah, Tanstack didn't quite make the list. I think when Tanstack does make the list, it's going to be a bit of a game changer. Is Gatsby even on this anymore? Quasar? What's this one? Gatsby. Yeah. This is like the perfect. Like maybe we should use this as the model of what like the decline looks like. Actually, Gatsby's appreciation went up. I guess because like the people who are left appreciate it. This is brutal. Like people make fun of Angular sometimes, but like Gatsby's fall was just way, yeah. This one analog. Yeah, the fact that analog got on here and Tanstack didn't is odd. Yeah, exactly. Gatsby here is now creating packages for Tanstack. Backend frameworks I don't care about. Okay, let's go back up here and look at the curve. The curve is one of the most interesting ones because everyone boomerangs over time. But you want to be out here. You want to get up here. Vite is just an unstoppable force. They look like they were starting to curve, and they're like, nope, nope. We still have more to go. Versus Webpack, which is like, let's see if I can, which is like this just almost straight sideways back. What do we got here? Just, can I filter this down to what I care about? Yeah, I just want front end frameworks. Yeah. interesting pencil drawing. See, React is like the only one up in this quadrant, which almost makes it the only, in some ways, the only one worth talking about. Like in general, it's just, this is sad that the others can't be up here. Angular is like doing some circles over here where it's like trying to come back, and then 2025 is like reality check. Okay, not quite. Vue is, I don't even know. This is a weird dance. Vue looked like it was like actually shrinking. I guess before Vue 3 really kicked off, it was actually like shrinking, like not just getting more negative, but shrinking. And then it's like somehow turned things around. Svelte, this is, again, it's just one of those unfortunate things where you want it to get farther over here before it turns back, but we're getting stopped before we even go. Solid. See, somebody asked me the other day what, or they were talking on X, like they're like, I wish Solid was more popular, you know, more people used it. And I was like, it came out 2 years later. And the problem is the timing, these curves are very reliant on the timing that the thing came out. You can actually see this, like in 2022, almost everything either halted or started going backwards. Like 2022 is when Vue actually went down. React's different because it's more popular. But like if you look at everyone else, it's like Preact. Actually, Preact is an exception on the 2022 case. They actually jumped out. But what do we got here? HTMX. What a weird, that's just a straight hockey script back. No, people aren't even going this way. Any, like before it used to be like you start a little bit and then you go like this. Anything that's come out recently is just like immediately backwards. Like where's Quick? There's HTMX. Stencil. What? I don't even know why Stencil's Quick. Almost straight backwards as well. Solid's funny because we were doing good and then 2022 came around. We're actually curving back. I guess we're having to come back. But you understand, like what I'm getting at is like you're already kind of like, it's really if you don't get over low enough early enough, it's hard to ever be able to make a wide arc. Right? Like if this usually, this kind of shape just means is usually considered like a fail to launch. Now, if you remove React from this graph, this image looks a lot different. Like if you put the X like down here, but it's interesting. I'm super stoked that we actually went fairly steeply back the other direction. Preact did too. Yeah, it's interesting. I wonder if we can see more of this as React gets like more criticism, things that are similar to React get the benefits. Anyways. Oh yeah, Remix or React Router wasn't anywhere either here. All right. Oh, that's Solid 2.0 talk. No, the thing that impacts this is not Solid 2.0. The thing that impacts this is more like open code or TanStack adopting Solid and stuff like that. I feel like that has a bigger impact on this because our interest hasn't really gone up. Our awareness hasn't gone up. This and our satisfaction is just held thing. This is purely a result of usage improvement. Although that doesn't make sense actually because our usage. Yeah. Yeah, actually this suggests that it's not about usage improvement. This suggests that it's actually about positive sentiment. Yeah, so maybe you're right. People who don't use Solid are now being more positive about it. That's actually what this suggests. Huh, interesting. Right? That's interesting. I didn't actually look at the rest of this stuff, so I didn't actually see how, just from my curiosity, we look here, Fireship number 2, yeah, syntax, good old Wes. Newsletters, JavaScript Weekly, podcasts. One thing that I'm wondering is, where do things like, is this where front-end masters? Oh yeah, it's right here. Yeah, free code camp. Okay. Epic React. Huh. Didn't realize there's, okay. Yeah, I mean, huh. Syntax made a jump here, eh? This was always like Prime and Theo territory before. Actually, last year Theo wasn't ranked as high. I'm sort of surprised. JS Party. Where's my... I love PodRocket. PodRocket should be higher on this list. Whatever. JavaScript Jabber also. But yeah, syntax is the name of the game. Video creators. Oh yeah, maybe this is the category I'm thinking about. Yeah. Fireship, Theo, Prime. Yeah, that makes sense. Syntax, Jack Harrington, slightly down. Ooh, I'm a video creator now. I guess I did create videos this year for the first time, not just streams. Well, thank you. I fell this year. I'm usually, oh no, never mind, I'm a fifth. I'm usually on this list. Yeah. Me, Evan, Rich, Theo, Dan, Tanner. Nice. Can't see. It's funny, a lot of the same people that were in my list that I was analyzing. Daniel Rowe, great guy. That Dominic. A lot of people were in my list that I was looking for inspiration for in terms of like public speaking. Anyway. Okay. I don't know if I have anything else. I don't know if there's any other interesting. What's on PodRocket? Is this Rich's podcast? Sorry, you're gonna make me open it now. Yeah. Oh, nice. Yeah. Rich is also using the term async first. Yeah. Nice. Yeah. That's good. We actually have a common banner we can rally under. That's cool. I actually am gonna want to check that out, I'm pretty sure. Nice. Yeah. No. But yeah, no, there's definitely a movement going on there. Okay, yeah, okay, let's I think there's only a couple more things to wrap up on if there's nothing else on that. He talks about how Solid 2.0 async model changed after looking at Svelte. Yeah, completely. Yeah, huge influence. It took both React and Svelte to change my mind, but yeah, I'd seen Svelte, but I didn't like believe it until it really actually took React for me to appreciate Svelte, which is funny. But yes, yeah, definitely. Yeah, sorry. What I wanted to look at was thread. Was there something else in here? Bookmarks are done. Yeah, right. There's not much going on with Solid that I posted. Yeah, okay. This is funny because I was gonna prep more for this stream, and instead I got like sniped because I saw this. Someone tagged me in this thread, and I was like, "What's going on?" Ben Dave's like, "I can't believe I'm about to start my OpenAI shilling and React defending arc. How did this happen?" React defending arc because of LMS being good at React. That and React code bases actually scale really well. The component-based reactivity is annoying, but it actually saves you from many foot guns. Signals are objective correct solution, but they require a really good engineer to manage, understand, or an architect, and can blow up in your face hard if used incorrectly. And then there was more. I thought it was on one of the comments on this one. There was a follow. Maybe it's off this chain. What did Theo do to you? Yeah, I mean, I was thinking that too. Uh, uh, there's actually a comment that I responded to that was further down in the change, but I can't actually, I can't. Was it? I thought. I'm not going to find it right now. I actually found it when I actually wrote my response. I actually quoted it, um, but I'm not finding the that part of it. I'll give you up only because I saw a JS video. You work with the overture. Okay. There was another comment about talking specifically about like explaining what this meant a little bit more. In any case, I thought I wanted to share some of my thinking about scaling signals. So I wrote a little something. The component reactivity model is annoying, but actually saves you from so many outcomes. Signals are objective correct solution, but they require really good engineers to manage, understand, architect, and blow up in your face hard if used incorrectly. I'm going to focus on this comment because I've thought about this a lot over the years. So yeah, let me kind of talk a bit through this. I have to admit, obviously, that my experience is biased, but like it's interesting. The longest time that I was working on a single team like was actually between 2012 and 2020. Essentially, I spent 8 years at a company on a single team. Like I've spent 8 years at other companies previous to that, but I moved around a couple times on different teams. And that team was built by the guy who created Knockback JS originally. He's the one who did the hiring. He was the one who set up the team and continued the original project. So Knockback being the marriage of Backbone and Knockout JS. And so we had a dev team that basically used signals with like by the end, like some of the people who were still around by the end, like 5+ years of experience of using signals based stuff on production apps. And so we had this really strong culture there. And while it took a bit for new devs to get used to it at first, it wasn't really a problem. We hired a lot of like college grads and interns too. Like there was the core team that kept the things going, like the main developers, but then we also brought in a lot of like young people, mostly because we were very close to UBC, the university, and back then people didn't really learn React like the comp sci or engineering. Like you might do a final fourth year project where you might like pull React in if you're fancy, but people didn't like learn React. Like they didn't even do much web dev, as part of like their coursework or whatever. So like there wasn't like we got a lot of like open slates from a CS background where we actually taught them how HTML and CSS worked. We could hire them cheaper and we banked on their potential essentially. Um, and we also, as it turned out, used React Native for mobile. I spent a lot of time there working on performance, which is a completely different note. React Native circa 2016-17 was incredible because what it did, but it was also like, it was the funniest thing because there's like the hyper example of like where React's model was not okay at the time. Like they moved past that, but it was like you were thinking about performance all the time, every transition, every animation, every like list management. Like the APIs were like they had very specialized components to do like you didn't just do dot map if you wanted to do a list view. Like you had a grid or list component that you used. And it's kind of funny because a lot of like the criticisms people have on performance and stuff, like this was like it in your face. Um, Funnily enough, from a lot of people, because I'd already started Solid at this point, and I was kind of moved off day-to-day dev, and I was now the hiring manager, and like I was basically director of engineering at this startup. Um, not basically, I was. When it came to us doing like our big rewrite that we were planning, like the big upgrade, we actually chose to get rid of our reactive solution and move to React in 2018. We actually, yeah, flat list. And even that wasn't good enough for people. Yeah, I made my own virtualization system on top of their pre-made thing to handle like infinite scroll. We did image grids. This company, Vidogami, was like a Instagram for schools, like privately hosted kind of thing, facial recognition, all this kind of stuff. And we did lots of like we did image and video products, and we did a lot of image processing kind of stuff. And our app obviously was just photo grids, you know. So a lot of my experience, that's what I said. I spent 8 years basically working in a version of social media. That's kind of like a big part of what makes me like my where my experience bias comes from. And it's funny, I was no longer in the trenches. I was like a management, but I was like, Solid wasn't ready. It's funny, my CEO was like, let's bet on Solid, let's do it. And I was like, you guys, you know, it's not there yet. People don't use it. I don't know if anyone's gonna like I'd released it by that time, like in 2018, like, but like, you know, and it was getting hyped because it was like on the benchmarks and stuff. But like, I was like, I didn't feel comfortable. Like I didn't realize, like it was in this weird window before React hooks came out, and like, or maybe just around when React hooks came out. So I was like I remember it was like in that kind of zone where it's like I was like, I didn't think anyone would like our team was reactivity based. So like they when they saw they're like, this is the future. This is so cool. But like I was trying to be sensible, so to speak. So I was like, let's move to React. And I was like, we can also get like more of those college devs, maybe, you know, or like boot camp, not just college devs. We get like boot camp types, you know, hire them easier, kind of, you know. The funny thing is, college grads actually cost more than bootcamp grads, because like even if they don't have the specific experience, they have like their ceiling on their potential is much higher, which is why we like them. Like we could get them, maybe if they did some UI work, they might even move into facial recognition or other stuff. Like they were just generally purposed that, where bootcamp grads were like a lower dollar point in expectations, you know, generally. Like there's always like potential there, but like it was a very different kind of thing. And every time we interview someone, it's like, oh yeah, I have React experience. Like, I mean, well, we knew we'd have to train them anywhere anyway. So like, who cares? You know, like at least they knew what HTML was. So, and the funniest thing is when we finally, you know, I worked with the database people, architects, and we planned out the schema. I worked with the designers, and we kind of like had the plan in place, you know, and you know, each team was like set on what they're doing. The main UI team, led by guy I trusted the most, who I worked with for a very long time. He had a lot of new bootcamp grads on his team. Is him and another guy. Like he took over this like rewrite, and the funny thing is, they moved so quickly. I was surprised. Obviously, it was greenfield development. You can't take into consideration they basically was starting from scratch, but they built up the UI to like major sections within a couple of weeks. So they had everything, and then we used Preact, I think, originally, because it's smaller and performant and whatever, instead of React. We ended up moving to React later, just because like gaps in stuff, and we wanted to use some React libraries anyways, not for like components or anything like that, but just it was just like, actually I guess it was on features. I was trying to remember the exact specifics of it at the time, but anyway, I was kind of amazed at how fast. Like I was optimistic, but I was like, this is incredibly fast how quickly they threw this UI together. Um, but then development slowed down drastically, and over like the next like month or month and a half, deadlines started shifting and expectations and budget and stuff. And they're like, at first they're just like new technology, new people not familiar with, you know, this stuff takes longer than we thought. But then I decided to like get in there and like see what was going on, you know, like console log or whatever. And I was like surprised. I mean, the UI was kind of showing up, but it was completely broken. Like they would update something and it would re-render like a dozen times, and I'm not kidding, like more than a dozen times. I remember counting one of them where it re-rendered, like you click the button and it re-rendered like 14 times, and um, like the, they were swallowing errors because the bad practices, and not enough overview. Don't get me wrong, but where people were like the like basically writing code that swallowed errors and it displayed correctly, but like it didn't actually function properly, or like hit like a thing, and then like parts of the UI would just be dead, but like maybe you wouldn't notice it. It was terrible, and they amassed this debt like within like a month into the project, and I was just like, and some of the comments I got from like the lead dev, he's like, I thought hooks would be like signals, basically. He didn't use the term signals. We even called them back then. But he's like, but the thing is different. I have to like really, like, when I just do the stuff, it doesn't just work. Like it kind of works because it like just re-renders, but like it doesn't update when I expect it to. Like it's like, I'm like, I made a joke like, should have used Solid. He's like, yeah, I don't know. I'm like, maybe. I'm like, you'd find an issue with any software. It's okay. Don't worry about it. But it was like, it, it was very. He found it really weird using React. Oh yeah, the sunlight. Oh yeah, it's coming in a weird angle. Give me 2 seconds. A bit better. And basically, this is around the time we made a bunch of decisions. We're like, okay, drop React, and like, because I think we were having some problems with their error boundary or suspense boundary component, and that was part of why the errors were getting suppressed, but no one has spent the time to like realize it. And I was like, pick a section and go through. It's top to bottom, and yeah, you don't have to get rid of all the re-renders. Re-renders in React are kind of expected, but like let's clean this up so that we at least have some level of like we can actively work in this stuff. Like make sure that the top most areas, like the root hierarchy things, aren't overrunning too much. If you get down to the leaves and it re-renders a couple times, don't worry about it, but just work from the core down to kind of reduce the amount of this, find those key moments. It's funny, they were using GraphQL as well. And, like spend some time to actually work on this rather than just trying to keep on delivering the features. I know you guys have a tight timeline, but I'm going to vie for us to just put a stop and like spend like 3 weeks to get stuff in shape. So like there's a definitely lack of React experience here. This was like a skill issue. Combine senior devs without much React dev with juniors that had no clue, and you end up with this. Seniors assumed you could write stuff and just React would do reasonable things, which it kind of did. The juniors had no clue what was going on and only were worried if things appeared to work properly. I told them that while they didn't need I meant to say throw away they didn't need to throw away the API is what I meant to say. I was in such a rush to read this. They should basically start over and doing a sweep modularly to fix each part of the app until there's ran. Expected this took a while, but after a few weeks, things were much better placed and ironically more aligned with the estimates of how long the features would take. Common things, yeah. Okay, so let's go back here. The things the experience showed me. Most developers are more used to imperative thinking rather than declarative. You can vet this yourself if you have a college engineering background. How many people truly excelled at FPGA programming versus typical C-style programming? If you ask someone to say make the game of Pong in each, which would they find easier? If you know what I'm talking about, you know what I'm talking about. But if you don't, that's okay. But basically, FPGA is like a circuit, digital logic circuit kind of programming. It's almost like signals, but actually literally the electronic analog for it. And I found, for me personally, I found it like very fun and easy to do. It's really cool because you'd hook up to these boards where you'd have like hardware interfaces, and you could literally like you'd have a screen and you could literally like make like old style arcade games with it. It was great. And it because it was like the way the logic ran was much more literal to like you weren't running routines that would like it was very directed to like updating the pixels on the screen versus like some level of abstraction. Anyways, but yeah, it's all about clock cycles. And when you do like VHDL programming, all that, like every clock cycle, the system is synchronously has to be in sync with each other. Like there's no before and after. There's just tick, 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 tick. Anyways, people gravitate towards solutions that make it easiest to see positive feedback earliest, even if the overall cost will be much greater on them. Right? Like if they see the thing, they're like, okay, good. Right? Like they didn't care that it wasn't really working. They could just like kind of see the UI. Wrong assumptions hurt us regardless of the direction it is, whether that is experienced devs treating React as if it's knockout or vice versa. Familiarity plays a bigger role on preset biases than anything else. Okay. So let's talk a bit about difference to architecture here. I've talked about this before, but I don't know if I did a good job of explaining it here, but all reactivity systems involve propagating updates from the point of change to outputs, or sinks, depending on what you want to call it. So there's a simplification that comes with saying reactivity equals UI. That's my interpretation of the React model. Some people have a different idea. Basically, the UI representation in React is also data. So basically, like, it's all shares part of the exact same tree. There's no distinction. In fact, the output that React expects is UI, not the data, but it is UI data, right? You basically virtualize what you want the UI to look like, and then React takes that virtualization and compares it to the reality and reconciles it. But it means that the output gets entangled essentially because it has to produce this consistent artifact. While in components, there is no boundary to the reactivity. The key. So you can trust that when something above invalidates, everything below is re-examined, including all the UI. No one can argue with the simplicity of that model. This is the premise React is built on. It's like when Jordan walked in and was like, let's just throw it away, and people are like, that's crazy. They figured out how to make it performant. Like generally this would be prohibitive from a performance standpoint, but they developed this solution with the virtual DOM that actually means that this model can be relatively performant. So if we stop right here, like I think, and this is where a lot of people kind of stop. You can say that like the original statement is true. There are a lot less foot guns because there's a lot less room for things to get out of sync. Because literally, if you're doing everything, what can go wrong? The only problem, obviously, is like you do too much work. But let's face it, if every time something changes, you're like, I'm going to redo everything with that change. It's kind of like the approach we were talking about taking to AI. Like if it's not getting there, just start from the scratch again, and inform it a little bit better this time, but let it rerun to its natural conclusion. Better than trying to do incremental things. Unfortunately for everyone, the idealistic thinking versus reality doesn't match. The performance isn't good enough. Otherwise, people wouldn't use memo, react.memo, use callback. There'd be no React compiler. But an even simpler way to think about this is in a model where everything has the potential of re-rendering, and you're okay with that. It's okay to be okay with re-rendering. You need to be okay with keeping the temporal impact of those changes in your head. Like if something upstream changes causes your component to run a dozen times, if you're trying to debug what is wrong with your component, you have to be able to either ignore the times that those updates don't impact you, or find ways to justify and explain them within your mental model, right? This triggers this to rerun, which causes this to rerun, which will cause us to rerun again, and so on. Like, because usually it's like a fan out problem, right? Like it's some kind of timing piece where your component depends on the change, something above you also depends on the change, and that thing above also filters down into you. React's way of directing synchronous updates generally can ensure like consistency through that, but sometimes when you have to externalize the data through hoisting or even through different paths when you consider context, you can get into spaces where like the pure part, like the part that computes your components, can be a little bit sporadic, even though React ensures that the output at the end is consistent, because they're not going to flush to the effects until everything is settled. But you might have a bunch of unsettledness while that's going. So of course we can fix this, right? We can fix the re-renders. Then the lower components can function more logically, like things farther down the tree. But this introduces two concerns. First, now you have to look upwards. Like if you're in the component, you're like, why is this re-rendering? Like you're going to be like, okay, if this is something you want to fix, this is what I meant. Like if this is something that you're completely okay with, then just learn to live with it and ignore it. But if this is something that you need to fix, the solution is not found within you. The solution is found above. You can't manage your component in isolation. Secondly, the solution is often one of two patterns. You either have to structurally hoist up some data dependency so that you can wire it more directly, or add memoization to stop propagation. And Dan Abramos, before your memo article, honestly, so did I share this in chat? I should have shared my article in chat first, but Dan's article here is really good because he actually shows both this. He made an artificially slow component, and then he says move state down. But the way he did this was actually through projection, lift content up. Yeah, sorry. Yeah. So move state down. This you can't always do, but lift content up is actually how he shows it, where he, through projection, he basically, I'm trying to think of a way to, I'm not going to get into the gist of this article. Instead of putting the expensive tree here, what did he do? Oh, yeah. He passed it through the color picker. So then the color picker can see, the clever trick here is because now the color picker can work independently as much as it wants, because it doesn't really care about the children that get passed in through projection, and the expensive tree works in isolation, whereas before the stuff all kind of got tied together. Yeah, he puts it in the slot, so to speak. Right, exactly. Which through projection actually solves it. And that's actually what I was trying to talk about here by structurally hoisting things up. It's like this is moving content up, so the data dependency is more direct. Or the other option is add memoization to stop propagation. Dan offers a third option, which is move state down, but you can't always move state down if it's shared. It's not easy. Dan's, so the first solution sometimes it's hard because of UI structure constraints, right? Because even if you can do that in a lot of cases, there's going to be cases where it doesn't structurally make sense to do that kind of weird, like that kind of like separation. I view this generally as a workaround in a sense, as it acknowledges that the UI structure isn't always the best representation of the data structure. Like, because you wouldn't naturally write it that way. You're doing it because you're trying to wire the data flows and get around React's limitation. But the second solution, the more common one, introduces a whole new layer of complexity. And this is the complexity that React hooks put forefront. This has a few repercussions. Once we start memoizing, we need to keep memoizing to ensure stability. Once one broken thing in the chain then the equality check doesn't happen, and then, you know what I mean? Like, and it's now possible that changes don't reach us for reasons that we are unaware of from above our scope, which is actually a lot like reactivity, to be fair. But it's something to keep in mind. We no longer can just look at the code in our component necessarily to make sense of things. There's no actual problem with any of this, but it should be an acknowledgement that we have lost some of our ability to locally reason. We are largely at the mercy of our parents. Okay. How does this compare with signals reactivity? Really, it's the same problem, just upside down. In the same way React hooks made us painfully aware of memoization, signals make us painfully aware of reactive propagation. Say poster also posted, signals are wires. You can send them all over the place and end up constantly rerunning some derived state 5 components over if you're not careful. Signals are hard to keep track of, components aren't. Yeah, what I kind of disagree about the components aren't bit, right? The benefit of components is you could, in the sense that you can trace down the tree, so you know the extent at which it can impact. But the challenge is, or trace up the tree. But the challenge is, you still have the same sort of categorical problem. What did I say here? It starts as the start of this is pretty accurate. Like in the same way you have the responsibility with memoization, you do so with how signals propagation works. Signals are automatically memoized generally, so you think less about the problem, but it's still there. Yeah, like you end up constantly rerunning some dry state 5 components over if you're not careful. I this suggests like that there's something that's not being equality checked, or why is it, if it's derived it should update. Like it's one of the hardest things about talking about this comparatively with React is, if in a lot of cases with reactivity, if this has happened, it's exactly what should happen, because it's literally the model by its definition. If you're deriving data from other data, you expect it to update. So usually the problem manifests itself not from the point of like you're doing something and then like you're like, why is this slow? And like, oh, it's doing some work over somewhere else. Usually it's the opposite. Usually you're looking and you're like, why is this updating over here? And then you go, you're trying to trace back to like what's causing that update. And you're like, oh, this prop. But the funny thing is, like when it's in the component tree, when it structurally aligns, like this process is almost identical to what you do in React. When you're using a bunch of external sources or stores, then you might have some issues, I guess. But is that any different than, say, using Jotai? Not sure. But let's continue here. Funnily enough, when debugging the story is actually really similar, it just starts from the opposite end. Is this intuitive? Maybe. Not based on your prior experiences, but is this any more complicated? I don't think so. The problem is basically the same, but it manifests itself a bit differently. Since signals are automatically memoized, you're less likely to have stuff run off re-renders, but the opposite, things just not updating when you expect. You lost reactivity somewhere. This lends to a much likely to break early model, whereas React will let you go further, and then you realize the mess when the performance hits you. This is sort of what I was getting at about it's not what he wrote here, but it's much more common with a signals library for stuff to just not update. Like, you're like, why is this not updating, right? It's like a reverse default, but it means that the second that you break the thing, it stops working. Whereas in React, it will kind of work, and then you realize later that, oh, this is actually like completely broken, but React did a miraculous job at like hiding that, like making it kind of work for you. I wouldn't want to be debugging any system with these sort of issues, right? Obviously, it's not always our choice, but one is more likely to not get yourself in bigger trouble by letting you delay handling or noticing that issue. Localization of thinking is present in both models and comprised similarly when it comes to performance. I recommend reading my article, Thinking Local Signals, to see the parallel here. Not enough people use or have read this article, especially people who read signals, who use signals. What the whole idea here is, a lot of people get attracted to signals for the wrong reasons, and there's no and those same people are the people who are like, why did solid force me to use tuples, and why is solid you make me type these extra characters instead of just mutating everything in spot, and why are these verbose APIs? Like, I might be poking a bit at some of the Vue and Svelte community, but it's like, because React isn't stupid. Like, React has very good reasons for the design decisions. Luckily for you, you don't have to give up the benefits of React by going to a signals model. Signals can be completely scalable if you use them well. Just like, like, you don't want to abuse React terribly, like, like any solution. You just need to have some structure. And sometimes if that structure is built into the defaults, then you've set people on a much better path. So like the true answer is that there's lots to learn from React. I've written several articles about what people should learn from React. But even knowing that doesn't mean that I think this is actually a flaw in signals design. I think it's just like, it's kind of like a perpendicular, like a orthogonal consideration. Okay. Takeaways. Theoretical models diverge from idealist models in practice. I think it's pretty obvious. Preset experience has a bigger impact here than technical consideration. Skill level bars are often set at the point of entry rather than looking at things holistically. Easier to get started is a decent metric, but it doesn't tell the whole story. So what does this have to do with skill and scalability? Well, there are some intrinsic qualities here, especially noticeable at the surface. The overall picture does not suggest the same. It's possible to abuse any pattern. I'd argue easier to abuse ones that are more permissive up front. My experience tells me that when thinking of scaling, we should be thinking a bit longer term, which suggests that a different value things should be valued. But I recognize everyone's experience and requirements differ. Okay, so I didn't really like tear down this perspective completely, except like I gave the points you needed, but I didn't like conclusively say, and this is why this isn't true. I think that it's not that you require a really good engineer to manage or understand architect, and that it can blow up in your face hard if you use it correctly. Like the last part, it can blow up your face hard and use it correctly, is true of any solution. I don't think this is more true of React versus Solid or Svelte than anyone. So the question actually is, does it require a really good engineer to manage, understand, an architect? And I think the answer actually should be yes for all of the above. It's just that React lets you get away with more, so you kind of lie to yourself to think that you don't. So, I mean, this will put different value for different people. How much do we care? It's a very different question when you ask about quality. This is not a comment on the framework. It's a comment on the quality of your product. Because technically, you should have good engineers to manage and understand your architect. Using React does not save you from that, because it will bite you. It might not bite you quickly, but it will definitely bite you, right? If my anecdotal story is there. It's not because it's React versus Solid. It's simply because you can't, there is a model that you should be following, and if you don't adhere to the model, then bad things will happen. So I think the challenge here, and often when this discussion or point is brought up, is like, this isn't a scale question. It's like it's not about scaling in the sense of like the size of the project or like the effort or complexity of the project. I think there's actual reasons why, from a scale perspective, you might want to not, or choose something other than React. It's more of like a question of, like, when I read this, I'm not seeing about scale. I'm seeing scaling people, not scaling products. And there is a difference, even if those two things are related, because scaling people suggests that the expertise shouldn't exist, but it doesn't. It has a real factor on the quality of what you're building. So like, if you're, the easiest way to put it is, if you have a choice between making something, and I'm going to use extreme cases here, make something that does the function, but is basically unmaintainable and is slow, but you were able to complete it quick enough because you could hire cheaper resources with less experience. At what point do you draw the line between that and something where that's of higher quality? I'm saying the framework isn't actually the deciding factor there, beyond the fact that maybe it enabled you to do something you couldn't do before, which is build crappier stuff. I know, it's interesting. But like, you understand what I'm saying? If you're saying but good engineers are scarce, then you're basically suggesting that good products are scarce. Right? Like, a tool having there's an importance about a lower entry point in terms of learning and all that stuff. But I think having a lower bar for passability and quality is not necessarily a good feature. At least it's an unfortunate reality. It's not something that I get on a soapbox to advertise. You know what I mean? It's like, okay, let's face it, what I'm building is not that important, or like I just need to get in front of people, limited funds. I like there's tons of business reasons to make that decision, but there is no technical reason to do that. And that's the only reason why I got into this conversation, because this suggests, even though like it's not saying it's a technical, they're saying it's like a hiring or skill issue. In a sense, like that's why I can't completely disagree with the statement on a certain standpoint. The more accurate reality is if you don't have the really good engineer, an architect, it will blow up in your face. Like it's not a matter of if, it's when. So if the number of foot guns is not actually less, it's just a function of when you hit them. You just have to choose whether you pay the cost, pay a cost up front, or pay a slightly large, or pay a larger cost on the back. And for most types of products or business things trying to start up, you're fine deferring the cost. So like from a business standpoint, that could make sense. I just don't I don't even think this is I think you hit this issue at the level that this is a concern, almost at like almost at the same time. Like that's the key difference I think here. I don't think like one is drastically better than the other in terms of like when you hit this, because like that was what my technical thing was. I think you actually, one might be more in your face, one might be less in your face. You might be ignore things, but the reality of when it becomes impactful to you and your business is at the exact same point. So, like, it's more of like you might be able to go like, I can ignore this a bit longer, but the impact is felt at the same time. So it's not like you it's not like you it's not like it's something that you can push off in terms of like, oh, React lets me get further before this becomes a problem. That's not the reality. The reality is it becomes a problem at the exact same point. The ways to solve it are basically comparable. It's whether it's it's like, can you live in the in like the filth longer? I feel like that's a question. And I think that characteristic from that argument standpoint, then I could see an argument against signals based frameworks, because there's probably a lower limit for garbage. Yeah, it's not just yeah, it's yeah, but it's not even just about becoming visible later. I think that that's what people assume, and that seems like a reasonable trade-off. I actually think it becomes visible sooner. Like if people, again, I guess it takes knowing what you're like. If you don't have a good engineer, then it's not going to become visible sooner. But if you have someone, I mean, it depends. Performance, someone testing it, QA, like someone will notice. It will be visible, apparent, if you actually use the product at the exact same point in time. And the solution could be, it's just like, are people paying attention? symptom of more bad management. Yeah. So like, I don't think they require any better of an engineer. I don't think you can get away with React with a garbage engineer. I think you're fooling yourself if you think you can. This is both a testament to me, people underestimating the capability of React engineers, perhaps. I think I, and also overestimating engineer. Like everybody uses their tools slightly wrong. Like if you ask the creator of those tools, so like there is a decent amount of leeway in any tool. So like what we're talking about is very, very small margins. Enough that I wouldn't even be able to enough to put a statement behind it. I mean, if people want to get into the technicalities of like what it actually looks like to debug or that, we can go into that. But like you kind of get that like we're talking about the thinness of margins, and even then, um, like yeah, I it's maybe it's like too easy or too compelling to come up with a narrative to justify like a business thing. I've always wondered by like why people try so hard. Like I feel like often when like with these kind of technology choices or things, you have to like really come up with like a hard justification of that. I understand not everyone uses, as I said, every tool is principled, but it's like there are a lot of similarities, and the differences are subtle and nuanced enough that they aren't likely going to be appreciated by anyone who's not um, the same good engineer you have here that could understand architect. So like you could talk about like better defaults or like more reasonable default behavior, but like that doesn't feel like a scaling question to me. Like it's scaling in the sense of people, but not like you could think of a dozen arguments the other way. It's like if one hand components re-render everything, then everything is entangled in a sense, so things get more complicated. And you can say that if your reactivity is signals based, it's isolated, so the bad work that someone does over here probably won't impact the bad work someone does there. If you give them their little wedge, it's actually fairly hard for them to break out of it, right? Stuff flows down, um, but which is true of React too, right? Like if your component down here re-renders 10 million times, it's probably not going to cause components higher up to re-render unless there's like some data architecture problem that's like coming in that's worse. You know, like there's too many ifs to be able to make this sort of generalized statement when like the reality of these things is like memoization on reactive components, and let's say through something like hooks and an actual like signals based reactivity system are very analogous. There's a difference about where the stuff flows through, but you have this, and maybe the concerns are turned on their head, but they're the same concerns at the same point, at the same thing. This is just like there's a structural thing you can kind of see and visualize it. It's like in the same zone. Sorry, I went off a bit of the tangent. I probably lost a bunch of you guys. But I think that's probably it for today. I just wanted to kind of talk about it because I got completely hijacked. I linked some good articles on the topic, and I don't know. I got more async work to do, sync work to do, get everything going. So it might be another little while before I do another stream. I'm gonna keep on pushing AI, see what I can do with it. Um, and hopefully today gave you something to think about. Yeah, yeah, I am so done. Yeah. Everyone have a great weekend. Thanks.